Setelah melakukan analisis iklim setempat, diketahui bahwa kecepatan dan arah angin berbeda untuk kedua musim. Pada musim hujan, arah angin dapat menuju dua arah, yaitu utara atau selatan. Sedangkan pada musim kemarau, arah angin cenderung mengarah dari selatan ke utara. Dari analisis iklim tersebut, maka diperoleh orientasi bangunan rusun dan letak bukaan agar efek ventilasi optimum. Sistem ventilasi pada rusun ini sudah dirancang agar kenyamanan termal di dalam unit rusun dapat tercapai dengan menerapkan stack effect ventilation. Stack effect di ruang atap berfungsi untuk mendinginkan suhu udara agar dapat mengurangi atau mencegah peningkatan suhu ruang di bawahnya. Desain fasad bangunan dirancang untuk mengurangi panas di dalam unit rusun. Elemen-elemen tersebut meliputi peneduh eksternal, jendela dengan kisi-kisi untuk mengoptimumkan inlet udara, balkon sebagai zona thermal buffer yang dirancang untuk menghindari radiasi matahari langsung memasuki unit hunian dari segala arah. Prinsip radiant cooling pada rusun ini yaitu dengan menggunakan PCM untuk menyimpan panas ketika siang hari, dan ketika malam hari panas dibuang melalui radiant cooling berupa PCM atau phase change material yang dipasang di lantai. Selain itu, material insulasi juga dipasang pada atap untuk mengurangi penyerapan panas. Rusun ini juga menerapkan teknologi removable walls dengan tujuan apabila ingin merubah posisi jendela, maka dapat dilakukan dengan membongkar pasang dinding seperti Lego.
Direktorat Bina Teknik Permukiman dan Perumahan melaksanakan penjaminan mutu. Salah satunya melalui audit persyaratan mutu dan pengukuran rumah susun hemat energi Kota Tegal, agar sesuai dengan persyaratan mutu bangunan. Kami berharap proses pengukuran termal eksperimental di rusun ini dapat memberikan kepuasan penghuni dan mendukung bangunan yang hemat energi untuk tujuan pembangunan yang berkelanjutan.
Hasil eksperimen ini diharapkan dapat menjadi referensi dan standar untuk perancangan bangunan apartemen maupun rusunami di masa depan.
There's a secret to modern life. A few, actually. Secrets that have been working hard for you for decades. Look closely and you will find them everywhere. They're in your walls, in greenhouses, on the trains and inside your wheels. They're in the ground. They're blocking sound, insulating, irrigating, purifying, fortifying, so you can focus and play and live and be happier. Getting on with what's most important to you without your surroundings getting in the way. And helping businesses thrive more efficiently while respecting the environment. For the last 80 years, we have been unlocking these secrets inside stone. And we found that by applying our curiosity, passion and knowledge, we could recreate stone's natural cycle and optimize the use of resources by converting waste into valuable material. Today, stone wool improves people's work and well-being in all kinds of different ways. It plays a big part in making people's life richer, more productive and more beautiful wherever they might be. But we're sure there's more, and we are absolutely determined to find it, so we can do even more to improve life in societies around the world for decades to come. You might never see these secrets hidden around modern life, and you don't have to. We are proud that you experience their effects every day.
Kami Kami percaya untuk membangun sesuatu yang luar biasa harus dimulai dari halaman rumah kita sendiri. Itulah yang kami lakukan di sini, di YKKAP. Di Indonesia, hanya YKKAP yang memiliki proses produksi terintegrasi, mencakup 8 fungsi utama. YKKAP melakukan riset mandiri di Indonesia yang berkolaborasi dengan lembaga pemerintah dan berbagai universitas terkemuka. Berdasarkan hasil riset R&D, kami mengembangkan produk secara mandiri. Hanya YKKAP di Indonesia yang dapat melakukan tes performa secara mandiri untuk memastikan kualitas terbaik di Indonesia. YKKAP mampu melebur ingot menjadi billet silinder secara mandiri. Proses ekstrusi di YKKAP dilakukan dengan standar teknologi Jepang. Proses anodizing di YKKAP adalah satu-satunya di Indonesia yang menggunakan teknologi electrodeposition 3 layer, memastikan produk tahan lebih lama. Kami menggunakan mesin khusus untuk proses produksi agar proses fabrikasi lebih akurat. Staf-staf terbaik YKKAP akan berbagi wawasan dan pengetahuan mereka. Hal ini dilakukan melalui site inspection, distributor training, dan metode pelatihan lainnya. Di Indonesia, hanya YKKAP yang memiliki 8 fungsi produksi terintegrasi untuk memastikan produk dengan kualitas tinggi. Sebagai bentuk kontribusi YKKAP dalam membangun ruang hidup dan masyarakat yang lebih baik. YKKAP, we build a better society through architectural products.
Mari kita kenal lebih dekat dengan Balai Sains Bangunan. Balai Sains Bangunan berlokasi di Jalan Panyawungan, Cileunyi Wetan, Kabupaten Bandung. Balai Sains Bangunan merupakan balai teknis di bawah naungan Direktorat Bina Teknik Pemukiman dan Perumahan, Direktorat Jenderal Cipta Karya, Kementerian.
Ladies and gentlemen, the seminar will begin at 9 a.m. Please be seated and fill in the front row. Before we begin, please be seated and switch your mobile phone to silent mode throughout the agenda. Your cooperation and attention are highly appreciated. Thank you. Attention please, ladies and gentlemen. Kindly proceed to the conference room since we will momentarily begin the agenda. Thank you. The seminar is about to begin. Kindly be seated and fill in the front row. The Honorable Director for Human Settlements and Housing Development Engineering, Director for Settlements Infrastructure Implementation System and Strategy, Director for Building Management Development, Director for Housing Flat, Directorate General of Housing, Director for Center for Applied Climate Services, National Agency for Meteorology, Climatology and Geophysics. Head of Research and Development Center, National Agency for Meteorology, Climatology and Geophysics. Keynote speakers, Professor Prasasto Satwiko and Architect Yusing. JICA representative, JST representative, Professor Shikazuno. Japanese project leader, Professor Tetsu Kubota. Professor from Indonesia and Japan and dearest participants. Assalamualaikum warahmatullahi wabarakatuh. Shalom Om Swastiastu, Namo Buddhaya. We are now in the second day of the International Seminar of DELCA, Low Carbon Affordable Houses for Sustainable Societies. The seminar is also a pre-event to the World Habitat Day and World Cities Day. It is an honor for me, Shani Elizabeth, to be the master ceremony of today. This seminar is part of this project and co-organized by the Directorate of Engineering, Development of Human Settlements and Housing, Ministry of Public Works and Housing, and Hiroshima University, Japan. The seminar is also in collaboration with Agency of Meteorology, Climatology and Geophysics, BMKG, Municipality Government of Tegal, Universitas Indonesia, Institut Teknologi Bandung, Universitas Pendidikan Indonesia, Universitas Gajah Mada, Institut Teknologi 10 November Surabaya, Universitas Brawijaya Malang, Tokyo Institute of Technology, Waseda University, Shinshu University, and Kagoshima University. And also we would like to express our deepest gratitude to our sponsors, Rockwool, YKKAP, and AGC for your full support of this seminar. Rockwool is a leading insulation company producing insulation products for building applications such as thermal insulation, fire insulation, and acoustic insulation. YKKAP is a manufacturer of international standard extruded aluminum profiles and ensures that each product guarantees high performance to create a comfortable space. And AGC is a global glazing company, strive to help realize a sustainable society by providing differentiated materials and solutions. Today, we will initiate our second day seminar with two keynote speakers. The first keynote speech will be delivered by Professors Prasasto Satwiko of Universitas Atma Jaya, Yogyakarta, and the second will be delivered by infamous architect as well as founder of Aknoma Studio, Yusing. Then we will discuss a number of issues in 4 sessions. The first and the second sessions will cover the development of passive cooling techniques for apartments in the hot humid climates of Indonesia, focusing on Rusunami type and Rusunawa type apartments. The third session will further discuss the assessment of life cycle energy and life cycle carbon dioxide of the apartments. And the last, future experimental building design will be presented and discussed. Ladies and gentlemen, for the first keynote speech, Prof. Prasasto Satwiko has joined us today. Prof. Sas, as he usually called by, is professor of Universitas Atma Jaya, Yogyakarta. He obtained PhD degree in architecture from School of Architecture Victoria, University of Wellington, New Zealand. His research interests cover building performance simulation such as aerodynamics, acoustic, lighting, and energy, artificial intelligence, neuroarchitecture, and visionism. Prof. Sas will deliver a keynote speech with the topic Trend of Future of Sustainable Buildings in Indonesia. Prof. Sas, you have 20 minutes for delivering the keynote speech. And ladies and gentlemen, please welcome Prof. Sas.
can you start? Okay. Good morning, ladies and gentlemen. Good morning, everyone in this room and also online. Thank you for being on this morning seminar. Yeah. Thank you to the organizers of this seminar, especially who has been kind enough to give this since 1984. Yeah. Maybe some of you at that time weren't born yet. Yeah. So for almost 40 years then, yeah, in building physics, which includes building energy. In 2005, 18 years ago, I published the book with the title Architecture Cyber Energy, or Energy Conscious Architecture. It summarizes my lecture, which contains basic guidelines for designing sustainable buildings. It includes an introduction to computer programs to facilitate energy calculation. Yeah. If you are familiar with Energy Plus, yeah, I think the most precise or accurate program software for energy simulation. Yeah. In this book, I teach the initial version, yeah, version number 1. Yeah. Let's assume that my students were 20 years old on average. Now they are 38 years old. They have become quite experienced architects. Unfortunately, I've never surveyed whether my students apply the sustainable building principle in this book to their design. So I don't know if news is good news. Yeah. Yeah. Most of these disasters worldwide are not reported in Indonesia's mainstream media, such as the previous one, the Great Flood of China, and what you see now continue to occur, to rise or slow down, considering that in many countries there is starting to be a downward trend in bit rate. Human needs energy and the building because it's very, very sophisticated, yeah, and based on we wrote it with Python. Yeah. Okay, I found two exciting building design that support a sustainable design, but I think Prof Using will talk about this later. Yeah. Okay, I will talk quickly so Prof Using have more time. Yeah. Okay. Okay. In my observation, sustainable building construction faces many challenges. Yeah. Again, yeah, I list 10 challenges. Yeah. For sustainable buildings in Indonesia. Yeah. For sustainable buildings in Indonesia. Yeah. It's one of it is deals with regulatory challenges. Yeah. Then lack of awareness. Not many people aware of the need to build sustainable buildings. Yeah. High initial costs. Yeah. Limited availability of materials. Yeah. Sometimes you have to import the materials and it's very expensive. Skilled workforce shortage. Yes, indeed. Infrastructure limitation. Yeah, until the 10.1. Maintenance. Yeah. Okay. Okay. However, estimating the trend of sustainable buildings in Indonesia, especially for affordable ones, is also interesting. I list 12 points. Yeah, you can extend the points. Yeah, like this one. Yeah, in the screen. Yeah, yeah. The trend of future in sustainable buildings in Indonesia. Yeah, green building certification. Yeah, there are more than one green building certification now, and I think some agencies, some institutions have developed according to their own views or own perspectives. I think that's good. Yeah, renewable energy integration, passive design. Yeah, let's keep going. Yeah, yesterday we discussed about climate, and also today we will discuss about design. Yeah, I think it's good. Yeah. Urban agriculture. Yeah, one of the trend. Yeah, during the COVID, green urban agriculture is developing. Yeah, it's developing. Okay. Okay. Now I will conclude with with this 5 scenario. It's actually my own experience. Yeah, I will talk something that maybe most of you haven't heard before. Yeah, the connection between our plate, yeah, with the effort to sustaining our earth, our world. Yeah, so I put this sub-chapter, the title, yeah, plant-based food for the occupants of the sustainable buildings. Yeah. Okay. Come back to these graphs. Yeah. Actually, if you look at those graphs in details, you will find that in terms of greenhouse gas emission, buildings emit lower than meat industries. Yeah. And I don't think we, in daily life, we read from the mass media about this issue. Yeah. Sometimes we just don't want to talk about it. Yeah. We keep talking about transportation, we keep talking about buildings, industry, or burning fossil fuels, but no one talk about how we care, how we see our plate. Yeah. Okay. See, I apologize for these graphs. Yeah. I put the old one. Actually, I have to put the latest one. Yeah. So this is the concentration of carbon dioxide, methane, yeah, and nitrous oxide, yeah, from 1992, 2010, I think. Yeah. Okay. Yeah. You can see the graph is, yeah, all the elements, all the greenhouse gases, yeah, going up. It's going up. Yeah. Okay. Let's see this pictures. There's a lot of information here. Yeah. Methane. Yeah. Methane gas, one of greenhouse gases. Yeah. Comes from cattle. Yeah. Especially ruminant livestock. Yeah. Okay. You can see from cows, buffalo, beef, yeah, pork, chicken, yeah, they are all emitting greenhouse gases, yeah. But maybe we never think about that, yeah. Okay, see, yeah. We talk about this one. Yeah, it's one of the most familiar greenhouse gases, yeah, carbon dioxide, yeah. It's about maybe 78% of the GHG. Yeah, methane maybe about 17, and nitrous oxide is smaller. But in terms of its potential, yeah, 5 minutes. Okay. Yeah, I think I will on time. Yeah, you can see that nitrous oxide and methane have very big impacts, much bigger than carbon dioxide. Yeah. Okay. See. Yeah. So let's compare our lunch then. Yeah. I think most of you will be good. I will go here. Yeah. I'm here. Yeah. So I release the less in this room, I think, in terms of greenhouse gases. Yeah. Okay. Okay. I will go past this. Yeah. If you meat lover, yeah, suka sate, maybe you will be here. Yeah, you release 3.3 ton, yeah, carbon dioxide. Yeah. Okay. Yes. I have to. I think I have. Okay. Yes. This is from the Ministry of Health. Yeah. our plate. Yeah, actually, yeah, our government has released sustainable food. Yeah, you can see here from our staple food, vegetable and fruits. Yeah, most of them are dominated by plant. Yeah, plant. Okay. This article just released, yeah, Oxford scientists confirm vegan diet is massively better for planet. Yeah, they did very comprehensive integrated survey and research. Yeah, vegan diet massively cuts environmental damage. Yeah, study shows. Yeah, this is what we have to be aware of. However, gigantic power of meat industry blocking green alternatives. Yeah, study finds that. Yeah, okay. So we can understand why we can see this information in the mass media because of this. Yeah, okay. Okay. Yeah, it's very good comparison. Yeah, to obtain the same lumens, energy-saving lamps need only 1/5 the power of ordinary lamps. Yeah, but if you change your diet, yeah, to obtain the same calories, plant-based food only require 1/16, yeah, of the fuel compared to meat. Yeah, so it's much better to change your diet than, yeah, to change your lamps. Yeah, to obtain 1 kilogram of beef, if you if you like hamburger, yeah, yeah, it needs 16,000 liters of water, yeah, which are enough for 6 months of bathing. Yeah, okay. This is my book. Yeah, in 2016 I published I Vegan or I Vegan. Yeah, I think I have to be consistent. So my students usually read this to understand their weird professor. Yeah. And in 2020 I published this one. Yeah, indoor garden architecture to support the idea of urban farming. Yeah, and 2021 I published urban farming architecture. You can download online. Yeah, free. Yeah. 2021 I published architecture student ideas for urban farming. Yeah, with the students. This is my newest book, my latest book. I published Neuroarchitecture. Yeah, this is my recent book. I published it free online. Yeah, after encouraging sustainable dietary changes, I tried to understand how humans respond to their environment at the primary source of consciousness, the brain. Yeah, in this book, I try to understand the occupants of buildings from the neuroscience perspective. I hope what is revealed from the human's brain can lead me to a new understanding of how humans respond to their environment, experience multisensory comfort, and achieve that comfort through sustainable lifestyles within sustainable buildings. Yeah, okay. So this is my last message. Let's make our world a better place, not only for the human beings, our species, yeah, but also for all the living beings on Earth, other species too. Thank you very much.
Thank you very much, Prof. Sas, for delivering such a remarkable and insightful keynote speech. Please, Prof. Sas, to remain on the stage. I'd like to invite Pak Sugeng Parianto, as a representative of Directorate for Settlements and Housing Engineering Development, to move forward and hand over the placard to Prof. Sas. Ladies and gentlemen, please give applause again to Prof. Sas. As a second keynote speaker, Cian has already joined us today. He will present the practice and future sustainable development in Indonesia. Cian is founder of Aknoma Studio. He is prominent architect with his works, mainly emphasizing on the sustainability in terms of economic, social, and environment. His works reflect his idea on the sustainability. He received Mori Award for Culture and Humanity in 2021 and Green Leadership Award from BCI Asia in 2016. Mr. Cian, you have 20 minutes for your speech. And ladies and gentlemen, please welcome Cian.
Good morning, everyone. We want to talk more about sustainability design. My main issue today is focused on three aspects. The first one is green city issues on passive design. The second one, I think the most important thing is interdependency between human and nature. And the third one is complexity. Global warming creates a narrative about the importance of sustainability. The biggest effort made is to reduce carbon emissions. Since then, we know that green principles have emerged: green roof, green building, green material, green transportation, green city, and etc. Yesterday, we talked about albedo effects and the conclusion and the suggestions about the city needs more green space, need more tree. I think almost all of the big city in Indonesia want to achieve is already happened in Singapore. Singapore have 46% more of the area is green area with 30% of green canopy. Imagine if Jakarta being built the same verticality with the Singapore. That means that all of the building in Jakarta being replaced into vertical building, just the same percentage like Singapore. For sure that third quarter of Jakarta will be empty. It will be very amazing. Singapore have second world champion for green building performance index, and also third world champion for percentage of total number of green building. So Singapore can be our precedent, good example of the green city. Also the green area and etc. Singapore have very good public transportations. Almost I think more than 80% of Singapore is a water catchment area. That means that all the rainwater and used water is already filtered and can be used again. We can drink all of the tap water. So the achievement is very great. Unfortunately, is it enough for sustainability? Actually, honestly, we don't have for sure sustainable certificate for every building. We only have a green certificate. So this is what happened in Singapore. Still that Singapore temperatures rising at double the global average because of the fast growing populations and also urban heat island effects, especially from air conditioner. So from this data, we know that all of the aspects that we talk much about green, about a tree, about open space, etc., green building is not enough. So what can we do for our next sustainability city? The green building is good but still not good enough to making our city sustainable. Still in the give negative impact, because the green building certificate only reduce carbon emissions by maximum about 50%. Meanwhile, we talk about also net zero energy building, zero carbon title, but the most zero energy building title is not really zero energy building, but they buy the carbon storage from forests elsewhere, not in the site, to exchange their carbon emissions. That's, I think, the problems. This is also interesting data. The country with higher GDP per capita, that means the higher GDP is the more good technology for afford green technology and etc., have more higher tendency of carbon emissions. Singapore people 12 ton per capita, Japan 10 ton carbon emission per capita. Meanwhile, Indonesia is only 1.7 ton per capita. This is another problem that we have to face, that we can think that the wealth of the country will give more to the sustainability. If you learn from Singapore case, dependence on air conditioning must be reduced. Passive design for thermal comfort is a design solutions that significantly will reduce carbon emission and urban heat island effect. This is one example, one point about passive design. One good example of the high-rise building, a 12-story building in 2010. The Gensheim Center have hybrid technology, also application the passive design that use atrium. Here, the atrium in the middle of the buildings, solar chimney, sunshades, and double facade to alleviate temperature extremes before the heating and cooling system are applied. The prismatic louver at the top deflect heat-generating direct sunlight, allowing only diffuse light through the skylight into the atrium. Light heliostat are the large mirror located on the roof. They follow the path of the sun throughout the day, reflecting sunlight onto the set of fixed mirrors, which then direct light down into the atrium. The chandelier here is not ornaments. This is the central component in the light enhancement system. Consists of a lot of prismatic plates that distributed light from the skylight into the interior space throughout the building. The exterior facade of the Gensheim Center includes operable windows and several terraces that allow for use of natural ventilations, therefore reducing the reliance on the building heating and cooling system. Gensheim Center's energy costs are estimated to be 42% less than comparable building. Also use estimated 34% less water. Is over 75% of the material used is recycled material, and 90% of the all construction waste from the project was recycled. This is one of the good example of the passive design, I think. Can be applied also on high-rise building. The important principle should also be a standard in every building design in Indonesia. Actually, the passive design is not really have good percentage criteria for the green building certificate. All of the green buildings still use aircon, for sure. So I think the passive design can be the one aspect of the important things that we can achieve. The second issue is interdependency between human and nature. In many traditional villages in the world, the people depend on the material, natural material, because at that time there are no industrial material yet. Human dependence on natural resources demands the preservation of nature as a supply of human needs. If nature is sustainable, then the human life will also be sustainable. interdependency is one main issue that we have to afford, I think. This is the example of the lifestyle of the dependency to the natures. The marginal people, the poor people that living in Batam, live by selling mangrove charcoal. They do not cut down the mangroves. Meanwhile, the deforestation of the mangrove tree in Indonesia is one of the biggest deforestation in the world. They only take the branches to make charcoal because they understand about the ecosystem of the mangrove forest. They can get fish, they can get crab, prawn, etc. Their lives dependent on the mangrove trees. Therefore, they participate in preserving mangrove trees. That's becoming interdependency. This is also one good example of the business that depends on the nature. There is one hotel in Ubud, in the city center of Ubud, that relies on the rice field as the essential view of its hotel. It's not really big hotel, it's quite a small hotel. But the occupancy of the hotel is very high because the people like to stay here to enjoy the rice field next to the hotel. So the hotel knows that the rice field is very important. So they rent the rice field next to the land so that is not converted into other functions. This is also an example of the interdependence. In traditional houses, natural materials such as woods, bamboo, leaves, stone, soil, etc. are used as it is with a little simple preservation. But in this era, we face greater challenges, fewer natural material, space functions are more complex, taller buildings, smaller green area, etc. Apart from relying on the simple use of natural material, how to contextualize the interdependency principle today? This is the most important question. Maybe we can still use the natural material, but with the more industrialization of the engineering. Because the natural material with that already engineered can be more stronger, can be more durable, and also we can use just a little bit of the material. For example, sandwoven bamboo, laminated bamboo, also the wood, glue lamp wood, cross-laminated timber. This is maybe the interesting example of wood-plastic composite between plastic and wood. All of the material industry this material will be sustainable if the natural material resources are also sustainable. For example, the plywood industry cannot be sustained if they cannot protect the forest for their source of the material for making plywood. So dependence on the natural material will encourage sustainable industrial forest management. This means that using engineered natural material also plays a role in preserving nature. The development of wooden buildings in the world is increasing to pursuing sustainability. For example, this is world's largest wooden city said to be built in Stockholm. This is Toyo-Ito, largest wooden building in Asia. This is the world's tallest timber residential is being to build. This is also the example that a collaborative project between Jaya, GST, PUPR, and Aknoma Studio. One of the second experimental rusun in Tegal, hybrid timber housing, that also use natural material, wood, for structure of the building. The longer facade of the building is faced north and south, also to get the natural wind. The east and west part of the facade is using double facade and also sun shading at the facade. We also put this ventilator at the shaft of the building to use it as a natural wind tunnel of the corridor. The structure will be combine between concrete structure and the wooden structure, 2x4 system, that more affordable than the other wooden structures. Okay, thank you. This is the section of the building. You can see that in the middle of the corridor, they have a wind tunnel. The shaft can be function as the wind tunnel, and also the passive design is applied. We also use rice husk charcoal as the humidity insulations at the attic, at the plafond. This is another alternative for the walls, using bamboo plaster to protect the wooden structures at the buildings. Yeah, we can talk later at this afternoon session about the rusuns. The latest principle is complexity principle. This is a signed project of the renovation design of the Ledokan traditional market. Is here in Kediri city. We added more street vendor or PKL in this area, in this part of the city. This is before the existing traditional market. The site is below the road, so we put more street vendor near the trottoir to put it more higher, just half floors, and then the below is for a motorcycle. But beyond a signed project, we think that the land use should be more efficient, not only for the traditional market. We tend to ask the government agency to be more cooperate to make one project, not separate. For example, this land only using for traditional market, but we propose that actually the upper side of the land can be used also for the housing. So we give them free and not project, also not real project, but free as the illustration that if we can think that this land can be used more effective, if we functioning as another function, not only for pasar but also for housing above. This is the first floor. This is the street vendor, the stores. This is the housing. The traditional market will be below. The sections of the building, this is the part of the traditional market. This is part of the housing. So the interdependent relationship will be created between the community above, market and street vendors, as well as the residents of the rented housing above it. Flat residents can shop at the shops below, and markets on the lower floors. Shops and the markets have regular buyers in the upper towers. Also interdependency. This is the facade of the buildings. This is also another issue of vertical densifications. In Palembang, we also proposed the study of the kampung to be verticalized. This is, for example, of the existing condition consists of 6 houses at the Palembang, becoming 13 houses and 1 rental house, and this is the design. Still at the atmosphere of the kampung, but more dense and more effective of the land use. Thank you.
Thank you, Mr. Yusing, for your valuable insight in your speech. Please remain on the stage. I'd like to invite Pak Sugeng Parianto again to move forward on the stage and present the placard to our distinguished keynote speaker, Mr. Yusing. Ladies and gentlemen, please give applause again to Mr. Yusing. Now we are going to the first session of this seminar. This session is very important since we are going to discuss the passive cooling techniques for apartments in the hot humid tropics in Indonesia. In total, we have 8 speakers for this session with various topics. First session will be chaired by Dr. Andang Rahmatri Hamdani. The second will be chaired by Dr. Takashi Asawa. Ladies and gentlemen, Dr. Andang, who is going to moderate the first session, is a senior engineer in YKKAP R&D Center Indonesia. He obtained his doctoral degree from Hiroshima University, Japan. His research interests include indoor air quality for low energy apartment, performance-based window for buildings, and building performance simulation. For the first session, 75 minutes are allocated, including 15 minutes Q&A. Yes. Dr. Andang, time and floor are yours.
Okay. Good morning, everyone, ladies and gentlemen. Thank you for the introduction. So I hope today is going to be more interesting than yesterday, because in this session 1, 2, until 3, we can learn more practical that maybe you can also apply in your house. Yeah. For example, window techniques here, and also the how about our behavior in green buildings. So we will learn from all the speakers here. So for the session 1, the topic is the development of passive cooling techniques for apartments in the hot humid climates of Indonesia. This is part 1. I would like to call the first speaker, which is Mr. Andika Prasetya from Ministry of PUPR. So he will be presenting the passive cooling techniques. Passive cooling techniques for low carbon apartment in hot humid tropical climates of Indonesia. Please, Pak Andika. Then for the second speaker, I know this guy very well. He is working very hard for his PhD. He is Mr. Haruka Kitagawa from Tokyo Institute of Technology. So he will be presenting optimum window opening control for naturally ventilated buildings with phase change materials in the hot humid climate of Indonesia. And then the next presenter will be duo, 2 presenters at the same time. So I would like to call Mrs. Colintia Erwindi. She is currently a lecturer in ITS, but now taking his PhD study in Tokyo Institute of Technology, and also Mr. Kyohei Kondo. So they will be presenting behavior and comfort during floor usage in Indonesian apartments. And the last speaker, he used to be my lecturer back in Institute Technology of Bandung. I would like to call Ms. Dr. Doni Kurniawan. So he will be presenting prototyping and simulation of fixed and adaptive shading devices on 4 facade orientation of a tropics high-rise office building. Kondo-san, stand by here, there. I think you can also sit over here. I will be sitting there. No problem. So please come on the stage. Pak Andika mungkin bisa geser ke sini. Saya di sebelah sana aja. Gampang. So let's begin with our first speaker, Mr. Andika Prasetya. So the time is yours. You have 15 minutes ya.
Okay, thank you. Saya pakai timer ya. Okay, good morning everyone. Assalamualaikum warahmatullahi wabarakatuh. My name is Enrica. Currently, I'm doing the doctoral study in Hiroshima University under the supervision of my sensei, Professor Tetsu Kubota. Today, I would like to talk about the passive cooling techniques for Rusunawa in the hot climates of Indonesia. So I will be presenting on behalf of my working group research actually. So they will also part some of the study conducted by the other researcher in Hiroshima University. Okay. Okay. So these are the contents for today's presentation. Basically, I would like to draw back a bit about the earlier stage of the research, which is doing some of the classification or typology study to understand more actually about the current existing of the typical Rusunawa and Rusunami in Indonesia. And then we will also propose the best model. And then for the later part, I will try to deliver about the current process of building simulation and several study of passive design techniques and several ideas and other feature works. So for the Rusunawa base model, basically this is the issues that we are facing on this topic research. Basically, Indonesia still have backlog housing in the urban areas, according to the Ministry of Public Works, 7 million housing in 2020. And we also have the national agenda of reducing the greenhouse gas emission by 29%, according to the Paris Agreement. According to the data that we are collected, there are some national policy in 2007 and also 2015 that accelerates the development of vertical housing, especially for the urban areas. So now we understand that the number of vertical housing is growing, but what about the quality? The quantity is growing. Now we are start to thinking about how to increase the quality without giving more burden into the greenhouse gas emission. So basically, these are the framework of the progress of the research. We are studying the current existing prototype design. We are doing the typology study, and then we are proposing the best model. And then by having this best model, all of the researchers in Indonesia can use this base model to do further simulation, building performance simulation in any other topics, like for instance the low energy, maybe indoor air quality, natural ventilation, and everything. And then by having this base model, we are trying to have, we will try to modify the base model and try to propose it as the new prototype of Rusunawa. The data collected were more than 500 buildings in Indonesia from 1988 into 2021. So I hope it will be enough to represent the current existing Rusunawa and Rusunami in Indonesia. Usually researchers having difficulties on collecting the data, but yes, lucky enough on this study we can gather so many data. For instance, one of the classifications that we are making is on the indoor layout, the position of the bedroom, the room configuration, living room, the number of bedroom, the position of the toilets, and then the type of balconies that were used. And then there are also some quantitative figures that we are trying to collect. For instance, the window floor area ratio, the height of ceilings, the size of balcony, and everything. And we are trying to use all of these indicators as sets of database that we are going to analyze by using statistical analysis. And this is some illustration of that. We are performing the principal component analysis, hierarchical cluster analysis, and frequency analysis. This paper has been published in the latest journal recently. So these are the final conclusion of the typical layouts for Rusunawa. This one is for Rusunawa. For Rusunami, private apartment, they have different layout. So this one is consisting the 1 bedroom and the 2 bedroom. These are the unit scale, and then these are the typical of a building scale. The black one is the vertical circulation. So according to the finding, we are also trying to identify the characteristic of the current Rusunawa. For instance, this is the building orientation, which is I believe very important for the passive design studies. There are tendency that we cannot find actually the pattern of the building orientation that were already being constructed in Indonesia. So perhaps they are more on the regulating positioning the building by according to the local building regulation, such as the urban design guidelines. or maybe the position of the roads, and they try to maximize the capacity of the unit, so they try to make as big building as possible. So that's why maybe building orientation is not one of the factors that is being considered until now. There are so many other part of discussion. This is the typical layout that is growing from time to time, the tendency. And these are some of the findings that there's also tendency to reduce the size of the corridors. And the use of vertical void is also decreasing, unlike the previous era of building vertical housing. And then the use of single-loaded corridor is also very much increasing now, reducing. I mean, so the double-loaded corridor is very much used currently to maybe to increase the efficiency of the building within the specific site. So this is the base model that we are trying to propose. Now we are going to present this base model in the AIJ conference this month, actually, in Kyoto. These are the several published papers. So heading out to the next topic, the current process of building simulation, we are trying to use the finding of the base models by doing the building simulation. But first of all, we have to do this validation of the models. So we are collecting the data from the field measurement data, including the several measurement device in the unit, in the Rusunawa, and also using the weather data. So later we will try to compare within the simulation results and the field measurement data. If the comparison is already similar or typical, then we can say that the model is correct. Then by having the validated model, we can do the modification. So this is the idea. So by having this 4 base model, we have 3 locations in Surabaya, in Bandung, Jatinangor, and also in Tegal that we already have the field measurement data. So by performing the simulation and comparing to the field measurement data, we are hoping that we will have the validated model to be further modified for by using other passive design techniques. These are some of the illustration during the field measurement. This one is in Tegal. These are some of the equipment that were used during that time in the unit and also in the corridors. This is the illustration, also the customized mini weather station that were used also in Bandung. These are the illustration of the current developed models that we use. So we're using the Open Studio modeling and also the Energy Plus for the simulation. This is the building orientation. This is the inside of the unit. But until now, we are still having some difficulties on validating the model. Hopefully after this, we will manage to finish all the building validation. Especially for the no ventilation case, we are still having some difficulties to adjust the infiltration rates of the building models. So yes, maybe this is some of the illustration of the process that we are currently doing now. This is some comparison that we are using. So this validation process is also conducted in other places, like three different places. I would like to also to explain a bit about the current passive design study that we are conducting under our research group. Later on, any typical design that will be proposed as the future prototype of Rusunawa should be comply with the local climate. As yesterday, Dewasan already, Mas Dewa already explained about his finding on the integrated Indonesian climatic zone. So the idea is later that after we have the proposed design for specific Rusunawa, we will later be able to say, okay, this prototype design will be more suitable on which climatic zone. And this prototype number 2, for instance, will be more suitable on which climatic zone. This will be the final result of the study, actually. According to the findings, most of our building sample were located on the zone climatic, on the 3B, if I'm not mistaken, submonsoonal area. So according to his study, there will be different approach, different technique design that will be more suitable to be used on each climatic zone, like the night ventilation, comfort ventilation, evaporative cooling, and etc. And this one conducted by our team also. So basically, he is collecting hundreds of literature related with passive design, and he tried to cluster the topic into, for instance, the rejection of heat gains, the user behavior, and etc. So he collect hundreds of journals and try to evaluate the performance of its passive design techniques that were proposed on that journal, and try to compare within each other. So
4 more minutes.
Oh, okay. This is one of the example how the performance and the price that can be compared within each other. This is in overall. We can see this one is regarding the price, which one is the cheapest, which one is the highest. He tried to standardize the value using Z-score. And this one is what if we compare? What if we combine both of them, the performance and then the price? So some of them were already tried to be summarized, but yeah, still under process, I think, for now. And the second will be about the use of wood materials. So this one is conducted by Riko Koda. And we studied about the use of timber material in vertical housing, wooden construction. We also visited some buildings in Japan to make some comparison. And she tried to analyze the embodied energy. So she tried to use one of the best models and try to replace all the conventional reinforced concrete structure with the glulam, for instance, the engineering wood, and then try to see what is the number reduction of the embodied energy and the CO2 emission. So according to the findings, the number of energy, embodied energy consumption will be able to be reduced more about 24%, and the CO2 emission can be approximately reduced by 18%. These numbers can be also increased by the use of local material, domestic materials. It can be increased until more than 40%. These are several design ideas which is still under process. Mr. Yusing already explained about this, but maybe later Mr. Yopi will be able to have some times to explain further more about this. This one will be in the second experimental house which is under proposal, using the wooden hybrid construction, wooden and concrete structure. This one is also just some sketch idea about how to, for instance, using the high ceilings to improve the nature of ventilation, and also to combine the use of wooden materials in the upper part of the buildings. So this part of the building for the room can be proposed by using wood. So during daytime, most activity will be conducted in the first floor, and then during nighttime, people will sleep in the bedroom in the second floor. So this is using the loft type, similar to the first Tegal experimental house, actually, the idea. So for the future works, as I mentioned, this is our group research, actually. So we are doing the design typology, material study, passive design study, and we also try to look at the climatic zone that were conducted by Dewasan. And we will trying to do the building performance simulation, and then later on we will try to also involve other findings on the other research group to be able to propose the future prototype design for Rusunawa. That's all from me. Thank you very much.
Thank you very much, Pak Andika. It's very nice news. Yeah, we will have more scientific and quantitative basis for our Rusun, for our better Rusun as well. Thank you, Pak Andika, for great words. And then let's welcome our next presenters, Mr. Haruka Kitagawa. You have 15 minutes.
Good morning, everyone. I'm glad to get the opportunity to present today. Okay, today I would like to discuss my research, optimum window control for the naturally ventilated buildings with using PCM. Okay, first of all, let me introduce the background. In the hot and humid climate, including the Indonesia, Malaysia, the natural ventilation is really important to improve the thermal comfort. For example, the occupants tend to open window regardless AC ownership. Then more than 80% of respondents want to open the window during the daytime. And then we asked the reason, and they answered like occupants want to get fresh air, and the occupants want to feel the air movement. So it means they prefer the comfort ventilation. During the nighttime ventilation can be effective, even in the hot and humid climate. Then in Asian countries, including the Japan, Indonesia, and the other Southeast Asian country, occupants tend to tend to be bare feet in their houses, and then they prefer being bare feet and sitting on their floor. Then if you spend their time with bare feet, radiant and contact cooling, occupants can receive that kind of cooling effect through the thermal storage effect and night ventilation. However, there is, of course, disadvantage of each passive cooling method, such as comfort ventilation depends on the weather condition. So if you cannot receive the good wind, you cannot get good comfort ventilation effect. And during the nighttime, compared with other climate region, in the nocturnal temperature in the hot and humid climate is slightly higher than the other climate region. So night ventilation alone is difficult to satisfy thermal comfort. Therefore, we propose the novel floor cooling system using the PCM. So we install the PCM on the backside of raised floor to increase the thermal storage as a latent heat. Then during the nighttime, we operate the ventilation fan to dissipate the heat from the PCM or building structure. During the daytime, occupants can receive the radiant and contact cooling effect through the thermal storage of PCM. And then if you open the window, the comfort ventilation assists the improvement of thermal comfort further. Then this is a research question. The combination of comfort and night ventilation may compensate the disadvantage each other, but how to maximize the combination effect? So there is a context of Indonesia and the previous study. The natural ventilation is important. Then occupants prefer the comfort ventilation and the contact cooling. Then each passive cooling method has disadvantage. However, we can, the combination may compensate. Then this is the purpose of our study. Our study is to develop the passive cooling method that maximizes annual thermal comfort. And then this presentation mainly focuses on determining the optimum window control. Then this is the flow of this study. Firstly, I constructed the thermal energy simulation coupled with airflow network model. Then I validate the constructed model comparing with the result of field measurement and the coupled CFD, which was previously I proposed. Then parametric study of window opening control was conducted. Then finally, we evaluate and determine the optimal window opening control. Then this is the target building. We conducted the field measurement in 2019. Then for the room A, this is the test room. In room A, have floor cooling system that I proposed previously, and then horizontal pivot window, which is the preferable window type for the comfort ventilation. It's installed in room A. Meanwhile, room B, this is the reference room. So we, in room B, doesn't have floor cooling system and just simple opening. Then this is the calculation flow of coupled TES. We use the Energy Plus. Then Energy Plus calculate the heat and mass flow balance for each node. Then before starting the coupled CFD, the window pressure coefficient, flow rate, and indoor air speed was calculated using the CFD simulation. Because to use the airflow network, the window pressure coefficient is necessary. So window pressure coefficient was calculated for airflow network model. Then airflow network model can calculate only mainly flow rate. So it cannot calculate the wind speed. So that's why we developed the regression model to calculate the wind speed based on the flow rate. Then this is the interaction between TES and the airflow network. From the airflow network to thermal energy simulation, flow rate was used for the heat balance analysis. And then if thermal energy simulation calculate the temperature data goes to the airflow network to calculate the ventilation rate. So this is the coupled simulation method. Then for the parametric study, the purpose of window opening control, if the current value lower than threshold value, we close the window to maintain the thermal storage effect. Meanwhile, if the current value higher than threshold value, we open the window to get comfort ventilation. Then this is the threshold value to open the window. We tested the 4 basic ventilation type, and then indoor air temperature, outdoor air temperature, outdoor wind speed, and then this is the logic flow. We tested the threshold value alone, and then this is the window was controlled by threshold value and schedule. So it means if the current value is was higher than lower than threshold value, then goes to no, and then after that we check the current time. If the current time is nighttime, we open the window. Okay, this is the result of validation for the air temperature and the PCM temperature and the floor surface temperature. The temperature calculation relatively accurately. Meanwhile, it is still difficult to calculate wind speed at every time step in coupled tests. But coupled tests can calculate the overall trend of wind speed. And then this is the annual weather condition in 2020 measured at the experimental site, Tangera. The average air temperature was similar to the nearest official weather station. For the wind direction, the experimental site was largely influenced by the sea and land breeze, but it stabilized the prevailing wind direction. During the daytime, we received the wind from north, and then during the nighttime, we received the wind from the south because of the land breeze. This is the influence of window opening control on indoor air temperature. So if you control the window opening by using the indoor temperature, then indoor temperature of 27 degrees Celsius, the rapid temperature decrease was observed in the evening. Then if you close the window in early evening, closing window cannot dissipate the heat effectively in the evening. Then closing window in the morning, you can see the orange arrow. It means the temperature rise slowed. Then opening window in the evening can better to dissipate the heat and decrease the temperature in terms of improving the thermal comfort.
4 more minutes.
Okay, thank you. Then if you combine with the night ventilation strongly contribute to the temperature decrease in the evening. And then if in case of you control the window by indoor temperature of 30 degrees Celsius, the temperature raise in the morning slowed further compared to upper figure. It's controlled by just threshold value. Then this is the combined with night ventilation. But there's still need to clarify how long we can close the window in the morning to maintain the thermal storage effect. Then next, I evaluate the window opening control based on the SET star. In case of controlling window by wind speed, the large SET star reduction was observed in the December, because the average wind speed in December is quite high compared with the other months. But sometimes controlling window by wind speed is disadvantage, like closing window even when indoor air temperature was high, as shown in the green arrow. Controlling window based on the wind speed is not appropriate method for our proposed system because it cannot consider the thermal storage effect. Meanwhile, if you control the window based on the indoor temperature of 27 degrees Celsius, closing window in the early morning maintain thermal storage effect, then it contributes to the improved thermal comfort satisfaction. And then when indoor temperature exceeds the 27 degrees Celsius, comfort ventilation through opening window can be effective to improve the thermal comfort. Based on the parametric study, we achieved the annual thermal comfort period up to 83.3%. Meanwhile, the reference room just still 50.2% for throughout the year. Then next, we analyzed the reason why 27 degrees Celsius is effective. This is the relationship between operative temperature and the SET star. When operative temperature is about 27 degrees Celsius, the SET star was below the comfort limit regardless of wind speed. Then maintaining thermal storage effect, which keeps indoor temperature of less than 27 degrees Celsius, and the opening window if indoor air temperature exceeds the 27 degrees Celsius to use the comfort ventilation can be an optimum window opening control in this study. Then this is the conclusion for our study. During the nighttime, decrease the air temperature and decrease the MRT, decrease the SET star. Then during the morning time, decrease the air temperature, decrease the MRT, decrease the SET star, mainly because of the maintaining the thermal storage effect from the PCM. Then during the daytime, we increased wind speed and slightly decreased the mean radiant temperature, decreased SET star because of the comfort ventilation and thermal storage effect. Okay, that's all for my presentation. Thank you for listening.
Thank you very much, Haruka-san. So kind of strange, yeah? Most of us normally like to open window in the morning and close at night, but Haruka-san's research tell differently, yeah? So you can ask more questions to him, but please keep it at the moment because we will move on to the next presenters, Bu Windy and Kondo-san. So you have 15 minutes.
Okay. Okay, good morning, everybody. So right now I would like to introduce myself. At first, my name is Colintia Erwindi. I'm one of the lecturer in ITS, Department of Architecture, but right now I'm doing the doctoral course in the Tokyo Institute of Technology, supervised by Dr. Atakashi Asawa in Asawa Lab. And right now I will present the behavior and comfort during floor usage in Indonesian apartment with my colleague Kyohei Kondo. And then I would like to continue. So For today's, I would like to present about the floor usage in Indonesia, and then how is the housing in Indonesia, and the overview of the research and demographic, and related the questionnaire for Indonesian behavior on floor usage. And then the next part will be presented by Kondo-san, related with the analysis flow and the result. And at first, we already have a discussion yesterday and slight conclusion that in building or we need to be comfort while living in it. So, but how comfort? Or maybe how is the behavior related with the Indonesian? Because without the behavior itself, we cannot, how to say, I think we cannot obtain the certain level of comfort. And in here, related with the floor usage, we found something that interesting. So from the ancient or the culture in Indonesia, there is a related with the floor sitting. But it is related with the hierarchy. So in the king area, and right now we are in Semarang, so it is a strong, can be strongly seen in here as well. So we can see the king, and then the this is the hierarchy. So the lower hierarchy will be sitting in floor, and also it affect the, how to say, the furniture, or maybe the equipment that we use, including gamelan, and then this some kind of ceremony. So this is kind of culture in Indonesia, but how we deal with it. And also in daily living, we can see a lot of things like this. Also, Kita Kawasan already mentioned about there is a sitting on the floor behavior, and also with how does I say, touching in the floor. So we conduct gathering and also studying, and then eating together. We do it all in the floor, or maybe just resting or sleeping. So this kind of interesting, how to say, behavior. And then related with the housing, because house is, yeah, housing in Indonesia has several stages. So at the beginning, maybe until now, landed house is still commonly used. It is private owned from the low end until the high end. But Andika-san also already mentioned the growing of the vertical housing is growing rapidly. And also related with the government program about the 1,000 apartment, but I think it 10 years ago, 2012 or 2013, but it is not well obtained, maybe. But right now, the usage of the apartment or high-rise housing is getting increased. So I would like to focus on what kind of effect in the vertical houses. If we see daily activities in the vertical houses will be, I apologize, will be like this. So there is a lot of activities, and logically it always contact with the floor. This is the overview. So just sitting, relaxing, or just laying on the floor will be a daily based use. But we cannot say it as a strong behavior for Indonesian because we don't have any specific data. So in this case, after this important floor usage from my hypothesis, yeah, so from related with the Indonesian behavior, and then kind of with thermal effect itself, because contacting with floor might be might affect the thermal comfort of the body itself. In the end, we've kind of few questions related why, and then why we are using the floor, and what kind of materials maybe we use, and then where I'm focusing on the housing, and then when and who. And how would this floor usage behavior and habit will be potential for other purpose or the next purpose? In this case, we conduct a questionnaire in collaboration with the energy team. So we use a main questionnaire, which is with the demographic of the respondent for in the Bandung, we choose 5 big cities that we hope it can represent the, how to say, the behavior of all Indonesian. Bandung, Jabodetabek, Makassar, Medan, and Surabaya. The proportion is as seen in the screen, at the screen. Most of the respondent is in Jabodetabek, and then the gender is mostly women actually when we conduct the questionnaire. And this is the overview of the questionnaire itself. So the respondents' total number is 3,363, and the method is in-person survey. And then the age is from 10 to 60s, and this is the related with the house type, unit category, and then the number of family number, building structure, total floor level, and then the location and ownership. This is the overview. And the question itself, actually for the part 1 is the general question and energy and related with lifestyle question. But related with the behavior will be in this part 2. Activity related, and then food and floor cover question, and then it's the posture and preference question, and the next one is the body parts contact with the floor question. So in this case, we decide to analyze focusing on the daily activity and all the combination between the daily activity, posture, foot cover, and floor surface, because this is the, in our understanding, it will be the most related with the daily behavior of the Indonesian. And it's kind of interesting, there's a previous studies related with this. So there is a studies about gathering, conducting in Japan actually. I know that Japan also has a sitting on the floor culture or behaviors, but in here, Indonesian, even they move in Japan or maybe other country, they still conduct the gathering by sitting on the floor or contacting with the floor, regardless they have a certain furniture or not for sitting. And the other one, the previous study related the comfortness by contact with the floor already be conducted, and one of them by Kita Kawasan, that is one of the, how to say, option to improve the contact cooling for the floor contact for the human or the respondent residents. And there is about local discomfort as well. And then, okay, for the next part, I would like to invite Kondo-san to explain the analysis. Thank you.
Thank you, Wendy-san. I explain about the analysis flow and also the results of the survey that we conduct. Oops. Sorry. Yeah. There are mainly 4 analysis that we did. First, sit-in behavior, on the floor vs the chair or sofa. And the second one is the sit-in behavior clustering to summarize the behaviors related to the sit-in. And then the third one is the preference of sitting on the floor. And then fourth one, the reason why they prefer to sit on the floor. First, the first one. How come?
You have 5 more minutes.
We compare the activities based on the sitting on the floor or sitting on the chair. The gathering, especially the percentage of the sitting on the chair is only 41%, and then the sitting on the floor is the 52%. So as on the behalf of the sitting on the floor behaviors, I pick up the gathering activity. And then the second one is the sitting behavior clustering. The aim of the clustering is to make sure the posture characteristics in gathering. And then as she mentioned, we pick the main posture, main foot covering, main floor covering in gathering. It also represents the three behavioral factors to show the behaviors related to the sitting in gathering. I validated and then I select the 6 clustering. The cluster 1 and 2 and 6 sitting on the chair and so forth. And then cluster 3 to 5 is to sit on the floor. In terms of the main foot, cluster 1 to 5 sit on the floor, sitting while barefoot in gathering. And then only cluster 6 wearing the sandals or slippers in gathering. And then the third one is the floor cover. Cluster 1 and 4 and 6 floor cover is the carpet, and then cluster 2 and 3 is without mat. It means the contact cooling is contact on the floor itself. And then cluster 5 is using mat. So cluster 1 shows the sitting on the chair with barefoot and also on the carpet. Cluster 2 is sitting on the chair with barefoot and then without mat. Cluster 3, 4, 5 is sitting on the floor with barefoot, and then cluster 6 is sitting on the chair and also the sandals. And then I compared between among the cities that we picked, the 5 cities. The cluster 3, 4, 5 is sitting on the floor, so mostly, regardless of the cities, they sit on the floor. And then only the Bandung, mainly with the carpet. So I think it is because of the cool air temperature. And then the sitting on the chair is mainly in Jabodetabek and also Surabaya. And then cluster 6 is the sitting on the chair with the sandal or a slipper. So that's why only in Jabodetabek it shows. So this is the characteristics in gathering. Mainly sitting on the floor, 71% in total, and then barefoot is the 98%. Only 2% is sandal or slippers, and then the 47% is sitting in with the carpet, and then without mat is the 29%. Regardless of the cities, sitting on the floor was seen more than 50%, but the as for the floor cover usage, the Bandung, in Bandung, they mainly sitting while carpet with carpet. So utilizing floor still exists in Indonesia, and also especially in hot areas, except for Bandung, they conduct the floor directly with barefoot. And then the third one is about the preference of sitting on the floor. I correlate between the clustering and also the preference of sitting on the floor. The cluster 3, 4, 5 is sitting on the floor, so that's why the behavior itself is related, might be related to like the prefer to sitting on the floor. And then cluster 1 to 6 is sitting on the chair, so that's why the behavior itself is related to the, might be related to preference for sitting on the floor. And then the last one is about the reasons of preference. The left from the audience is about the reasons of preferring of sitting on the floor, and then the right one is about the dislike to sit on the floor. As for the left one, the main reasons of preferring to sitting on the floor is comfortable and also the cool. But the reasons of not preferring to sitting on the floor is about uncomfortable and also the too hot. So it might be, related to the some comfort and also some discomfort in terms of the preference of sitting on the floor. Then as for the conclusion, the posture characteristic and also the preference of sitting on the floor. Mainly, they sit on the floor with barefoot, 98% with barefoot, and then the reasons for preference is mainly comfort and also the cool. But the reasons for non-preference is the uncomfortable and also the too hot. So that's why there is a possibility of achieving the summer comfort from the sitting on the floor in terms of the preference of sitting. Yes. That's all from me.
Okay, thank you very much, Bu Windy and Kondo-san. Very interesting research. Never done before in Indonesia, perhaps, about sitting on the floor. And please keep your questions because we will move on to the next speaker. We also have several questions already from our online participants, but let's keep it at the end after the last speaker, okay? And please welcome the next speaker, Dr. Doni Kurniawan. You have 15 minutes, Pak.
Thank you very much. Good morning, everyone, and nice to be here. Invited by Dr. Aril, actually, in here. And I want to talk about the prototyping and simulations of fixed and adaptive shading device on 4 facade orientations of the tropic in the high-rise office buildings. Actually, my presentation is about the summary of my experience and my experiments research in ITB, and belong to Building Technology Lab in Department of Architecture's ITB, and this is my roadmap actually. And my roadmap is about how to make the emissions and energy efficiency in the buildings. It's not just in the buildings, but I have to make that the emissions and energy efficiency in the city too. So that's why we have a multidiscipline right now to achieve the low carbon cities and efficient energy in the cities. One is the buildings designs and the master plannings in the right and the left hands, and there is a community system planning that right now we conduct some communities research, because this is very important than the other ones. And the below ones is the transportation system planning. So we have some roadmap to have done maybe for the next 5 years later, because we right now facing the carbon emissions very high. And today I'm not talking about all that I mentioned before, but I want to talk about just one part of my research. What is that? That's the adaptive facade that we already have experience and experiments 4 years, and one of the finished result is to be done by Sri Rahma right now in here. That's used to be my student in ITB, and that's my that's already finished for the one's prototype. But right now I have a 4 prototype actually for the adaptive facade. I'm not talking about the thermal comfort, but I'm talking about the daylight right now. So this is the background of why I have to research about the adaptive facade, because we spend almost 90% of our time in indoors. So 5 things that we have know is about the high indoor environmental quality. So there is a thermal comfort, air quality, lighting distributions, occupants control, and the materials emissions in indoors. So we have to consider about how to control 5 things that I mentioned. And another ones that there is for buildings envelope systems that falls as a safe pick for the saving energy in the buildings actually. And what are the four main functions of the building envelopes? So we can control the building indoor when we can control the facade of the building. So this is very important that the facade of the building is have to be considered. So the materials things is a very important that we have to consider when we design the buildings. And the high-rise buildings have to consider more than the low-rise building. So this is a very important how to control the weathers, the moistures controls indoor in the buildings using the facade of the buildings, and the airflow of the airflow that how to control the airflow from the outside of the building to inside of the buildings, and how to control the energy efficiency, heat, and the thermal control. This depend on how you design the facade of the buildings. And the last things that we have to control is about the noise reductions. So we have to consider about this one. We not just consider about the thermal comfort, but we have to consider about the daylight too, because the daylight can make people more productive when you can design appropriate daylight. Because the artificial light is not so comfort for us actually, but we have to avoid about that once. But we have to consider that daylight is more important to make people more productive. So maybe I already mentioned these ones, and there is a sick building syndrome too that affect by the facade of the buildings. So we have to know about that bad humidity in the buildings is considered about the facade of the buildings. And the ventilations. So the ventilations have an effect when we design the facade of the building too. And pollutants, there is how to control the temperature, how to control the lighting, and actually lighting means that how to control the daylight that can penetrate to the inside of the buildings, and how to cleanliness. This is about the maintenance of the facade of the building when we design the building for the high-rise buildings. So we know already in the tropical country, when we use the concrete, so we see that our building, the high-rise building, is very difficult to maintain, because many lack of is a fungus in the facade of the buildings, and is a very dirty, because in the tropical country is different with the subtropical country. We have some dust and some moistures. Is moistures with very humid. So we have to consider how to clean the facade of the building. So that's why. We another things, because the effects of the COVID-19, we have to consider that it is have a benefit for the morning sunbathings. When we design the facade of the building can be as a balcony, so it is very important to us, to the tropical peoples, to make that the balcony to be the place to sunbathing, because sunbathing is very important for us to produce the vitamin D. So why the architects, or we just consider that the building is very flat? No, this is not good. So we have to consider about how to design the balcony. So we can see in the picture that some people using the place as a balcony, as a sunbathing during the COVID-19. And we have to consider about how we look at it on the meshings. So the meshing is very important when the penetrate of the radiations come to building, to other buildings. So this is, we call about the sky view factors. So the sky view factors mean that some buildings maybe cannot get the penetration radiation from the sun. But it is very important when we consider how the distance is between the building to the other buildings, because we need have some radiations. Some architects reduce the radiation, but we have to consider that reducing much more radiation to the buildings make another sick building syndromes. So this is my first experience about how to calculate the facade of the building. So we are using the overall thermal transfer value, or OTTV, to make that the radiation is very important to the facade of the buildings. So we use the meshing concept, and using the Galapagos and ladybugs in this simulation to make that the formula of the OTTV, we put the formula of the OTTV in this parameters and in these applications, grasshopper, and we calculate how the penetrations of the radiations in the facades of the buildings. So we use all analysis of the OTTV, and using all the parameter of the OTTV, and we make it the facade concept to design the forms of the facades. So this is the Galapagos and ladybugs that we use, rhinoceros, grasshoppers, and this is the results of the variables that from the south to the west of the facade of the building, how that the facade is penetrated by the radiations actually. And this is the result how the radiations penetrate to the facade of the building with the sums of forms of the meshings of the buildings. And we design about the facade, how the facade is designed with the concept of the OTTV. And this is the concept, the basic concept of the OTTV that we used previously. And we using the WWR, window to walls ratio, to make that the penetrations of the radiation can be controlled to the indoors of the buildings. And this is the results of the facade of the buildings according to the locations. So we can make that applications to be anywhere in Indonesia, and using that applications to design the facade more effectively to make that the penetrations of the radiation not just affect to the indoor of the buildings, but they have a benefit to the building itself. This is the results. And another things, this is prototyping that finished by Rahma. And we use the Arduino at that times, and this is adaptable facades that can have some kinetic application at that times, mechatronic system in this facade. And this facade is adaptable when there is penetrations of radiation from the suns. And this is the result, and already published in Building and Environment. And I think you can see these papers though. And we use the projections of ISA and SDA to see that there is some effect or not when there is a sun that penetrates to the facade of the buildings. The shading itself is a self-shading, is a flat shading. This is the prototypings of number 2. And this is the prototyping of number 3. We use the tensile that can move back and forth, and use the Arduino to make that the tensiles can be something like that. This is the prototyping, and we use the openings of the tensiles to reduce the penetrations of the radiations that have some effect to inside of the building or indoor in the building, something like that. And we use the Arduino, how to control the Arduino, and we use affordables, very affordable mechatronic that can be found in the market actually, and it's not so expensive. It's very low cost, and using that mechatronic system to be used to make that this facade is more adaptive to the sensor of the radiations of the sun. This is the system of the Arduino, and actually I have I have the video, but maybe later I will show you the video if you want. This is the simulations. This is how the Arduino input, the process, and the output can make that adaptable facade. And this is the result when there is some openings from the tensiles of the facade for the illuminance. This is the spatial daylight autonomy. It's very nice, and the effects for the indoor is have already finished, and we know that this is a very effective facade. And this is the daylight factors. Another one's annual sunlight exposure. This is for the glare, and there is no glare. And we use another simulations. We butterfly to know what about the temperatures outdoor and indoors. And this is the CFD simulation. Use the butterfly tool that have correlation with the grasshopper, and this is the result of the wind flow inside of the buildings. This is the simulation for the CFD, and this is the prototypings. This is the system of the Arduino that we fix another. Actually, there is some problem, and we already fixed the component for these ones. And this is validations, and this is how they actually done. And this is the fourth prototypings of my adaptive facade. And the last one, this is the fifth prototypings. We use the pumps to connect the mechatronic, because the last for prototyping, the energy used to make to control the adaptive facade is very high. So we use the pump, and we know that the pump is more convenient and less using energy. So this is very important to us to understand how actually the pump can be used. So we use the pneumatic pneufins to switching and folding soft pneumatic adaptive system. So it's like a balloon, So when we pump the balloon, so the opens can be closed for 100%, and we reduce the balloon, the open is more open. Yeah. We use like this one to move the balloons and to move the some penetrations to make that have open or close, something like that. And
Adoni, could you speed up a little bit more?
This is the last ones. We use the origami systems for the facade kinetic. And I think this is the result, so we can discuss about this one for and we want to make some collaborations with another research. So we use the alga research to be our facade system. It's still on progress. Yeah. Thank you very much.
Thank you very much, Pak Doni. Please give applause for very interesting research project. So I would like to open the time for question and answers. Maybe this time I would like to open for 2 questions. So please raise your hand. Okay, we have one over there. Okay, please say your name, your institution, and to whom your questions will be delivered.
Good morning. Thank you for the chance. I'm Sandika from Directorate General of Housing, Ministry of Public Works and Housing. I would like to ask some question for Pak Doni. Good morning, Pak Doni. The research is so impressive, but I'd like to know more about the distance between buildings. Is the distance between buildings taken into account in the simulation? And how much the ideal space between building to get the maximum or optimum daylight? And the last one is, I think the prototype is using fabric, so can you explain more about the maintenance? Because I think fabric is quite delicate, so is it suitable to be applied in high-rise building? Thank you.
Okay, maybe Pak Doni, you can answer directly.
Okay, thank you very much for the questions. For the first questions about the distance between the buildings. So actually we have to simulate about that once, yeah. Because so there is so many simulations applications for free for simulate the how actually the good distance between the buildings. Because we have to know about how the radiations and how actually the rotations of the suns at that times and what the orientations of the buildings. But according to my research, we have to calculate about the H per W, H per W. I mean the height of the buildings and the width of the corridors. So we have to consider about that ones. Actually, there is a standard of H per W, but in Indonesia there is still no standard about that ones. So it is important when you have to design the messings, more than one messings of the building. So you have to consider about the distance between the buildings. So using the applications for free. There is so many applications that you can. I use the free applications. Namely, is I think Andrew Mars web base. You can use that ones. Andrew Mars web base. So the second question is about the tensile. That's very important questions. Because we still don't know about that one. We still going what kind of the tensile that we want to use to make the facade, the adaptive facade. That's our experience is more low maintenance. But the important things when you design the facade, the thickness of the facade is more important to calculate the penetrations of the radiations.
Thickness of
the thickness
wall,
not the thickness of the wall, but the thickness of the facade itself.
Oh.
Yeah, horizontal thickness, not the vertical thickness. So when you design the secondary layers of the facade, just like the walls, there is no effect. That's my experience. Yeah, about the daylight. Yeah. Thank you.
So it's a matter of the aspect ratio of the wall and the alley, and also the depth
thickness
of the building. Yeah.
Yeah, horizontally. Okay. So I mean, 120 centimeters is more convenient for the thickness of when there is a light come from outside to inside of the buildings.
Okay.
Yeah.
Thank you, Pak Doni. I hope that answers your questions. So I would like to move on and deliver the questions from our online participants. There are two similar questions from Sindu, Pak Sindu in Tokyo and also Pak Agung in Tokyo. They both, maybe Kita Gawasan can answer this question, maybe Pak Andika also can give additional response. Yeah. So their question is about how can the passive design and natural ventilation works, not only considering the thermal comfort, but other urban environmental issue, for example, air pollutions and also noise. So maybe Kita Gawasan can answer about the natural ventilation, and Andika-san can answer about the passive design in general by considering those aspects.
Yes, thank you for asking the question. I think yes, passive cooling is not completely a perfect answer. There is still some disadvantage. Like even in terms of thermal comfort, for our study, the maximum annual thermal comfort period is still approximately 80%. So less than 20% the occupants cannot satisfy the thermal comfort. So now I try to develop another cooling system combined with active cooling system. So sometimes it's really difficult to use the natural ventilation alone to satisfy the thermal comfort. So in this case, yes, we have to consider to use the active cooling system. And yes, of course, to design the passive design, we have to consider the other problem like, yeah, as you say, the air pollution and noise. So, and of course, the lifestyle is really important when you design using the passive cooling, because in Indonesia, the typical lifestyle is closing window during the nighttime, right? Am I right? So that's why, yes, this is the just answer from the single aspect. But if we want to apply in the real situation, we have to consider from the multiple perspective, from the air, from the thermal comfort, from the lighting, from the visibility, and from the lifestyle. So we have to consider all the aspects, and then we can find the optimum solution in the future. So my research is still ongoing.
Yeah, thank you, Kita Gawasan.
Yeah, thank you. Maybe I can add something to his.
One more question specific for Pak Andika, yeah.
Oh, really?
Passive design cross budget also.
Budget.
There's another question from Pak Agung, our online participants.
Wow, nice question. Okay, to be add a comment from Kita Gawasan. Yes, it is indeed that passive design that we are talking about. Like, we are focusing on how to reduce the use of energy, for instance, how to support the program of low carbon development. So, but as Kita Gawasan mentioned, there are many other aspects, many other dimensions that we need to consider. Like one of them related with air pollution, of course, the indoor air quality, that can be some kind of trade-off. So whether we open the window, then suddenly the air will be changed from outdoor to indoor. Then we need also to consider the level of the outdoor air, also the quality of the outdoor, whether it will worsen the condition of the indoor air quality or it will be improved or something like that. So there will be many other aspects that need to be considered, as also the social aspects as mentioned, maybe about the safety aspects, lighting, everything. So yeah, there will be many more aspects that still need to be reconsidered for the passive design techniques to be used. For the budgeting, yes, for the budgeting, one of the study that conducted in the Hiroshima University is the passive design studies, comparing the level of performance of the some clustered passive design approach, and also to be compared with the budgets. As we all know, I forgot to mention on the presentation that we will need to propose which one has the highest performance, but under the very lowest budget. So that is the combination that we are going to propose for the modified base model for the future Rusunawa prototypes. I think that's it.
Okay, thank you very much for the answers. For Bu Windy and Kondo-san, actually there's a long questions online from our online participants, but we cannot share this in this session because our time is very limited. So I hope you can respond to other questions online, yeah? So again, please give applause for our speakers. And this is the end of the first part of the development of passive cooling techniques for apartments in hot, humid climates of Indonesia. Thank you for your attention.
Thank you very much, Dr. Andang, for sharing the first session with very fruitful discussion. And once again, please give applause to Dr. Andang and all the speakers in this session. Ladies and gentlemen, I will deliver a little bit announcement. Tea and coffee has been already served in the next room at the right side. The participants can take the beverage, but please, after that, to have a seat back, because we will begin momentarily the second session. Thank you. Mohon izin Bapak Ibu, karena sebentar lagi akan dimulai sesi kedua, untuk Bapak Ibu yang ingin mengambil minuman, kopi, teh, bisa diambil di ruangan di sebelah kanan, tapi kembali dimohon untuk duduk kembali untuk mengikuti sesi kedua. Terima kasih. Ladies and gentlemen, move to the second session. We have 4 speakers and the session will be chaired by Professor Takashi Asawa. He is Associate Professor of Transdisciplinary Science and Engineering, Tokyo Institute of Technology, Japan. His specialization is urban and built environment, thermal environment, remote sensing, urban greening, and heat transfer simulation. As the first session, the second session, same, we have 75 minutes for this session, including 15 minutes for Q&A. Professor Asawa, time is yours.
Good morning. Okay, still morning. Okay, good morning, everyone. So this is a session of the development of passive cooling techniques for apartment in hot, humid climate in Indonesia, part 2. So this is Takashi Asawa as a kind of introduction. So I'd like to start this session. I think the previous session, as you know, is a very exciting and very attractive the session, so that I'd like to continue this intensive discussion and nice, the Q&A, even in this session. So, okay, so this session has 4 speakers. from the different institute and university and companies. So I'd like to invite first speaker, Muhammad Rajadi, Emir Rajadi from Tokyo Institute of Technology. Emir-san, please come here. He's come from PUPR, but he's a now student, my student, okay? So Emir-san, would you sit here? Okay, please do your best, okay? Okay. So second speaker is Professor Yukari Hirayama from Kogakuin University. Hirayama-sensei, please come here. Okay, so third speaker is Amalia Nurana-san. Oh, sorry that I cannot pronounce. Amalia-san, please come here from YKKP. Okay, Amalia-san. Okay. And last presenter is Nasi-sensei, Professor Siri Nastiti, Ekasivis-sensei. Please come here and welcome Nasi-sensei. Okay. Okay, so same with the previous sessions, we have a 15 minutes presentation from each speaker, and just that we have discussion. Yes. Okay, so could you start the first speaker, Emir-san, for your presentation?
Good morning, everyone. My name is Muhammad Emir Hanif Rashadi. You can call me Emir. I'm currently a student in Asawa Sensei's lab, Tokyo Institute of Technology, but I am also part of Ministry of Public Works and Housing in Subdirectorate Building Reliability. And today's the research topic is about development of hybrid floor cooling system integrated with phase change materials in Indonesia. Okay, this is the content of the presentation: introduction, methodology, project resource, and next agenda. Before we started, this research is currently ongoing in Tegal Experimental House. Therefore, tomorrow, if we go to Tegal Experimental House, we can see the research tomorrow. Okay, this is the introduction. So the background of the research is because, as we all know, we currently feel that global warming is currently, we are currently feeling it, and building industry contribute 37% of global energy related to CO2 emissions. And also, Indonesia is the highest country in Asian region for greenhouse gas emission with 32.2% according to the reports. And the CO2 emission in buildings, the usage is for space cooling, and is the dominant source of electricity for the buildings. And also, it is currently predicted that energy consumption for cooling in Southeast Asia is rising to 7.5 times. Therefore, need to find a way to reduce the usage of space cooling or usually use air conditioning system in buildings. And to minimize this, using passive cooling techniques is one of the solutions. However, passive cooling techniques has disadvantages. One is very reliant on the microclimate on the location, because passive cooling maximizing climate around us to cool the buildings. However, if the location is not suitable, then using passive cooling can be limited. And also the spatial restriction, as we all know in Indonesia, to find a home and to build a buildings is very difficult because the land is already reserved, already built. Therefore, restriction of spatial. Therefore, one of the solution is to integrate it with active cooling system. Yeah, we cannot eliminate active cooling system, but we have to find ways to make it more efficient and effective to cool the buildings. And also, therefore, we propose a hybrid floor cooling system using the combination of air conditioner and also the night ventilation from the climate. Okay. This active cooling and passive cooling work out simultaneously, alternatively, to cool the room. And then this system will be installed in the floor. The lifestyle in Indonesia is inside the house. They mainly use bare feet to do their activities. So, if we use our bare feet and contact the floor, it will be like a contact cooling, and also with the air from bottom from underfloor to outside, we can also get the air, and to minimize the direct airflow from AC, and also cool air can accumulate lower part of the room, therefore reducing air conditioned space. And to store the cooled air, we use phase change materials. Phase change materials, if with the combined AC and ventilation, PCM can solidify throughout the nighttime. So at nighttime, the cooled air from AC and night ventilation will make the PCM from liquid phase to solid phase. And then when in its daytime, so the temperature becomes warmer, the PCM will change to solid phase, but also releasing the cool air inside. Okay, so the purpose of this study is to develop the hybrid underfloor cooling system and evaluate its thermal comfort and also its energy consumption. Okay, this is the methodology of the research. So the building that we use is Tegal Experimental House, located in city of Tegal. And this is the features of the building based on the typology of Indonesian apartment. This has 4-story buildings. And we have 2 different units, loft unit and standard unit, 2 bedrooms. There are 12 unit rooms. And also in each side there is void space that can facilitate airflow from outside to inside. Also there's a penthouse in the roof. For this research, hybrid underfloor cooling system, we will use standard unit, 2 bedrooms, located in the 2nd floor and the 1st floor. The 2nd floor will be the main unit, the place where we apply this system, and the 1st floor will be the reference unit. So to compare between these 2 units, and this is the bedroom and the living room. This is the floor plan. Okay, so this is the floor settings that we use. So we use some kind to protect from damage. So we use like a styrofoam as the base, and then after that we want, because with this underfloor cooling, we want to elevate the floor. So therefore we're using bricks as the foundation, and then after that, above that, we will use omega floor, the elevated floor. And then the omega floor will be covered with plastic sheet, and then inside we'll pour the PCM, and then after that finish it with material ceramic. There will be a picture that to illustrate more clearly. This is the unit setting. So this is the living room and the bedroom. So the bedroom is installed AC, air conditioner. And also we put a partition board. The AC is installed in the floor level, so not usually we install it in the ceiling level, but no, we install it in the floor level. So it's near our foot like this. It's around 12 centimeter high, 20 centimeter high. But in this underfloor, we installed the floor 12 centimeters. So we the body of the AC, the wind fin is directly into the underfloor of the system. So, and then we want to concentrate the airflow into the living room, because in the living room we will install the PCM. So the PCM is only installed in the living room. So we use partition board in the underfloor to concentrate the airflow into the living room and then going back into the bedroom. And then there's openings, air grills to supply air. And then return air can be obtained from the air-conditioned bedroom, so the energy efficiency of AC will be higher. Okay, there's a picture after this. Next, this is the PCM floor settings. So the omega floor, we set iron bar in the side, and then we prepare the plastic sheet to cover, and then inside we use the PCM paraffin. We pour the PCM paraffin in the plastic sheet, and like making like a square form like in the omega floor. And then after that we cover it again with the ceramic tile. So the final is like this picture. So this ceramic tile has PCM inside, and also the omega floor base. So the type of material we use for the PCM is paraffin. The melting temperature range is 29 to 30 degrees Celsius. Solid temperature range is 27 to 28. Installed amount roughly around 3 kilograms per meter per second, with square meters. Okay, this is the AC and fan we use. We use AC Panasonic, 1.5 PK, and also Panasonic fan. 2 fans are needed to reach 1,000 cmH. So this AC we use because if there is a power outage, it can have automatic recovery function. Okay, so to make them work simultaneously, alternatively, we use controller for AC and fan. So this controller will turn on the AC or the fan with a logic control. So for the AC, if the outdoor air reaches more than 27 degrees Celsius and it is nighttime, the AC will turn on, the fan will turn off. But if the outdoor temperature reaches below 27 degrees Celsius and nighttime, the AC will turn on and the fan will turn on. So we work alternatively between the active cooling and the passive cooling using this controller. And this is the sensor settings that we use. We use in the living room and the bedroom. Total we have 56 channels for GovTech and TND9, and also to measure its energy consumption we use electricity current for the AC and the fan. So we want to search the surface temperature, air temperature, global temperature, relative humidity, wind speed, and condensation. And also the 3D wind velocity. Okay, so this is the sensor settings for the tile. So because like this is a square, so we put a position of the sensors like this. Also, this is the simulation cases that we have done. We currently working in progress on the case 3, which was fan control. So the fan only works from 6 p.m. to 6 a.m. only nighttime. But we have done the case 1 closed window, which was the AC and the fan are controlled by the controller, where using this logic. So when it is nighttime from 6 p.m. to 6 a.m., if the outdoor temperature is more than 26.7 degrees Celsius, then the AC will turn on. But when...
Emerson, five more minutes.
Oh yeah, thank you. And then when it is less than 26.7 degrees Celsius, the AC will turn off and the fan will turn off. And then when it reaches daytime, 6 a.m., all of them will turn off. That's logical. Also, we have done the case 2. This is so the AC will turn on from 6 p.m. to 6 a.m. But in this presentation, we calculate the results only for case 1 closed window. Sorry. This is the thermal comfort evaluation. We use adaptive thermal comfort. We will calculate this mean radiant temperature, operative temperature, and also the operative % stability limit, and also its energy consumption. But for this presentation, we haven't done the calculation yet. This is the picture. So yeah, this is the progress, the work from day 1. So we put the styrofoam for the base floor, and then we put the bricks, and then this is the omega floor for the elevation floor. This is the underfloor space. This is the maintenance tile. So inside we will put another sensor, wind speed, and also its temperature. And this is in this sheet we will pour the PCM, and then also we finish it with ceramic tile. This is the fan. So the fan, we want to directly the airflow from outside, night ventilation, to the underfloor. We use reducer duct like this, so that it can focus on the underfloor of the system. So this is the final result. You can see it tomorrow in Tegal. This is for the bedroom system. So the installation of the AC is in the floor level, and also we make maintenance door for the AC. This is the installation of the Omega floor. And we didn't put PCM here. This is the outdoor supply air. The supply air from the AC. And this is the sensors for the bedroom. And this is the outdoor temperature sensor, so that this sensor will measure the temperature based on the logic. And this is the reference room. Okay, I have to fast after this, I'm sorry. Next. Next. Okay. Next, please. Next. This is the result. So this is to see if the AC and fan works simultaneously, alternatively. So this yellow line is when the temperature 27. So if this is the outdoor temperature, the blue one. If the outdoor temperature above the yellow line, then the AC will turn on. So this is slope like this. AC is working from 6 p.m. And then when it reaches below the green line, which was the set temperature for the fan will turn on. So below the fan will be turned on. So this one, like this, the fan turning on from, I think from 9 p.m. until 6 a.m. So AC and fan are working accordingly to the logic control based on the outdoor temperature. And as you can see, for the cooling power, the AC only until 4 kilowatt hour, and for the fan only until 1.75 roughly. And this is the effects. So we put sensors in the AC grill and door grill. So when it is 6 a.m., the temperature almost reaches 14 degrees Celsius for the AC, near the AC, and this is for the door. And this affected the surface temperature of the living room and the bedroom. So the surface temperature, average temperature difference for nighttime is around 0.21 degrees Celsius between the bedroom and the living room. And also in daytime, 1.2 degrees Celsius. So living room is cooler than the bedroom surface temperature. And also for the air temperature nighttime, bedroom is cooler because AC is turned on, and around 0.7 degrees Celsius.
Could you wrap up your presentation?
Yeah. And this is the PCM already solidified. 27 degrees Celsius is the solid temperature. And this is the picture of the PCM inside, but this is the trials. So I want to introduce you the PCM. This is the solid phase and this is the liquid phase. Okay, next. Sorry. This is the vertical temperature distribution. So in evening, we have difference around 0.7 degrees Celsius. So in this picture, our calculation is that living room can maintain the coolness of the temperature because of the addition of the PCM. So the tentative summary is AC and fan are working according to logic controller. Also, PCM affected the surface temperature and air temperature for the living room, with many living room becomes more cooler than the bedroom, because this case is still conducted, and also the window in the living room we set it to close. Therefore, the potential for ventilative cooling is still be increased. Okay, this is the next agenda, because it's still ongoing. Thank you very much for your attention. I'm sorry for the time.
Okay, thank you very much, Emir-san. Okay, so that we need to receive the questions after the oral presentation. So next speaker is Hirayama Sensei. So time is yours.
Is it okay? To begin my presentation, I would like to thank the organizers for such a wonderful seminar, and also giving me this valuable opportunity to give my presentation. Thank you. So to start my presentation, I would like to first point the characteristics of Indonesia in the perspective of climate and architecture. As Dewa-san gave a presentation yesterday, Indonesia's climate zone belongs to equatorial, highland tropical, monsoonal, and savanna. But most of them are warm to hot, but I think it is not too hot in perspective of thermal comfort. For example, in Japan, Tokyo, even it is at the end of the summer, yesterday's maximum temperature rose up to 35 degrees. And the summer in Japan is very hard. But compared to that, I found Indonesia's weather is much mild. And another point is that I think like measures to improve thermal comfort in Indonesia can focus on measures against heat, since there is no winter. For people living in Indonesia, you may think it's obvious, but it's very enviable from Japanese who have both hot summer and cold winter. And also in winter, also in Indonesia, during daytime when the air temperature increases, the wind velocity is relatively high and the relative humidity is relatively low, which means that there is a potential for greater use of passive cooling methods for low carbon affordable houses for a sustainable society, which is the theme of this symposium. And our building team has been focusing on experimental house, which is double-loaded apartment with a vertical void for natural ventilation. And thanks to Eko-san, understanding and cooperation, this experimental house was built in Tegao City in 2020. And many passive cooling methods are introduced in this experimental house, such as solar shading, natural ventilation, using close ventilation and temperature different ventilation, and also night ventilation, and heat and cold storage, and of course, high insulation. And since the experimental house was built, we have been conducting many measurements. But, for this year, one of the challenges is to add evaporative cooling in order to form cool spot in the pillory and also lower the air temperature flowing into the void. So today's contents are mainly three topics. The first is the characteristics of air temperature distribution of Tegao experimental house using the measurement data taken in 2022, last year. And the second is the characteristics of ventilation distribution of Tegao experimental house by using the thermal and ventilation network simulation. It is evaluated by the simulation, but the data from 2022, experimental data from 2022 is used for the validation of this simulation model. And the third is about the evaporative cooling method, but it will be a prompt report since we have just started this theme. Okay, so for the first topic, here is the description of the experimental house, which Emerson has just introduced as well. But here I show the main measurement points that I used for my data analysis. The representative air temperature for each residential room was measured at the height of 1 meter from the floor level. And for the void, 8 points at different heights were measured to clarify the vertical distribution of air temperature. And for window conditions, all windows were opened at case 1 and all windows were closed at case 2, including the rooftop. And here is the result of air temperature distribution for each residential room on the left graph and for the void on the right graph. So during case 1, when windows were fully opened, air temperature varied widely within a room as outdoor air temperature showed daily variation. But the temperature differences between the rooms were fairly small. But during case 2, when windows were fully closed, air temperature's fluctuation decreased within a room, but the minimum temperature increased, as you can see with the red arrows. And the same trend can be seen for void. The mean and minimum temperature is higher at higher floors, well, especially under windows closed conditions. This indicates that adaptive passive cooling methods such as cold storage become difficult to use. So it is important to verify the good window opening pattern with the consideration of other passive cooling techniques. Okay, the second topic is the thermal and ventilation network simulation. For simulation, ASIM software was used. And for building thermal simulation, a thermal node is set for each wall, floor, ceiling, openings, and ground, and heat flow was calculated among these nodes. For ventilation network simulation, air volume passing the openings is calculated depending on each open ratio. And in addition, outside wind velocity and its temperature is considered to calculate the pressure difference between inside and outside the building. And here is the model of the simulation of Tegao experimental house. Rooms, void, and rooftop windows were all reproduced. And the result of the air temperature showed a similar tendency with the experimental results, well, of course, with an error range of 0.3 to 0.8 degrees, which I think is enough accurate to evaluate the thermal comfort. And for case one, when all the windows are opened, room's temperature were close to the outdoor air temperature. But during nighttime, room temperature in standard rooms did not decrease as much as in loft rooms. I think this is because the wind direction during night is from the south, and the loft rooms face south, which is in the windward side. So only loft rooms succeeded in gaining enough outside airflow. And moreover, when you look at the air temperature during the daytime, both rooms and voids temperature are lower than the outside air temperature. It's just about 1 degree lower, but it is important that it's lower than outside. And this indicates the cool storage effect of the building. So, as the brief summary of the experiment and simulation result, I would like to denote our goal. We are aiming to enhance the cool storage effect and also to use this cool air to achieve thermal comfort in each rooms. In order to do so, we are thinking that it is important to develop a window opening logic which is not only for a single room, but optimized as a whole building. So here's another result of the simulation, which is showing the average ventilation amount during daytime and nighttime when all windows are opened. According to the dominant wind direction, airflow is from north to south during daytime and south to north during nighttime. Moreover, you can see the airflow of the void entering from the bottom and going out from the rooftop. This is a simple case with all windows opened, but since we finished validating this model with the actual experimental result, which we took last year, we are now conducting several cases with different window opening patterns to achieve the logic.
5 minutes, rest.
And the last topic, but not the least, the third topic is about evaporative cooling method. This is a topic that we just started, so the presentation today will be a prompt report of this year. For the evaporative cooling methods, we are expecting cool air accumulation and cool radiation with natural ventilation around the bricks. And the target area is in the purity in order to enhance the thermal amenity of purity and also to cool the air flowing into the void. But before building the evaporative cooling wall on site, We measured surface ratio and water absorption ability of several blocks because surface area is very important in the point of heat exchange between wet, cool surface and air. Water absorption amount affects the duration time of evaporation after stopping water supply, and also it is an indirect index for water diffusion to wet the brick's surface. Because the point of evaporation is that it is very difficult to wet the entire surface because water usually flow on the same place and not the entire bricks. So these bricks need certain amount of absorbing ability as well. And according to the result, as you can see, the number 1 flower type brick had the largest surface ratio of 2.41 and absorbed water quickly, as shown in the blue line. And it absorbed quickly but became stable after 20 minutes. So we chose number 1 flower type as evaporative cooling bricks. And this is the ideal plan for evaporative cooling wall in the Tegao experimental house in order to accumulate cool air impurity. The ideal image of evaporative cooling wall is to surround the purity, but for this year, since this is the first trial, we plan to build a small mock-up of 1.8 meter at the corner of the purity. The height of the wall was restrained to 1 meter above this, so that the wall doesn't disturb the airflow flowing into the void. And this is the design of the evaporative cooling wall with the flower bricks. And the right is the photo taken on September 1st, which is 5 days ago. And after this photo, TIT team and HU team helped us kind of finishing building up these bricks. So when we visit Tegao experimental house tomorrow, hopefully we can see this evaporative cooling wall built up and also enjoy the cool air passing through this wall.
2 minutes.
2 minutes. So that's all for my presentation, and this is the summary. Today I introduced the Tegao experimental house's air temperature distribution and also ventilation characteristics. And for next step, I'm thinking of combining it with evaporative cooling methods and even cooler the air in the void so that each room can achieve comfortable air, cool air, and also good airflow condition by the optimized window opening patterns. Thank you.
Thank you very much, Hirano-sensei. Very interesting presentations. Next speaker is Miss Amalia from YKKP. So, could you prepare for your presentation? Oh, yeah, okay. So, time is yours. Please
Okay, good afternoon, everyone. My name is Amalia Nurjana, and I'm from YKKAP R&D Center Indonesia. And here I would like to present our research result with the title of CFD simulation on ventilation performance of existing apartment building in Indonesia. So let me start from the background. So this is the thermal performance of the existing apartment in Indonesia that conducted by Dr. Ariel at 2017. And then the result shows that the old public apartment in Indonesia experienced a thermal discomfort up to 48.9%, while in the private apartment, for the middle class, it much higher. It reached up to 72.4%. And in regards to the private apartment, we also could see that there is a higher indoor air temperature, up to 2 degrees Celsius than the outdoor air temperature. And this condition would lead to the excessive use of the AC utilizations, and we need to suppress the use of the AC, and one of the mitigations or one of the solutions to suppress the use of the aircon is a hybrid cooling concept. So basically in the hybrid cooling concept, one of the approaching method is we can implement the active and also the passive cooling at the two separated rooms. So as illustrated in the picture, we can see that in the active cooling, the AC room are designed to maintain a minimum cooling loss and also the heat gain. So we need to maintain the room has a well air tightness. So for instance, we can use the internal insulation in order to maintain the air tightness. And then in the non-AC or naturally ventilated room is designed to operate with a natural ventilation, so we need to maximize the natural ventilations, and also we could equip with several features to prevent the excessive heat gain from the outside by using shading and also the external insulation and also the high performance glass. And in regards to the natural ventilations, it's very important to provide a high indoor air speed, because the elevated indoor air speed could increase the upper limit of the thermal comfort. For instance, if we could provide 1.2 meter per second of the indoor air speed, we could increase the thermal comfort limit up to 2.2 degrees Celsius. However, it's quite challenging because the indoor air speed performance is very dependent on the external and also the internal factors. For the external factors such as the wind flow around the building, and in the internal factors such as the floor plans and also the opening configurations. And we will focus on the internal factor, so we want to reveal the ventilation performance of the existing unit floor plans and also the opening configurations as the basis for the future improvement. So in order to achieve these goals, we conduct several studies, including the typological study of the middle class apartment and also CFD simulations of the unit floor plan. So basically in the typological study, we expect to obtain the typical design of the building and unit floor plan and also the opening, including its size and also its types. And also in the CFD simulations, we expect to obtain the ventilation performance of each unit floor plan under several ventilation mode. And here is the result for the typological study of the middle class apartment in Indonesia. So we have conducted a survey at the 200 units of the apartment, which located at the several cities in Indonesia. And then the result shows that double-loaded corridor are mostly used as the building layout. And then we also found that there are 4 dominant layouts for the 2 bedroom types. And then for the typical window, we found that top hung window is more preferable to be used at the typical apartment, and also the combination between top hung window and also fixed window. While for the typical door, as we can see in here, that we have a full panel door that mostly used as the entrance door, while the glass door is commonly used as the balcony door. And then the result of the typological study will become as the input for the CFD simulation model. So here is the typical building. So this is a 5 stories building, and it's also using a double-loaded corridor, and we have 8 evaluated units which located at the 3rd and also 5th floor. And this is the typical unit floor plans. As I mentioned before, that we have 4 layouts in here, and we also want to assess additional layout, which is layout number 5. This is a typical layout that commonly found in the Rusunawa. And for the typical window and doors, we have a door number 1 and door number 2. This is a full panel door that installed at the entrance door and also the interior door, while door 3 and 4 commonly used at the balcony door. And for the window, it mostly used as the bedroom window or LDK window, while the Buffenlicht window is used for the bathrooms. And here is the detailed setting of the CFD simulation. So we need to set the wind conditions, including wind speed, environment conditions, and so on. And we also need to set the analysis type, thermal condition, and so on. And here is the case design. So basically we will evaluate the 5 typical floor plans under 4 simulation mode. I mean the four ventilation mode. The first one is opening only, because we didn't install the window and also door. But in the case 2, we install the door and also the window, but under open conditions. So we call it as the cross ventilations. And then in the case 3, we will close the entrance door. So we will evaluate the single side ventilation. While in the case 4, we will close all of the door, including the interior doors and also the entrance door. So we will operate the window only. That's why we call it as the window only. And then for the evaluation parameters, we have 2 parameters in here. The first one is indoor airspeed, and then the second one is the air change rate per hour. So basically, in the indoor airspeed, we will evaluate the indoor airspeed at 1.2 meter from the floor, and then we will categorize the indoor airspeed into not good, moderate, and also best. If the indoor airspeed below 0.2 meter per second, then it will be classified as NG or not good, and it will be classified as moderate if the indoor airspeed range from 0.2 until 0.4, and it will be classified as best if it's higher or more than 0.4 meter per second. And for the air change rate, we will classify based on its functions. The first one is to remove the heat inside of the room. So we need to provide the air change rate more than 150 per hour. But for the indoor air quality, it should be higher for more than 4 air change rate per hour. And here is the result for the air change rate per hour for the living dining kitchen or LDK, bedroom 1 and also the bedroom 2. Bedroom 1 has a larger size, but the bedroom is the smaller one. And then as you can see, the x-axis is percentage of the unit that could fulfill the requirement for the thermal comfort, indoor air quality, and also the unit that could not meet to the both requirement, which represent by the gray color, or we call it as NG. And then as we can see at the LDK, under the opening only and also cross ventilations, all layout have satisfied the thermal comfort and also the indoor air quality. But under single side ventilations, most of the layouts could meet to the indoor air quality requirement, but could not meet to the thermal comfort requirement. And under bedroom number 1, as we can see, under opening only and cross ventilations and also single side ventilations, almost all of the layout have satisfied the indoor air quality, but only layout 2 that could satisfy the thermal comfort requirement. And then for the bedroom number 2, under cross ventilations and also single side ventilations, only layout 2 and 5 that could achieve the indoor air quality requirement or higher than 4 air change rate per hour. This is because there is a exterior window at this room at the layout 2 and 5. But under the window only, it's very challenging to provide air change rate. So both requirements could not be achieved in all layouts at the LDK, bedroom number 1 and also bedroom number 2. And here is the result for the indoor airspeed. As I mentioned before, that we will classify the indoor airspeed into good, moderate, and also NG, which represent by the green, blue, and gray color respectively. And then as we can see at the LDK, most of the layout have a moderate airspeed until good indoor airspeed. And then in the bedroom number 1, under the opening only and cross ventilation and also single side ventilations, most of the layout have a very small airspeed, which is below 0.2 meter per second, but only layout 2 that has a moderate airspeed. And in the bedroom number 2, under all ventilation mode, all layouts have a relatively small airspeed. And in the single side ventilations and also window only, all layouts have a relatively small airspeed. And here is the detailed result of the effect of the unit floor plan on the ventilation performance. So basically the result shows, if we take a look at the case 3 and also case 2, in the case 3 we close the entrance door, but in the case 2 we open the entrance door. And if we focus on the case 3, we could see that layout 2 and 5 have a good performance in all rooms. I mean a better performance than the other layout. So if we take a look at the LDK, most of the layout have the air change rate more than 5 per hour. And in the bedroom number 1, it's also relatively high, it's more than 1 air change rate. But in the bedroom number 2, the air change rate is relatively lower. It's below 0.1 air change rate per hour, especially at the layout 1, 3, and 4. However, the exceptional result could be seen at the layout 2 and layout 5. As we can see at the bedroom number 2, the air change rate is up to 6 air change rate per hour, while in the layout 5, the bedroom number 2 has a 5 air change rate per hour. This is because the availability of the exterior window at the bedroom 2. And then if we compare the case 3 and also the case 2, we could see the effect of the opening at the corridor side. We could, if we open the entrance door or opening near to the corridor side, we could improve the ventilation performance up to 148 times higher. So if you take a look at the layout 1, at the bedroom 2, if we close the entrance door, the air change rate is 0.05 per hour. But after we open the entrance door, the air change rate increased up to 4 air change rate per hour. And here is the detailed result to know the effect of the airflow passage on the ventilation performance. So we will compare the case with the interior door are in the closed condition, while in the case 3 we open all of the interior door condition. We open all of the interior door, but the entrance door is remain closed. And then the result shows that creating the air passage, or by open all of the interior door, we could increase the air change rate up to 85 times higher than the other unit. Then unit with a divider or obstructions. So if we take a look at the bedroom number 1 at the layout 1, we could see that the air change rate, if we close the door, it's around of 0.05 air change rate per hour. But if we open, there is an increment up to 85 times higher, and then the air change rate increased up to 2.5 air change rate per hour. And here is the effect of the opening configuration on the ventilation performance. So we want to know the effect of the window type on the ventilation performance. So we will compare the case number 1 and also case number 2. These two have a cross ventilation mode, but in the case 1 we didn't install window, but in the case 2 we install the top hang window. And then the result shows that after we install the top hang window, there is a reduction of the ventilation performance up to 60%. This is because a smaller effective opening area of the top hang window, and also improper design to catch the incoming wind at this unit. And then this is the summary. So for the ventilation performance of each layout varies depending on the ventilation mode, and under 4 ventilation mode, layout 2 and 5 have a better ventilation performance than the other layouts. And in regards to the unit floor plan, the interior wall and furniture need to be carefully arranged to optimize the air circulation in the unit. And also for the opening configurations, the availability of the opening toward the outdoor in each room is necessary to provide a sufficient ventilations. And under single side ventilation mode, it's recommended to provide more than 1 opening on the exterior wall. And then the last one is the selections of the window type need to be considered to optimize the overall ventilation performance. Maybe that's all. Thank you very much.
Thank you very much, Amaria-san. So thank you very much for the very, how to say, the systematic typology and the systematic simulations for achieving the nice window conditions for natural ventilations. Okay, so let's move to the next speaker. Final speaker of this morning session is the Professor Nasi-sensei. Okay, could you present at the time? Okay, could you use that microphone? Are you ready for the presentation? Okay. Could you start?
Good afternoon, everyone. Thank you for organizer that giving me the opportunity to present the part of the research, main research that proposed by Asawa Sensei Lab. That is the effect of contact cooling for bare feet using floor cooling system on human thermal physiology and comfort sensation in humid tropic Surabaya. Actually, the main topic, the effect of contact cooling for bare feet, conduct in 4 locations that by Asawa Sensei Lab is for Japan, and then Yogyakarta by Bu Unan and team, and in Bandung by Pak Aril and team, and in Surabaya is our team that is state and the author of the paper or PowerPoint slides. PowerPoint. Next, please. Yeah, the background is yeah, you have the abstracted IT create. Lying or sitting on the floor without mat or walking bare feet is known as residence habit in tropical regions from ancient, such as Indonesia. A comfort feeling is perceived due to a cool sensation when part of the skin has direct contact with the floor surface. The floor materials that used in housing, which are commonly applied in housing, support this condition, which in turn will produce a sensation of comfort for the occupant. The habit of barefoot is a response to the thermal discomfort of the tropics in naturally ventilated dwelling. This is because the room temperature fluctuates and is often above the comfortable temperature range. That is the comfort sensation feels by the residents. Nowadays, the habit is still continuing or ongoing, even though in houses with air conditioning, where the preference of room, actually the residents can set, and then in the tropical region or in Indonesia, the residents prefer to set the room temperature lower. And the human body can regulate and respond to the thermal environment received by the skin surface to maintain a normal body temperature. The aims of the experiment are to investigate how thermal physiology parameters are influenced and how the sensation of the comfort occurs before the feet contact with the floor and in the state of the contact of in the floor surface, especially in the case of air-conditioned room. Yeah. First, I try to explain the method. That is, the experiment is conducted in one of the rooms of the experimental houses, or we known as Eco House at ITS. And here is the building, and the room is formed to a small room and conditioned with AC, and the experimental room is set like this. That is, we follow the main research by Asawa Sensei Lab. Then the respondent should contact the step on the floor material. That is, we call it cooling with cooling system, and then the other surface without the cooling system. That is the experimental room designed like this. And the experiment plan, the whole experiment plan consists of 6 cases. The case 1, 2, and 3, we consider that as the room temperature or air temperature is high, and the second group, the case 4, 5, and 6, we consider the air temperature very low, and we assume that is the condition in air-conditioned room in that prefer choose in tropical region or in by the resident in tropical region. That is the condition that the second group, we focus on the second group. Then this is a part of the main research topic that Asawa Sensei's design. Yeah, for the second group, that we consider the air temperature and floor temperature are the same. That is the high 24 degrees Celsius. And the case 5, we consider that the air temperature or floor temperature is lower than the air temperature. And the case 6, both air temperature and floor temperature are very low. And we maintain the relative humidity in 50%. And the thermal physiology parameter are mean skin temperature, salt temperature, that is from the food, and core temperature is the body temperature, and the heat flow and blood flow and blood flow index. And we survey about the thermal sensation. That is a subjective measurement by the with the questionnaire. And the respondent and participant, we measure 10 males and 10 females. So that is the sensor placement in the body on the body of the respondent, and the sensor in the salt to measure the salt temperature, and the core temperature we measure inside the mouth. Yeah, the experiment procedure of the subjective measurement, we measure, sorry. We measure the step before the feet step on the 30 minutes before measurement or before the step contact to the floor panel, and then until every 30 minutes, 120 minutes contact to the floor panel, and we measure the behavior. Contact with the floor cooling 30 minutes. The feet is not contact to the floor cooling from the 30 minutes to 120, and the measure of the measuring the core temperature and the sensation. The respondent should answer the questionnaire vary about 5 minutes. That will be questions about thermal sensation in 9-point scale.
Necessity, excuse me, 5 minutes, let's.
Yeah. Yeah. the condition of the room, yeah, we have difficulties to make the precise design temperatures that we design, but it is okay that here is the reality of the measurement of the experiment. Yeah, the result is the mean skin temperature. The red one, the red line, the vertical red line, is the the 30 minutes first before contacting the floor panel. That is the floor panel is cooled by the temperature, the low temperature of the floor panel will be contacted by the respondent, and here the left side is the for male respondent, and the right side is the female respondent. Yeah, and the result is about the mean skin temperature tend to decrease when exposed to room and floor condition. That means in case, the first line or first curve is for the case 4, there is the higher temperature. This is the same floor temperature and room temperature are the same, and the yellow is about for the room temperature is higher than floor temperature, and the blue one is the same temperature, floor temperature, and the room temperature are the same but is very low. That is, the condition is the female and male, or the case 6, the low temperature when the skin, the foot contact to the floor panel, the temperature, skin temperature decrease faster than in case 4 and 5.
That's it. 2 minutes.
Yeah. Well, how about the soil temperature? The soil temperature is the foot, the skin surface of the foot temperature of the foot surface. After contact with the floor, the soil temperature tends to be decreased in all cases with floor temperature are different. And the case 5 and the case 6 has the lowest temperature than the others. But the core temperatures maintained in the healthy temperature 36 until 37. That means by touching the low temperature, floor temperature, that the body temperature is maintained health or in the health condition. Oh, sorry. Yeah. Here is blood flow index. The blood flow index of male was higher than the female. In the case of the case 6, tend to be the same as the case 4 and 5. And here, the thermal sensation, we can show, we can see that here the female and male, and here the second case, the case 5, female and male also, and female and male also. We can see that the thermal sensation of the whole body temperature, that the mean body temperature, shown that there is a low air temperature and the floor temperature. And the thermal sensation for legs shown that if there is a low air temperature and floor temperature, that means the case 6, the thermal sensation will be getting low or colder, which is decreasing for the female is larger than the male.
Nasitha, could you wrap up the presentation?
Here is the thermal sensation. The thermal sensation for the case 6 is very low, and for the skin temperature and the soil temperature is also the case 6 is very low, and the correlation of the blood and soil skin temperature is like this. Yeah, the summary, the core temperature or human body temperature is the most stable temperature, higher than it is higher than the skin temperature and soil temperature. The soil temperature drops rapidly when the soil contact with the floor. This shows that the soil respond quickly to low floor temperature and is not being affected by room temperature. Apart from that, the skin temperature decrease only in case 5. There is the difference between room temperature and floor panel. When the floor temperature was lower than air temperature, I mean like this, although the decrease was not as fast as that of the soil temperature. It indicates that the temperature respond more to air temperature than to floor temperature or floor panel. In case 4 and 6, the mean skin temperature of 1 to 2.5 higher in case 6 compared to case 4. Regarding the questionnaire result, the thermal sensation of the female response is more sensitive to changes. In case 5, where the floor temperature is lower compared to room temperature, the thermal sensation of the female respondent is higher than that of the male respondent. This can also indicate that the response to discomfort due to stepping on the cold floor will be felt in air-conditioned room with a floor temperature that is lower than room temperature, and also both room temperature and floor temperature are low. Thank you.
Thank you very much. Thank you very much for very detailed and important the research and the analysis. So this experiment is very, very difficult to get, but very nice data. Thank you very much your presentation and give us very nice information, important information. Okay, so I'd like to move to on the discussion sessions. So due to the limit of time, that I'd like to receive 2 questions and comments from audiences. Okay, using Sam, using Sam process with message.
Yeah, I want to ask a question to Dr. Yukari Hirayama. It's nice feature to put the terracotta as a cooling agent. The question is how to water the terracotta time by time. The first question, and then the second question, why don't you put also the terracotta at the balcony in every units at the facade, the wind from the facade also cooling the room, not only from the middle of the buildings. Thank you.
Okay, thank you for the question. For the water supply, we are using the tubes from the faucet, and then bringing the tube on the top row of the bricks, and dripping water just a little bit continuously. So after, so some will be evaporated and some will be absorbed to the bricks, and some will be, the surplus will be drained from the bottom, but a bit large amount of water needs to be supplied in order to let the bricks totally get wet and to have an efficient evaporation. And for the second question, for the balcony, I thought about it, but the wind direction changes during the day. So during the daytime is north and the nighttime is south. So some residents which has the big balcony on the north side can enjoy their cool air during the daytime, but not on the south side. So for all residents in the whole building to enjoy the cool airflow, I thought the bottom of the pilotis will be the best place so that it can provide cool air through the void.
Yeah, maybe you can put a small pond, under the terracotta walls, so you don't have to water time by time, but just let the water evaporate to the terracotta itself.
Thank you. Yeah. Yes, we are also measuring how up to which height can the water be absorbed and soaked up, and I think 1 meter. Maybe we tried up to 30 or 40 centimeters, but we haven't tested 1 meter yet. But I think it's important to have enough height so that we can feel the cool air, not only on the bottom, but can also feel the cool air. So if water can be soaked up to 1 meter or so, I think we can supply water from the bottom.
Thank you very much. Are there any questions? Okay. Ms. Aiko. Yeah, please.
Thank you for Dr. Hirayama. Based on your research, which one or where is the most comfortable unit for Tegal building? Which one, in the second floor or fourth floor, northern side or southern side? Because I think this, yeah, perhaps I will stay there, the most comfortable one. Thank you.
It's a difficult question to answer because I think there will be residents who will live in each room. So I don't want to give the concrete answer, but at this moment, with the situation right now, I think the southern room with the second floor, the first floor. Say the south has the loft room of 2 stories, so the one on the first story, I think, is the best. But I think it will change depending on how you open the windows and how you set the evaporative cooling and things. So at the moment, I think it has the high potential.
Okay, thank you very much. Okay, so the Takagi said small questions. Okay, so the time is almost limited. Okay, but could you give a short, Takagi-sensei?
Okay, thank you very much for the presentation. I just want to know that for Professor Hirayama Sensei, so that the mold, kabi, so mold will always happen in this kind of things. So how do you think? So it is outdoor, so that's okay, might be okay. But if you use the balcony, so the mold mixed air will come into the rooms. So that's one question. And another one is Andan-san.
Amari-san.
Amari-san, YKKP's. So when actually the natural ventilation was installed in the houses, so some previous speakers mentioned about the security or the safety or the preventing the mosquitoes or some other insect. So such kind of measures. So these measures will decrease the effect of the natural ventilation. So, will you consider such kind of measures? And as a YKKAP, are you going to develop such kind of product to this country or even for Japan?
Could you answer
For the
very shortly?
evaporative cooling bricks, I think they will be a must if the brick absorbs water too much. So that's why each brick's experiment to see how much water they absorb is important. They should be minimum amount of absorption. And the other method is to use photocatalyst. I've done in Japan using photocatalyst, and it works so well. And I've tried 5 years or so, but there's no moss or no any green things on the surface. So I think I will try it on the next step.
Okay, thank you for the questions. And I would like to confirm the first one is about the insect screen. Yes, we already have the insect screen that can be installed at our product, and it could be used during the night time in order to prevent the mosquito to enter the room, and it will help to the occupant to get the natural ventilation at night time, and it will give more benefit to the occupant. And in regards to the security, and I think we need to do some further study in regards to the window that maybe have a geometry that could secure the privacy, but also can provide a good natural ventilation. But also in our product also have a good security as well, to maintain the security.
Does your CFD analysis has already considered such kind of things?
No, we not assumes the insect screen, but of course there will be reductions because of the insect screen, because of the pressure loss.
Okay, thank you very much for your important comment. Oh, 2 more minutes. Okay, okay. So now that they can extend the time for the discussion for 2 more minutes. Thank you very much. Okay, so do you have any other questions or comments from the on-site audience or the online? From online, one question coming that for the Emil-san, for the first speaker, that are there any temperature difference between the PCM and the ceramic floor of the original the room? That I think that means that what is the effect of PCM on the floor surface temperature of that?
Okay, thank you very much, Mr. Pandu. Actually, in the slide I will tell you the difference, but limited time. So we compare between the reference room and the main room. What is the temperature? And it was found that the reference room is more hotter than the main room, the room that we use for the system, and it has average temperature differences around 2 degrees Celsius. So we have deficit 2 degrees Celsius for the difference of the temperature for daytime and nighttime. But this is only first case which we conducted, case 1 closed window, and we still have many cases to do. Therefore, the preliminary measurement is promising. So this PCM affected the surface temperature and the air temperature in the main room.
Okay, thank you for your answer. Are there any questions or comments? Okay, so I direct this. Okay, 1 minute, give me time. So now that we have a very, very nice and the passive cooling techniques, individual techniques, but finally that we want to combine and them for the buildings and integrate them into the designs. So I'd like to discuss with all of you to how to integrate them into the actual design, new design of buildings. So this means that the technology can enhance the design, and design can also accept the technologies. So I'd like to discuss such things in near future or within the period. Okay. So thank you very much. So please give a nice, great applause to the speakers. Thank you very much.
Thank you, Prof. Asawa, for sharing the second session, and thank you for all the speakers for sharing interesting findings. Let's applaud Prof. Takashi and all the speakers once again. There is an announcement from Dr. Ariel, please.
Ladies and gentlemen, good afternoon. Before we end the session and go to the lunch break and praying time, so I'd like to give two important announcement. One considering but this after the seminar we will have a social visit to the Kota Tua Semarang, old town of Semarang. So this is very interesting place. You can feel the sensation of the European city in Semarang because of Dutch colonialism. Anyway, so we provide the shuttle bus, and immediately after this seminar ends, so please, if you are interested in join with us, please enlist your name on the register list on the registration desk. So we can estimate about the departure time and also how many the shuttle bus can pick you up and so on. And the detail will be given in the end of the seminar. And the second this is special for those who will attend the GCC tomorrow in Tegal. So we also provide the shuttle bus, and we already enlisted the participants. So please be informed that we will depart in the start from Novotel, if I'm not mistaken, at 7:15, and then in the end from this hotel Patra at 8 AM. So I hope you will notice, and please be prepared at the time. That is the two announcement from me. Thank you very much, and I give back to the MC. Thank you very much.
Ladies and gentlemen, with the end of this session, we will be having a lunch break that will be served on the next room, just the right side. And for the participants who are attending an afternoon prayer, and the praying room is located at the left side, please be informed that the lunch break and praying time will take until 1:30 PM. So please reconvene in this room for the next session. I hope you enjoy the meal serve. See you then.
Kenal lebih dekat dengan Balai Sains Bangunan. Balai Sains Bangunan berlokasi di Jalan Panyaungan, Cileunyi Wetan, Kabupaten Bandung. Balai Sains Bangunan merupakan balai teknis di bawah naungan Direktorat Bina Teknik Pemukiman dan Perumahan, Direktorat Jenderal Cipta Karya, Kementerian Pekerjaan Umum dan Perumahan Rakyat. Kami berkomitmen untuk selalu memberikan pelayanan terbaik sesuai dengan standar yang telah ditetapkan, yaitu pengujian, advis teknis, serta bimbingan teknis.
Pelayanan publik yang profesional dan berkualitas selalu menjadi prioritas kami. Kami berkomitmen penuh untuk membangun zona integritas menuju wilayah bebas dari korupsi dan wilayah birokrasi bersih melayani.
Sesuai dengan tagline Balai Sains Bangunan, yaitu profesional, berintegritas, dan melayani.
Pengujian di Puskim bagus, kita punya lab yang lumayan lengkap dengan sampel yang cukup besar. Ya, kita sangat puas dengan pengujian di sana.
Mudah-mudahan kedepannya Balai Sains Bangunan tetap memberikan pelayanan yang sangat prima.
Saya ingin mengucapkan terima kasih kepada Balai Sains Bangunan yang telah mengadakan layanan bimbingan teknis internal dengan sangat baik. Materinya sangat bermanfaat dan membuka pengetahuan baru untuk saya.
Pesan saya terhadap pelayanan di sini adalah mereka cepat tanggap, mau membantu kami dengan cepat orang luar yang akan melakukan penelitian di sini.
Balai Sains prima.
Rupa rumah susun hemat energi dibangun dari hasil kerjasama penelitian antara Pusat Litbang Perumahan dan Permukiman Kementerian PUPR dengan Hiroshima University dan didukung oleh pemerintah Kota Tegal serta berbagai pihak baik dari Indonesia maupun dari Jepang. Rusun ini telah diresmikan oleh Wali Kota Tegal dan didampingi oleh Kementerian PUPR, Hiroshima University, dan LAPI ITB. Indonesia berkomitmen untuk memenuhi Paris Agreement 2030 terkait pengurangan karbon secara global melalui pengurangan konsumsi energi pada tahun 2030. Di sektor bangunan gedung, Kementerian PUPR terus melakukan inovasi untuk mengurangi konsumsi energi melalui pendekatan desain bangunan secara pasif tanpa mengorbankan kebutuhan kenyamanan penghuninya. Purwarupa Rusun Hemat Energi merupakan bangunan eksperimental yang dibangun sebagai sarana penelitian untuk mengkaji bagaimana bangunan memiliki kinerja termal yang baik melalui pendinginan pasif dan tanpa penggunaan energi berlebih untuk pendinginan udara. Teknik pendinginan pasif yang diterapkan meliputi ventilasi silang dengan memperbanyak bukaan pada dinding, penggunaan insulasi pada dinding bagian timur dan barat, penggunaan void dan ventilasi atap, dan penggunaan balkon dengan tipe penuh. Setelah melakukan analisis iklim setempat, diketahui bahwa kecepatan dan arah angin berbeda untuk kedua musim. Pada musim hujan, arah angin dapat menuju dua arah, yaitu utara atau selatan. Sedangkan pada musim kemarau, arah angin cenderung mengarah dari selatan ke utara. Dari analisis iklim tersebut, maka diperoleh orientasi bangunan rusun dan letak bukaan agar efek ventilasi optimum. Sistem ventilasi pada rusun ini sudah dirancang agar kenyamanan termal di dalam unit rusun dapat tercapai dengan menerapkan stack effect ventilation. Stack effect di ruang atap berfungsi untuk mendinginkan suhu udara agar dapat mengurangi atau mencegah peningkatan suhu ruang di bawahnya. Desain fasad bangunan dirancang untuk mengurangi panas di dalam unit rusun. Elemen-elemen tersebut meliputi peneduh eksternal, jendela dengan kisi-kisi untuk mengoptimumkan inlet udara, balkon sebagai zona thermal buffer yang dirancang untuk menghindari radiasi matahari langsung memasuki unit hunian dari segala arah. Prinsip radiant cooling pada rusun ini yaitu dengan menggunakan PCM untuk menyimpan panas ketika siang hari, dan ketika malam hari panas dibuang melalui radiant cooling berupa PCM atau phase change material yang dipasang di lantai. Selain itu, material insulasi juga dipasang pada atap untuk mengurangi penyerapan panas. Rusun ini juga menerapkan teknologi removable walls dengan tujuan apabila ingin merubah posisi jendela, maka dapat dilakukan dengan membongkar pasang dinding seperti Lego.
Direktorat Bina Teknik Permukiman dan Perumahan melaksanakan penjaminan mutu. Salah satunya melalui audit persyaratan mutu dan pengukuran rumah susun hemat energi Kota Tegal agar sesuai dengan persyaratan mutu bangunan. Kami berharap proses pengukuran termal eksperimental di rusun ini dapat memberikan kepuasan penghuni dan mendukung bangunan yang hemat energi untuk tujuan pembangunan yang berkelanjutan.
Hasil eksperimen ini diharapkan dapat menjadi referensi dan standar untuk perancangan bangunan apartemen maupun rusunami di masa depan.
There's a secret to modern life. A few, actually. Secrets that have been working hard for you for decades. Look closely and you will find them everywhere. They're in your walls, in greenhouses, on the trains and inside your wheels. They're in the ground. They're blocking sound, insulating, irrigating, purifying, fortifying, so you can focus and play and live and be happier. Getting on with what's most important to you without your surroundings getting in the way. And helping businesses thrive more efficiently while respecting the environment. For the last 80 years, we have been unlocking these secrets inside stone. And we found that by applying our curiosity, passion and knowledge, we could recreate stone's natural cycle and optimize the use of resources by converting waste into valuable material. Today, Stonewall improves people's work and well-being in all kinds of different ways. It plays a big part in making people's life richer, more productive and more beautiful wherever they might be. But we're sure there's more, and we are absolutely determined to find it, so we can do even more to improve life in societies around the world for decades to come. You might never see these secrets hidden around modern life, and you don't have to. We are proud that you experience their effects every day.
Kami percaya untuk membangun sesuatu yang luar biasa harus dimulai dari halaman rumah kita sendiri. Itulah yang kami lakukan di sini, di YKKAP. Di Indonesia, hanya YKKAP yang memiliki proses produksi terintegrasi, mencakup 8 fungsi utama. YKKAP melakukan riset mandiri di Indonesia yang berkolaborasi dengan lembaga pemerintah dan berbagai universitas terkemuka. Berdasarkan hasil riset R&D, kami mengembangkan produk secara mandiri. Hanya YKKAP di Indonesia yang dapat melakukan tes performa secara mandiri untuk memastikan kualitas terbaik di Indonesia. YKKAP mampu melebur ingot menjadi billet silinder secara mandiri. Proses ekstrusi di YKKAP dilakukan dengan standar teknologi Jepang. Proses anodizing di YKKAP adalah satu-satunya di Indonesia yang menggunakan teknologi electrodeposition 3 layer, memastikan produk tahan lebih lama. Kami menggunakan mesin khusus untuk proses produksi agar proses fabrikasi lebih akurat. Staf-staf terbaik YKKAP akan berbagi wawasan dan pengetahuan mereka. Hal ini dilakukan melalui site inspection, distributor training, dan metode pelatihan lainnya. Di Indonesia, hanya YKKAP yang memiliki 8 fungsi produksi terintegrasi untuk memastikan produk dengan kualitas tinggi. Sebagai bentuk kontribusi YKKAP dalam membangun ruang hidup dan masyarakat yang lebih baik. YKKAP, we build a better society through architectural products.
Mari kita kenal lebih dekat dengan Balai Sains Bangunan. Balai Sains Bangunan berlokasi di Jalan Panyaungan, Cileunyi Wetan, Kabupaten Bandung. Balai Sains Bangunan merupakan balai teknis di bawah naungan Direktorat Bina Teknik Pemukiman dan Perumahan, Direktorat Jenderal Cipta Karya, Kementerian Pekerjaan Umum dan Perumahan Rakyat. Kami berkomitmen untuk selalu memberikan pelayanan terbaik sesuai dengan standar yang telah ditetapkan, yaitu pengujian, advis teknis, serta bimbingan teknis.
Pelayanan publik yang profesional dan berkualitas selalu menjadi prioritas kami. Kami berkomitmen penuh untuk membangun zona integritas menuju wilayah bebas dari korupsi dan wilayah birokrasi bersih melayani.
Sesuai dengan tagline Balai Sains Bangunan, yaitu profesional, berintegritas, dan melayani.
bagus. Kita punya lab yang lumayan lengkap dengan sampel yang cukup besar. Ya, kita sangat puas dengan pengujian di sana.
Mudah-mudahan kedepannya Balai Sains Bangunan tetap memberikan pelayanan yang sangat prima.
Saya ingin mengucapkan terima kasih kepada Balai Sains Bangunan yang telah mengadakan layanan bimbingan teknis internal dengan sangat baik, materinya sangat bermanfaat dan membuka pengetahuan baru untuk saya.
Pesan saya terhadap pelayanan di sini adalah mereka cepat tanggap, mau membantu kami dengan cepat orang luar yang akan melakukan penelitian di sini.
Balai Sains prima.
Purwarupa rumah susun hemat energi dibangun dari hasil kerjasama penelitian antara Pusat Litbang Perumahan dan Permukiman Kementerian PUPR dengan Hiroshima University dan didukung oleh pemerintah Kota Tegal serta berbagai pihak baik dari Indonesia maupun dari Jepang. Rusun ini telah diresmikan oleh Wali Kota Tegal dan didampingi oleh Kementerian PUPR, Hiroshima University, dan LAPI ITB. Indonesia berkomitmen untuk memenuhi Paris Agreement 2030 terkait pengurangan karbon secara global melalui pengurangan konsumsi energi pada tahun 2030. Di sektor bangunan gedung, Kementerian PUPR terus melakukan inovasi untuk mengurangi konsumsi energi melalui pendekatan desain bangunan secara pasif tanpa mengorbankan kebutuhan kenyamanan penghuninya. Purwarupa Rusun Hemat Energi merupakan bangunan eksperimental yang dibangun sebagai sarana penelitian untuk mengkaji bagaimana bangunan memiliki kinerja termal yang baik melalui pendinginan pasif dan tanpa penggunaan energi berlebih untuk pendinginan udara. Teknik pendinginan pasif yang diterapkan meliputi ventilasi silang dengan memperbanyak bukaan pada dinding, penggunaan insulasi pada dinding bagian timur dan barat, penggunaan void dan ventilasi atap, dan penggunaan balkon dengan tipe penuh. Setelah melakukan analisis iklim setempat, diketahui bahwa kecepatan dan arah angin berbeda untuk kedua musim. Pada musim hujan, arah angin dapat menuju dua arah, yaitu utara atau selatan. Sedangkan pada musim kemarau, arah angin cenderung mengarah dari selatan ke utara. Dari analisis iklim tersebut, maka diperoleh orientasi bangunan rusun dan letak bukaan agar efek ventilasi optimum. Sistem ventilasi pada rusun ini sudah dirancang agar kenyamanan termal di dalam unit rusun dapat tercapai dengan menerapkan stack effect ventilation. Stack effect di ruang atap berfungsi untuk mendinginkan suhu udara agar dapat mengurangi atau mencegah peningkatan suhu ruang di bawahnya. Desain fasad bangunan dirancang untuk mengurangi panas di dalam unit rusun. Elemen-elemen tersebut meliputi peneduh eksternal, jendela dengan kisi-kisi untuk mengoptimumkan inlet udara, balkon sebagai zona thermal buffer yang dirancang untuk menghindari radiasi matahari langsung memasuki unit hunian dari segala arah. Prinsip radiant cooling pada rusun ini yaitu dengan menggunakan PCM untuk menyimpan panas ketika siang hari dan ketika malam hari panas dibuang melalui radiant cooling berupa PCM atau phase change material yang dipasang di lantai. Selain itu, material insulasi juga dipasang pada atap untuk mengurangi penyerapan panas. Rusun ini juga menerapkan teknologi removable walls dengan tujuan apabila ingin merubah posisi jendela, maka dapat dilakukan dengan membongkar pasang dinding seperti Lego.
Direktorat Bina Teknik Permukiman dan Perumahan melaksanakan penjaminan mutu. Salah satunya melalui audit persyaratan mutu dan pengukuran rumah susun hemat energi Kota Tegal agar sesuai dengan persyaratan mutu bangunan. Kami berharap proses pengukuran termal eksperimental di rusun ini dapat memberikan kepuasan penghuni dan mendukung bangunan yang hemat energi untuk tujuan pembangunan yang berkelanjutan.
Hasil eksperimen ini diharapkan dapat menjadi referensi dan standar untuk perancangan bangunan apartemen maupun rusunami di masa depan.
There's a secret to modern life. A few, actually. Secrets that have been working hard for you for decades. Look closely and you will find them everywhere. They're in your walls, in greenhouses, on the trains and inside your wheels. They're in the ground. They're blocking sound, insulating, irrigating, purifying, fortifying, so you can focus and play and live and be happier. Getting on with what's most important to you without your surroundings getting in the way. And helping businesses thrive more efficiently while respecting the environment. For the last 80 years, we have been unlocking these secrets inside stone. And we found that by applying our curiosity, passion and knowledge, we could recreate stone's natural cycle and optimize the use of resources by converting waste into valuable material. Today, stone wool improves people's work and well-being in all kinds of different ways. It plays a big part in making people's life richer, more productive and more beautiful wherever they might be. But we're sure there's more, and we are absolutely determined to find it, so we can do even more to improve life in societies around the world for decades to come. You might never see these secrets hidden around modern life, and you don't have to. We are proud that you experience their effects every day.
Kami percaya untuk membangun sesuatu yang luar biasa harus dimulai dari halaman rumah kita sendiri. Itulah yang kami lakukan di sini, di YKKAP. Di Indonesia, hanya YKKAP yang memiliki proses produksi terintegrasi, mencakup 8 fungsi utama. YKKAP melakukan riset mandiri di Indonesia yang berkolaborasi dengan lembaga pemerintah dan berbagai universitas terkemuka. Berdasarkan hasil riset R&D, kami mengembangkan produk secara mandiri. Hanya YKKAP di Indonesia yang dapat melakukan tes performa secara mandiri untuk memastikan kualitas terbaik di Indonesia. YKKAP mampu melebur ingot menjadi billet silinder secara mandiri. Proses ekstrusi di YKKAP dilakukan dengan standar teknologi Jepang. Proses anodizing di YKKAP adalah satu-satunya di Indonesia yang menggunakan teknologi electrodeposition 3 layer, memastikan produk tahan lebih lama. Kami menggunakan mesin khusus untuk proses produksi agar proses fabrikasi lebih akurat. Staf-staf terbaik YKKAP akan berbagi wawasan dan pengetahuan mereka. Hal ini dilakukan melalui site inspection, distributor training, dan metode pelatihan lainnya. Di Indonesia, hanya YKKAP yang memiliki 8 fungsi produksi terintegrasi untuk memastikan produk dengan kualitas tinggi. sebagai bentuk kontribusi YKKAP dalam membangun ruang hidup dan masyarakat yang lebih baik. YKKAP, we build a better society through architectural products.
Mari kita kenal lebih dekat dengan Balai Sains Bangunan. Balai Sains Bangunan berlokasi di Jalan Panyaungan, Cileunyi Wetan, Kabupaten Bandung. Balai Sains Bangunan merupakan balai teknis di bawah naungan Direktorat Bina Teknik Pemukiman dan Perumahan, Direktorat Jenderal Cipta Karya, Kementerian Pekerjaan Umum dan Perumahan Rakyat. Kami berkomitmen untuk selalu memberikan pelayanan terbaik sesuai dengan standar yang telah ditetapkan, yaitu pengujian, advis teknis, serta bimbingan teknis.
Pelayanan publik yang profesional dan berkualitas selalu menjadi prioritas kami. Kami berkomitmen penuh untuk membangun zona integritas menuju wilayah bebas dari korupsi dan wilayah birokrasi bersih melayani.
Sesuai dengan tagline Balai Sains Bangunan, yaitu profesional, berintegritas, dan melayani.
Pengujian di Puskim bagus, kita punya lab yang lumayan lengkap dengan sampel yang cukup besar. Ya, kita sangat puas dengan pengujian di sana.
Mudah-mudahan kedepannya Balai Sains Bangunan tetap memberikan pelayanan yang sangat prima.
Saya ingin mengucapkan terima kasih kepada Balai Sains Bangunan yang telah mengadakan layanan bimbingan teknis internal dengan sangat baik. Materinya sangat bermanfaat dan membuka pengetahuan baru untuk saya.
Pesan saya terhadap pelayanan di sini adalah mereka cepat tanggap, mau membantu kami dengan cepat orang luar yang akan melakukan penelitian di sini.
Balai Sains, prima!
Rupa rumah susun hemat energi dibangun dari hasil kerjasama penelitian antara Pusat Litbang Perumahan dan Permukiman Kementerian PUPR dengan Hiroshima University dan didukung oleh pemerintah Kota Tegal serta berbagai pihak baik dari Indonesia maupun dari Jepang. Rusun ini telah diresmikan oleh Wali Kota Tegal dan didampingi oleh Kementerian PUPR, Hiroshima University, dan LAPI ITB. Indonesia berkomitmen untuk memenuhi Paris Agreement 2030 terkait pengurangan karbon secara global melalui pengurangan konsumsi energi pada tahun 2030. Di sektor bangunan gedung, Kementerian PUPR terus melakukan inovasi untuk mengurangi konsumsi energi melalui pendekatan desain bangunan secara pasif tanpa mengorbankan kebutuhan kenyamanan penghuninya. Purwarupa Rusun Hemat Energi merupakan bangunan eksperimental yang dibangun sebagai sarana penelitian untuk mengkaji bagaimana bangunan memiliki kinerja termal yang baik melalui pendinginan pasif dan tanpa penggunaan energi berlebih untuk pendinginan udara. Teknik pendinginan pasif yang diterapkan meliputi ventilasi silang dengan memperbanyak bukaan pada dinding, penggunaan insulasi pada dinding bagian timur dan barat, penggunaan void dan ventilasi atap, dan penggunaan balkon dengan tipe penuh. Setelah melakukan analisis iklim setempat, diketahui bahwa kecepatan dan arah angin berbeda untuk kedua musim. Pada musim hujan, arah angin dapat menuju dua arah, yaitu utara atau selatan. Sedangkan pada musim kemarau, arah angin cenderung mengarah dari selatan ke utara. Dari analisis iklim tersebut, maka diperoleh orientasi bangunan rusun dan letak bukaan agar efek ventilasi optimum. Sistem ventilasi pada rusun ini sudah dirancang agar kenyamanan termal di dalam unit rusun dapat tercapai dengan menerapkan stack effect ventilation. Stack effect di ruang atap berfungsi untuk mendinginkan suhu udara agar dapat mengurangi atau mencegah peningkatan suhu ruang di bawahnya. Desain fasad bangunan dirancang untuk mengurangi panas di dalam unit rusun. Elemen-elemen tersebut meliputi peneduh eksternal, jendela dengan kisi-kisi untuk mengoptimumkan inlet udara, balkon sebagai zona thermal buffer yang dirancang untuk menghindari radiasi matahari langsung memasuki unit hunian dari segala arah. Prinsip radiant cooling pada rusun ini yaitu dengan menggunakan PCM untuk menyimpan panas ketika siang hari dan ketika malam hari panas dibuang melalui radiant cooling berupa PCM atau phase change material yang dipasang di lantai. Selain itu, material insulasi juga dipasang pada atap untuk mengurangi penyerapan panas. Rusun ini juga menerapkan teknologi removable walls dengan tujuan apabila ingin merubah posisi jendela, maka dapat dilakukan dengan membongkar pasang dinding seperti Lego.
Direktorat Bina Teknik Permukiman dan Perumahan melaksanakan penjaminan mutu. Salah satunya melalui audit persyaratan mutu dan pengukuran rumah susun hemat energi Kota Tegal agar sesuai dengan persyaratan mutu bangunan. Kami berharap proses pengukuran termal eksperimental di rusun ini dapat memberikan kepuasan penghuni dan mendukung bangunan yang hemat energi untuk tujuan pembangunan yang berkelanjutan.
Hasil eksperimen ini diharapkan dapat menjadi referensi dan standar untuk perancangan bangunan apartemen maupun rusunami di masa depan.
There's a secret to modern life. A few, actually. Secrets that have been working hard for you for decades. Look closely and you will find them everywhere. They're in your walls, in greenhouses, on the trains and inside your wheels. Then the ground, they're blocking sound, insulating, irrigating, purifying, fortifying, so you can focus and play and live and be happier. Getting on with what's most important to you without your surroundings getting in the way. And helping businesses thrive more efficiently while respecting the environment. For the last 80 years, we have been unlocking these secrets inside stone. And we found that by applying our curiosity, passion and knowledge, we could recreate stone's natural cycle and optimize the use of resources by converting waste into valuable material. Today, Stonewall improves people's work and well-being in all kinds of different ways. It plays a big part in making people's life richer, more productive and more beautiful wherever they might be. But we're sure there's more, and we are absolutely determined to find it, so we can do even more to improve life in societies around the world for decades to come. You might never see these secrets hidden around modern life, and you don't have to. We are proud that you experience their effects every day.
Kami percaya untuk membangun sesuatu yang luar biasa harus dimulai dari halaman rumah kita sendiri. Itulah yang kami lakukan di sini, di YKKAP. Di Indonesia, hanya YKKAP yang memiliki proses produksi terintegrasi, mencakup 8 fungsi utama. YKKAP melakukan riset mandiri di Indonesia yang berkolaborasi dengan lembaga pemerintah dan berbagai universitas terkemuka. Berdasarkan hasil riset R&D, kami mengembangkan produk secara mandiri. Hanya YKKAP di Indonesia yang dapat melakukan tes performa secara mandiri untuk memastikan kualitas terbaik di Indonesia. YKKAP mampu melebur ingot menjadi billet silinder secara mandiri. Proses ekstrusi di YKKAP dilakukan dengan standar teknologi Jepang. Proses anodizing di YKKAP adalah satu-satunya di Indonesia yang menggunakan teknologi electrodeposition 3 layer, memastikan produk tahan lebih lama. Kami menggunakan mesin khusus untuk proses produksi agar proses fabrikasi lebih akurat. Staf-staf terbaik YKKAP akan berbagi wawasan dan pengetahuan mereka. Hal ini dilakukan melalui site inspection, distributor training, dan metode pelatihan lainnya. Di Indonesia, hanya YKKAP yang memiliki 8 fungsi produksi terintegrasi untuk memastikan produk dengan kualitas tinggi. Sebagai bentuk kontribusi YKKAP dalam membangun ruang hidup dan masyarakat yang lebih baik. YKKAP, we build a better society through architectural products.
Mari kita kenal lebih dekat dengan Balai Sains Bangunan. Balai Sains Bangunan berlokasi di Jalan Panyaungan, Cileunyi Wetan, Kabupaten Bandung. Balai Sains Bangunan merupakan balai teknis di bawah naungan Direktorat Bina Teknik Pemukiman dan Perumahan, Direktorat Jenderal Cipta Karya, Kementerian Pekerjaan Umum dan Perumahan Rakyat. Kami berkomitmen untuk selalu memberikan pelayanan terbaik sesuai dengan standar yang telah ditetapkan, yaitu pengujian, advis teknis, serta bimbingan teknis.
Pelayanan publik yang profesional dan berkualitas selalu menjadi prioritas kami. Kami berkomitmen penuh untuk membangun zona integritas menuju wilayah bebas dari korupsi dan wilayah birokrasi bersih melayani.
Sesuai dengan tagline Balai Sains Bangunan, yaitu profesional, berintegritas, dan melayani.
Pengujian di Puskim bagus, kita punya lab yang lumayan lengkap dengan sampel yang cukup besar. Ya, kita sangat puas dengan pengujian di sana.
Mudah-mudahan kedepannya Balai Sains Bangunan tetap memberikan pelayanan yang sangat prima.
Saya ingin mengucapkan terima kasih kepada Balai Sains Bangunan yang telah mengadakan layanan bimbingan teknis internal dengan sangat baik, materinya sangat bermanfaat dan membuka pengetahuan baru untuk saya.
Pesan saya terhadap pelayanan di sini adalah mereka cepat tanggap, mau membantu kami dengan cepat orang luar yang akan melakukan penelitian di sini.
Balai Sains, prima.
Rupa rumah susun hemat energi dibangun dari hasil kerjasama penelitian antara Pusat Litbang Perumahan dan Permukiman Kementerian PUPR dengan Hiroshima University dan didukung oleh pemerintah Kota Tegal serta berbagai pihak baik dari Indonesia maupun dari Jepang. Rusun ini telah diresmikan oleh Wali Kota Tegal dan didampingi oleh Kementerian PUPR, Hiroshima University, dan LAPI ITB. Indonesia berkomitmen untuk memenuhi Paris Agreement 2030 terkait pengurangan karbon secara global melalui pengurangan konsumsi energi pada tahun 2030. Di sektor bangunan gedung, Kementerian PUPR terus melakukan inovasi untuk mengurangi konsumsi energi melalui pendekatan desain bangunan secara pasif tanpa mengorbankan kebutuhan kenyamanan penghuninya. Rupa Rusun Hemat Energi merupakan bangunan eksperimental yang dibangun sebagai sarana penelitian untuk mengkaji bagaimana bangunan memiliki kinerja termal yang baik melalui pendinginan pasif dan tanpa penggunaan energi berlebih untuk pendinginan udara. Teknik pendinginan pasif yang diterapkan meliputi ventilasi silang dengan memperbanyak bukaan pada dinding, penggunaan insulasi pada dinding bagian timur dan barat, penggunaan void dan ventilasi atap, dan penggunaan balkon dengan tipe penuh. Setelah melakukan analisis iklim setempat, diketahui bahwa kecepatan dan arah angin berbeda untuk kedua musim. Pada musim hujan, arah angin dapat menuju dua arah, yaitu utara atau selatan. Sedangkan pada musim kemarau, arah angin cenderung mengarah dari selatan ke utara. Dari analisis iklim tersebut, maka diperoleh orientasi bangunan rusun dan letak bukaan agar efek ventilasi optimum. Sistem ventilasi pada rusun ini sudah dirancang agar kenyamanan termal di dalam unit rusun dapat tercapai dengan menerapkan stack effect ventilation. Stack effect di ruang atap berfungsi untuk mendinginkan suhu udara agar dapat mengurangi atau mencegah peningkatan suhu ruang di bawahnya. Desain fasad bangunan dirancang untuk mengurangi panas di dalam unit rusun. Elemen-elemen tersebut meliputi peneduh eksternal, jendela dengan kisi-kisi untuk mengoptimumkan inlet udara, balkon sebagai zona thermal buffer yang dirancang untuk menghindari radiasi matahari langsung memasuki unit hunian dari segala arah. Prinsip radiant cooling pada rusun ini yaitu dengan menggunakan PCM untuk menyimpan panas ketika siang hari, dan ketika malam hari panas dibuang melalui radiant cooling berupa PCM atau phase change material yang dipasang di lantai. Selain itu, material insulasi juga dipasang pada atap untuk mengurangi penyerapan panas. Rusun ini juga menerapkan teknologi removable walls dengan tujuan apabila ingin merubah posisi jendela, maka dapat dilakukan dengan membongkar pasang dinding seperti Lego.
Direktorat Bina Teknik Permukiman dan Perumahan melaksanakan penjaminan mutu. Salah satunya melalui audit persyaratan mutu dan pengukuran rumah susun hemat energi Kota Tegal agar sesuai dengan persyaratan mutu bangunan. Kami berharap proses pengukuran termal eksperimental di rusun ini dapat memberikan kepuasan penghuni dan mendukung bangunan yang hemat energi untuk tujuan pembangunan yang berkelanjutan.
Hasil eksperimen ini diharapkan dapat menjadi referensi dan standar untuk perancangan bangunan apartemen maupun rusunami di masa depan.
Dear honorable participants, please make your way to the conference room as we are about to start the next session. Thank you very much. Dear respected participants, and we are now ready to the next session. In this session, we have 2 product presentation from our sponsors. Before entering session 3, for the first opportunity, I'd like to invite Mr. Leonardus from Rockwool Company to present insulation technology for building application. Mr. Leonardus, you have 20 minutes to present, and time is yours.
Good afternoon, everyone. Thank you very much for organizer for giving me time to give presentation from Rockwool. This particular topic is about external wall insulation, because now we are approaching to PUPR, yeah, particularly for the new housing models in the second housing model. Hopefully, we can engage deep and deeper in the future, yeah. Okay, my name is Leonardos. I'm from Rockwool Asia, Jakarta representative. I'm head for the general building. So today's topic is for building only. So we don't talk about other product or other types. Okay, let me start the presentation. I know this is the hard time because, as usual, after lunch, yeah, your stomach's digesting the food, so need more energy for listening the material. Welcome to Rockwool. First of all, I have to say that Rockwool actually is a brand, not a product. Yeah, because yeah, there are many misunderstandings about Rockwool, not only in the new customer, but also in the architect, consultant, contractor, and many stakeholders. So I will inform you that basically Rockwool is a brand, and our product is stone wool. Yeah, stone wool is a generic product. Rockwool is a brand. In Indonesia, there are many brands, actually, around 4 up to 5 brands, and basically all of them are stone wool. Yeah. So for the architects who specified in the project, please note Rockwool is a brand, not a product actually. Okay. From Rockwool said, we have 5 brands actually. We have 5 brands. First brand is Rockwool itself. Our core basis is insulation. Yeah, insulation, building, insulation for industry. Yeah, the brand is Rockwool. The second brand is Rockfon. This brand focus on the ceiling and acoustic panel. Yeah, and then the third one is Grodan. Grodan is a product for horticultural products. So if you ask me, is it possible Rockwool to install or to apply it as a horticultural? I can say cannot, because Rockwool itself is water repellency. We have a very high water repellency, so not absorb waters. Yeah. The fourth one is Lapinus. Lapinus is very common for the vibration and noise in the automotive industry, including the trains. And the last one is Rock Panel. Rock Panel is a facade products for the aesthetic and performance products. But we sell in Indonesia only Rockwool. The rest still in Europe, but if you need, we can import directly from Europe. Yeah. Currently we have experience more than 80 years, and our business still in the insulation, so we don't have another business. Again, only insulation that was made from stone. That's why we call it stone wool. Yeah, we are world leader in the insulation business, founded in 1937 in Denmark. So our headquarters in Denmark, and currently we have facilities more than 51 factories. The latest one in Japan, we acquired a Japanese company, Banshio Holding in Tomioka, which is we acquired in 2020, 3 years ago. So this factory is the latest one from Rockwool Group. Yeah. Then became Rockwool Japan at the moment, Rockwool Japan. Okay. We are presenting in more than 120 countries, including Indonesia, and yeah, spread in the 5 continents across the world. Okay, basically from the Rockwool Group, not only Rockwool, yeah, from the Rockwool Group, we have the 7 strengths of the stone. But talking about Rockwool, we are focusing on the third one, the biggest third one. The fire resilience, the thermal performance, also the acoustic performance. This is the 3 main things in the building. Yeah, but the rest, let's say robustness, then aesthetic, we can get this category from other product, kind of rock phone, rock panel, etc. Yeah, but Rockwool itself, we just like promoting a lot for 3 main performance: fire, thermal, and acoustic or sounds. Okay, this topic is about EWI, external wall insulation. Basically, we have new products in Indonesia. We call as a facade rock. Yeah, this is a product we launched because we want to help how to reach net zero emission in the future, or how to achieve EE in the future. There are many seminars that I follow, mostly talking about EE. Yeah, that's why we involving the seminar also, because we want to influence, also we want to bring how EE we can achieve in the future. Yeah, basically very fundamental that sequences the right thing to achieve net zero carbon. And this is quite long steps, but the most basic is about fundamental basic is about how design the building itself. Yeah, because in the future or after the building was built, there are many things aspect to reduce the net zero, to reduce the energy. For example, how you switch on the aircon, for example. Yeah, this is very influenced for the energy consumption as well. But again, from the beginning or the fundamental is about the design of the building. That's why Rockwool very eager and very happy if every building involving insulation to achieve the zero carbon. Yeah. So you can see in the presentation slides there are many steps, but I just want to talk about the first step, which is the very fundamental is passive insulation or passive design first. Yeah. Okay, and there are many things, there are many ways to achieve the net zero, from orientation of building, how the building orientation is very impactful to the consumption of energy. For example, in Tegal, yeah, the housing model is not heading in the straight to east, but also east to south. Same, in this orientation, the building has a very big influence to the energy consumption. The second thing is about the facade design. This is our business. Yeah, like I said before, we have product facade rock, which is the application is for facade building. This is quite simple application, but very impactful to reduce the energy consumption. The other thing is about daily lighting application, then natural ventilation, also thermal insulation, also strategic landscaping. This is some points that can helping how to reduce the energy consumption. What is EWI? Basically, exterior insulation designed to improve the energy efficiency for the new building or the existing building. Yeah, for the new building it's quite simple, because when you build a new building, we can insulate together with development of the building. But the ones for the existing building, we call as a retrofit building. There are many samples in Europe, also in Asia, particularly in China. We retrofit the old building to get the good EE in the future. Yeah. The nearest one is Malaysia. We have project Wilhelm in Malaysia, which is we built the new one, but retrofit the building, we have a lot, so I will give you example later. Then EWI is external wall insulation. That system can be two type of insulation, sorry. There are ATICs, or external thermal insulation composite system, which is facade rock, and the rest one is ventilated facade. I think it's very common in Indonesia using ventilated facade because this is not quite advanced, yeah. But for facade rock, yes, only Rockwool have the product for facade. I can say in the rest competitors they don't have. That's why once we launch the product in Indonesia, to be honest, we don't have any competitors. Yeah. Also, EWI is a continuous external insulation improve thermal performance. Yes, we are focusing on the thermal first because again, we want to reduce the energy consumption, so we don't talk about like sound or fire. But again, we are focusing on the thermal. Also, the one that influenced to the EE is about the type of material. Yeah, there are many variety of products that can be applied, but the most flexible product is stone wool. So that's why this product is very popular and yeah, very common to choose, particularly for architect, to design as flexible as they want. Why do we need EWI? Yes, because external wall insulation works to insulate either vertical or horizontal building. Yeah, we achieve also installation in the entire building or partial building. Okay. This insulation prevents the temperature load for sure because commonly our R value is about 0.03534. So this is very effective in blocking the heat from outside. So only 5 minutes left. And then the key benefit of EWI, you can see that preventing heat loss, reducing thermal bridging, yeah, improving energy efficiency, low cost solution in upgrading existing properties. That's why I heard that building from PUBR will be retrofit, so we are very happy to involve in the retrofitting to get the EE, yeah. Also, yeah, retrofit existing is very simple because we don't have to like moving or like doing many things from the building. So just insulated from outside is very simple. Also fast and very low cost effective. For new building is quite simple because one architect design, we can involve in the installation of the insulation. Ethic application is very simple. This is facade that we offer to PUBR. Yeah, there are wall as a base, and then we apply with facade rock, which is rock wool, and then cover with plaster. As simple as that. But there are many systems. That we should install. For example, like fiber mesh and then anchor. But generally, only three things, which is wall, brick wall, then we cover with stone wool, and then cover with plaster. That's it. It's very simple. This will reduce the heat from outside, and will get the cooler aircon in the inside. This application is external, yeah, not internal, but external. That's why we call as EWI. this is ventilated facade. It's very common in Indonesia. The nearest one, if you come from Bandung, yeah, the IKEA Bandung using this method, which is the wall, then cover with insulation, and then cover the outer cover is metal deck. Yeah, this is very common, but I think from the aesthetic is different perspective. Yeah, I think it's not quite high. The facade rock product is very unique because we have dual density in one product. Commonly, only one density, 40 or 60 or 100 or 150, but for application, this external wall, we have dual density in one product. The outer one is about 140 up to 160 kilogram per meter cubic, and then for inside insulation is very low, around 40. That's why it's very smooth inside because they will cover, we want to achieve the flatness outside. That's why the inside density is very low. Yeah. You may see that there are many performance we achieve from fire resilience, from thermal property, yes, of course. Then robustness is very durable. Then acoustic, yes, as I mentioned before, we have NRC 1 for the all product of stone wool, rock wool particularly. And then aesthetic, yes, it's very simple. Once you cover with plaster, you can put any colors. And then water properties. Like I said before, we have very high water repellency, so this is not easy to absorb water. Okay, this is dual density products that we launched in Indonesia. There are only 3 factories producing these products. Yeah, so there is very limited competition. And then this is the example that I mentioned before. This is in Canada. This building was built around 100. Sorry. Okay. Sorry, forgot it. Yeah, this is the facade rock installation. Sorry, this is on progress. You may see that our rock is mostly like yellowish, about brownish. This is before finishing. So Ken Sobel is a building that was built in 1967 and then retrofit in 2021 using facade rock. And then this one is still in progress before the finishing coat. Also, the last one is William Court House. This is early 1960 building, and then covered in 2019. Yeah. So this product we want to bring to Indonesia, and the first project, to be honest, I want to install in the PUPR project in Tegal. So that's all from my side. Thank you very much, organizer. Thank you very much, audience.
Thank you very much, Mr. Leonardus, for inspiring us with your nice presentation. Next presentation, I'd like to invite Mr. Alfredo Cipto Setiawan from YKKAP to move forward on the stage for presenting the window technology. Yeah, Mr. Alfredo, your time is 20 minutes to present. Time is yours.
Good afternoon, everyone. Thank you for your presence. Okay, so from now on, I will try to inform to you regarding our new product. That this is for the prefabrication and affordable products for better living. Yeah, this is our company profile. Actually, we are still on the same with YKK Group. The first one that with the fastening products. And then we are on the YKKAP. We call it architectural product. And also both of those line business also support by the machinery and engineering by the YKK Group. And this is the reflections of our market in the domestic and also the overseas. And this is for the product for the overseas. And especially for Indonesia, we just focus on the 2 climate which is on the summer and also on the rain season. So we develop in a two finished good product. We call it in a Nexta and Madela. This is the history of the YKK AP in Indonesia, and also we still supply in the country in the 4 country in the Asian. This is on the Thailand, Vietnam, Malaysia, and Singapore. And then we established on the 1986. Our name still in PT YKK Alumico. And then also we try to develop in the first testing center in Indonesia. So that's why we still can develop for our finished good product that already tested before. And then in 2004, we changed our company name from PT YKK Alumico into PT YKK AP Indonesia. And then in 2014, we're launching the product, we call it Nexta, that's still existing until now. Also in 2018, we established for the R&D center in Indonesia. This is the third one after in Japan and after in Germany. Also in 2021, we launched the new product, we call it Madela. Later on I will show you the detail. And then also we launched for the Nexta. This is actually for the completion product of the Nexta. We launched for the wide view, for the sliding door, and then also for the window we launched for the high ventilation in the COVID-19 era. And then in 2023, we relocate our sales and marketing office to the new location. So we built with our new showroom with the concept experience studio. We call it Yes. And this is for our product. Actually on the blue zone area, this is the performance product that developed including the parts and hardware from YKK AP. For the curtain wall product, we call it UCW and also KCW 75. But for the window wall product, we developed Nexta. And then also now we have the affordable for the middle segment, for the middle line market, we call it Madela. Also Madela we separately with the Madela H for the high-rise building, and then for the Madela L is for the low-rise building. And then for this green area, we call it the bar plus parts, and also for the shop front bar. This is actually the guarantee and then the standard of the operation. It's by our distributor or by the applicator themselves. I try to inform the detail more about Madela. Actually, Madela name comes combination from the Mado, in Japanese means jendela in bahasa, and then dela jendela. So we combine it, become Madela, its name. And then the first one, as this is a finished good product, we should concern that still using a parts and hardware from YKK AP original. And also our concern, we try to reach the middle line, the middle market. The price should be affordable, but still have a performance inside. And then with the simple design also, it means that our frame, the inner frame of the door and window is more slim rather than our series Nexta. And then for the efficiency of the order, as our concept simple and easy, actually we already put and give the application order to our distributor. So it can decrease the human error. For the example, if our distributor input the size of the door and window that not proportional one or oversized, they cannot input the amount. And then also we deliver in an efficiency way. We use inside the box that it's already cutting process, already including the accessories, and that can directly come to the side project. And then also we can show for this one actually the waterproof joint. Why we can guarantee about the waterproof joint? Because for the example that the joint between the horizontal and vertical frame, like for example for the inner or outer frame, we still use the SAP material. This is, we call it a sealer pad, so they don't metal touch directly. And also when we deliver to the customer, we give this customer service sticker. So hopefully psychologically they can more secure with this waterproof information. And this is because this is finished good product, so we should establish with our performance. For the structural first wind load, we have up to 1,200 for the Madela H, and then for the Madela L low rise, it's up to 600 Pascal. And then also we already tested for the opening force and then open close test until the 20,000 times. And then also we already can increase for the sound insulation. And the glass in this product can up to 8 millimeters thickness. And then this is our color category. We divide between the powder coating, the horizontal spray process, and then the anodized plus, the vertical dipping process. This is actually the product information series for the Madela. We have a sliding, we have a top hung, casement, and fixed. Also the size that mentioned in here, between the 600 Pascal and 1,200, this is the maximum size. So if we want to order below this size, it's still possible. And also we launched our new line-up product, which is we can release for the Madela swing door. Also we can sell only for the outer frame also. The size limitation also we already mentioned is up to, for the head, 3 meters. And also we try to communicate to our customer is more transparent. So we put on our brochure, our catalog, this is for the price list of the aluminum, including parts and hardware, but still exclude for the assembly, glass, and installation price. So we are ready also for the shop drawing for our module. And then hopefully from this kind of information, it can more easier and can be more faster to deliver to our customer for the information. And this is the image for our Madela delivery flow. We try to campaign for the prefab product, including accessories that comes inside the box, and then we can efficiency for the space of the delivery. And then also at the site, for example, this is for the less manpower and tools also when we try to assemble this prefab product. And then also for the glass cutting size, they can directly come to the site project, and then this is our distributor or applicator that already training by YKKAP can install it. So as our concept, simple and easy, we try to make efficiency start from production until delivery matters to site. Try to show you the video, comparison video. Simple way that we can install only with 2 manpower for the outer frame until the inner frame, and such less tools. This is the comparison. If we compare with the general bar window, they still have some risk also of the standard of the quality. So it's less than 30 minutes if we compare. Okay, so actually this is, I try to information regarding the current status of the middle market. This is actually some of the developers and the project owners calls us to come to the site. And then we try to manage into 3 main problems in here. The first one is regarding the processing problems. Some of the joint, they still have a gap. So maybe some of the air infiltration also can come inside. Like also for the performance problem, for the sealant matters, and then also for the parts problem also, because they don't test before when they release to the site project. And then also the most important is the content of the aluminum that we are up to 97%. So this is become the aluminum structure more rigid, not only thick but more rigid. And this is slightly forward. I want to inform about the Nexta. This is, we try to completion the two type, which is the wide view for the sliding door, and then the second one is for window is the high ventilation. They're still using a top hung module. Actually, this is the benefit of the cross ventilation that we can increase if we put the high ventilation window that on the high ceiling. So the air change rate more increase, it's up to 345% rather than only a single window on the low area. And this is, I show you the video for the Nexta, including the wide view sliding door. The height is up to 4 meters. And then it will come with a round shape for the interlocking steel, and we use multi-point lock. This is for the ventilation window on the high ceiling area. Can be easily operated using a sling. Yeah, actually this is our certificate. We already updated for some of like ISO, and also we are a member of Green Building, and also for the TKDN certificate, we are up to 66.35% for this TKDN certificate. So we are ready to support for this project, and this is the award for the YKKAP. The last one we award for the digital popular brand in the 2023, early of this year. And then we try to communicate to customer using the online also. We have an Instagram account, and then also you can see our update, our lineup, series update, our activity, and then can go directly to the website. Also you can download directly for our brochure. You can see clearly who's our distributor. And this is our project reference for the landed project, and this is for the high-rise project. And this is the image for the experience studio. Actually we put the touch panel standing, and then for this digital board we can sketch. So for the architect and developer, it's very welcome. We can discuss in our showroom. And this is the mobile showroom. Actually in the outside of this area also we bring to have experience, and the location in this at the right side of this building actually. Okay, so that's all from us. Thank you.
Thank you very much, Mr. Alfred, for such a nice presentation of YKKAP. After hearing interesting presentation of the building technologies from Rockwool and YKKAP, let's move to the third session. Third session covers issue on the life cycle energy and life cycles CO2 in the building sector. Prof. Hiroto Takaguchi will chair this session. Prof. Takaguchi is a professor from Waseda University, Tokyo. He obtained his doctoral degree from the same university. His research interests include energy saving policy, urban resilience, energy saving technology and equipment on residential building, sustainable process management, and renewable energy and materials on building. Prof. Takaguchi, this session has 55 minutes, including 10 minutes of Q&A. Thank you, Prof. Takaguchi, for sharing this session, and please, time is yours.
Thank you very much, MC, and ladies and gentlemen, selamat siang Thank you. So this is kind of the last sessions for the presentation of the researchers. I hope you have a little more patience to hear the research presentations. The topic of this session is, she has already mentioned, how to make a low carbon housing from the viewpoint of LCA and specific strategies. Of course, LCA is a life cycle assessment, include embodied energy through operational energies. The starting point of LCA is knowing and understand the current conditions, material used, energy consumption, and lifestyle of the resident. Today's presenters have done this hard work during the COVID-19 pandemic. Please welcome the speakers. So the first speaker is Mr. Rudy Stiagi Augustin Gutiérrez from PUPEA of Waseda Universities. Come to the stage. And the second presenter is Miss Sri Nobianti Prautiu. We usually call it Opi-san. And third presenter is Dr. Andan Torihamdani from YKKAP. Okay, let's start the presentations. So first is, now time is yours. どうぞ.
Thank you very much, Professor Hiroto Takaguchi. Good afternoon, everyone. My name is Rudy Setiaji. I'm working for the Ministry of Public Works, and now I'm studying at Waseda University. We'll share about our research result around embodied energy and carbon assessment of Rusunawa in Indonesia. I will share some point here, around 4 points, and I will start for the first one. It is about the embodied energy and carbon of existing Rusunawa buildings. So there are existing Rusunawa that already built right now, and this is some introduction that about Indonesia already committed to reduce the gas CO2 emission around 29%, and they already state in our national determined condition. And then in the world, the progress is quite massive here. We can see from the data that green building certification increased around 13%, and more country more adapted about the more green building energy code. And then for the building sector, this is already mentioned in the first day actually, and many sector contribute to the CO2 emission, including the building sector. And there are some reduction strategy that can be made to reduce that. For my related with my our study, it is addressing the embedded carbon stored in the building material. And so, if we're talking about building material, we should also talking about the building life cycle of stage. And we can see here from the product stage, construction process stage, use stage, and end of life, and after that. So the material has influence in all of these stages in the product stage until etc. The embodied energy that is contained in the material has a main role. And then in the use stage, the operational energy that being consumed by the building has a main role. So if we compare between the embodied energy from this paper and this is the operational energy, if the operational energy become reduced, so the embodied energy is more significant to be considered. And so based on this about this embodied energy, we can also see how important building material in all the green building certification. We can see about material has a quite significant portion in the assessment. And so, based on those consideration, we try to look about the existing Rusunawa in Indonesia. We gather all the document from the Rusunawa in Indonesia based on the ministry who is built, and then the local government, and also from the state company. And we conducted the life cycle analysis with the cradle to end of use boundary. So from the building, from the product stage until the building is already end of their service lifetime. And our finding based on the building-based analysis, so we studied based on the clusterization. I'm sorry, the letter is not so clear enough. Based on the work from the previous presenter, Mr. Andika, and we found that this 1BR2 model cluster has lowest embodied energy and carbon, and then this BR1, 2BR1, that is 2 bedroom, and 1BR is 1 bedroom, has the lowest value of the embodied energy and carbon. And when we talk about in the about height, for the middle, low, and high rise has the lowest actually embodied carbon. We make the value based on the floor area. So based on the floor area, it is quite efficient. But actually, if we gather in the value of one building, it is huge than the low one. And so we also try to look about the construction work based on the type of the building. So this one is about the upper structure. Upper structure has the biggest portion here, and the other is lower than that, followed by the building envelope, about the non-structural wall. And for the other consideration, we're talking about the system of the structure. If the building use the precast concrete, of course, they will have a lower embodied energy and carbon. And if we compare between single corridor and double corridor, single corridor actually has a lower embodied energy and carbon. So in further analysis, we are talking about the building materials. So we divided, this is based on the non-structural wall. So many existing Rusunawa have different system, and they have different configuration between the external wall and also the internal wall. Based on this, our research, the LCW, PG, and PG, this is the lightweight expanded polystyrene mortar sandwich panel. That is for the external, and using the partition of gypsum panel has the lowest embodied energy and carbon. And then for the roof, we are also classified, and we got result that if the roof using the steel frame and then the UPVC seat cover, it is has a low embodied energy and carbon also. And for all of the working construction work, of course, same with the other result, the researcher result, that product component has the main portion in this embodied energy and carbon. And I remind, previously I talked that about Rusunawa cluster, and why those two clusters become the lowest one. If we analyze with this chart, we can see that the cost for the 1BR2 cluster, it is because the upper structure reduction. The embodied energy and carbon of those components become lower than the other cluster. But the other cluster, this is the 2BR1, the building envelope have more influence than the upper structure to reduce the embodied energy and carbon. And this is the building material base. We can see that this is the wood, and then steel and cement. And so if we look at from energy to carbon, the carbon of the steel has a big portion, and also the cement. And so we are studying the material that influence that has major contribution to embodied energy and carbon, that is the cement and ready-mix concrete. So we survey several companies in Indonesia that produce cement and ready-mix concrete in Indonesia. So based on the net zero part of, this is from the concrete, some kind concrete group producer in the world. There are several ways to reduce the concrete, and one of that we will try is the use of to reduce the use of the cement. And so we know that in Indonesia we have a lot of cement manufacturer spread on around Indonesia here, and then we also know from the website also I discovered this capacity of those cement is quite big, and also they have capability to export the product to outside Indonesia. And but the use in Indonesia, the use of OPC, ordinary Portland cement, it's quite still high. Compare with the other more environment friendly, if the company, if cement industry say. So our ministry also give some push encouragement. So we regulate the minister instruction. So every construction should use this non-ordinary OPC, because we already know that the OPC has a very high contribution. So we sample from the cement manufacturer. This is the material of the total cement. And then also from the ready-mix concrete, based on the strength class, we also gather the mix design. This is the sample, but this is a sample only for one strength compressive class. And for the result, we get that the embodied carbon of our industry of OPC and non-OPC is still comparable with the other country based on this literature. And the one that we should be note that our cement industry use lower SCM compared with the other countries. So
4 minutes left.
We have the same, but we have the same embodied carbon, but we have lower SCM, supplementary cementitious material. So there is a possibility that if we can add it, we can reduce more. And for the ready-mix concrete, we also developed the reference. This is the existing one. We can predict the OPC using the OPC mix design. But if we use the developed reference for assessment of the ready-mix concrete, we can get the more rational result compared the other product that already available in Indonesia. So this product of ready-mix cement has very significant reduction compared to OPC concrete. It is around 58% can reduce the OPC concrete. One of the product from the company. Now, based on the on those previous results, we now have a current research activity to develop the to optimize the Rusunawa-based model to BR optimization. So this one is research from Mr. Andika. So from that base model to BR, we will make some modification on the building envelope and also building structure. Based on the previous research, we know that the influence of the building structure and building envelope to the embodied energy of carbon. So for the building envelope, we will combine about the use the material for wall, insulation, and window glass, and based on the climate zone, and also for the building structure, based on the material for structure and seismic design category, to make some model and analyze the building embodied and operational energy and carbon analysis. Since the material also has influence to operational energy and will have possibility to reduce the embodied energy, or maybe we can have another finding. And now we also doing collecting the building material inventory, local material in Indonesia that can be built or already being used by the existing Rusunawa. And this is the Rusunawa base model to BR. So from the building material inventory, we will get the coefficient of embedded energy and carbon, so we can make some simulation. This is about the building energy model simulation. We can combine the material and get the thermal properties of the performance of the building, and we can combine it again with the building structure to get more lower carbon of the Rusunawa. And for the closing remark, from the previous, we already identified, and some of the value of the embodied energy and carbon can be used as a baseline to baseline of the embodied energy and carbon of Rusunawa for the design of the future Rusunawa. And based on the cement ready mix, we already got the picture, the big picture, how much is the real embodied energy and carbon from the ready mix concrete, and we already can use the reference concrete mix design to assess the available ready mix that already exists in Indonesia. I think that's all that I can share with you today. I hope we can discuss later. Thank you very much.
Thank you very much, Ruri-san. So it's just a few 14 minutes old. So next presenter is Siri Aopi-san. Yeah. So time is yours. Oh. No.
Okay, good afternoon, everyone. So first of all, I would like to introduce myself. My name is Srinovi Yanti Pratiwi. Currently, I'm enrolling doctoral programs in Hiroshima University. So for today, I would like to present our research regarding to operational energy in vertical housing. So our title is Influence of Preferences of Lifestyle and Living Environments on Total Household Energy Consumption in Indonesia. This research also collaborate with Waseda University and supervised by Professor Tetsuku Bota and also Professor Hiroto Takaguchi. So the content of today's presentation, I would like to start with introduction. So as we may know that the increasing of consumption in energy in household sector is keep increasing. And then in the near future, we have to find a strategy how, of course, to manage how the energy consumption in household sectors. And then we found also that the condition of Indonesia experience now the accelerating economic growth. And then we found that we need to find a good strategy to in the future how we can design a low carbon housing. And then for this research, we want to explore about the factors that might affect household energy consumption, but not related to social or economic factors. But we want to try collected information regarding the personal values of people who live in Indonesia. And then for this research, there are three main objectives. First, we want to obtain the current household energy consumption in urban housings, especially in the vertical housing type. There are Rusunawa, which is Rusunawa, Rumah Susun Sederhana Sewa, and then the second is Rusunami, is a Rumah Susun Sederhana Milik, and also condominium or private apartments. And then the second objective, we want to discover the personal that related to psychology and physiology factors that may significantly affect energy consumption. And then the third objective, we want to clarify the preferences and evaluation structures of Indonesian people towards their living environments among different energy consumption level household. And then this is our methodology. There are two parts of how we can conduct the research. First, in the part one, we were focused on how we can collect the important factors that how physiology and
psychological factors of Indonesian people regarding to in the 4 scales assessment related to behavior, interior, building, and also neighborhood. And then we also try to survey the household energy consumption conducted by online survey. And then after that, the result from the pilot survey we use for the main survey that we conducted focus on the vertical housing type. And this research, I would like to more explain about the result from the main survey. So in this main survey, we conducted a face-to-face interview, and then we collected around more than 3,000 of respondents, and then we apply the result from the part 1 that we already collected some factors, and then we conducted made a questionnaire and then we test in the part 2, and then after that we process the data analysis with a quantitative analysis. First, we conducted the simple linear regression analysis, and then principal component analysis, cluster analysis, and then we also create the scatter plot to see how the preferences of household in different of household energy consumption regarding to preferences of living environments and also lifestyle. And then this is slightly briefly I want to explain about how we conducted the part 1, how we can get the factors that might important for Indonesian people regarding to living environments and lifestyle. We conducted a survey using evaluation grid method. This is the methodology that mostly used for in the environmental psychology. What we conducted, we showed them some pictures, and then the respondents should divide the pictures based on their preferences, and then after that we can get some key information, or we collected the keywords or key phrases that the reason why they prefer some certain of interior behavior and building and also neighborhood. And then this is the extracted result from the evaluation grid method. We can get the around 19 of the important factors related to psychology and also physiological factors related how they spend time in how they spend time with in socialize, and then how they concern about environments, how they prefer room color, the air condition in the room, and etc. And then this is the result. This is the respondent profile that we gather for this research. We get the around 46%. So we collected data from Rusunawa and also 41% from Rusunaumi, and then the rest is condominium. And then we found that we also gathered the data in the 5 major cities. There are Jakarta, Bandung, Surabaya, Medan, and also Makassar. And then for the type of ownership, we found that most of the respondents were rented in the Rusunawa, Rusunami, and condominium. And then I move to the main findings of our research regarding to the about the answer for regarding preferences for the 19 factors regarding to the related to the psychological factors and also physiological factors. We can see from here there's some spike here regarding how they prefer a room with cool air instead of prefer room with warm air. And also we found that Indonesian people who live in the vertical housing, they prefer to have like a bright color room and then prefer to have calm life, and then how they prefer to socialize with family. And then also for the result of total energy consumption, this is I shows the average of total energy consumption in Rusunawa, Rusunami, and also condominium, we found that the annual total energy consumption range respondent are in more than 36%, around 36% was in the range of 5 to 9 gigajoule per year. And then after that, we process the result from the SD questions related to factors, psychologically and physiological factors. We want to know how variables correlated with household energy consumption, and then we used a simple linear regression. And then this, from the 19, we found only 13 factors that related to psychology and physiological factor that linear with the household energy consumption. And then after that, we process the 13th of the important factors regarding to physiological and psychological factors. We try to, how can I say, made to simplify the variables, because we want to make a very simple axis to make to see how Indonesian who lives in apartments when they choose the several factors of their preferences in living environments and also physiological. As we can see from here, we conducted the principal component analysis, and then we get there are 4 components here. From 13, we can simplify to 4 component variables. In the principal component 1, or there are we took the values that above 0.4, and then in the principal component 1, there are variables: spend time with someone, socialize with family, and then also related to how they socialize, and also spending and concern in environments. And the principal component 2 related to the size of the building, how they also intolerance of hot temperature, and then in the principal component 3 related to how they prefer more in the traditional settings of design, and then they spend time without AC, and then principal component 4 spend time alone, and also gated house. And this is how we simplify. From 13 factors, we can simplify into 4. This is first variables is coexistence with nature and religions, intolerance with hot environments, traditional with natural ventilation, and then introvert and secure.
Oki-san, 4 minutes left.
Okay, thank you, Sensei. And then after that, we also try to see the preferences according to the level of energy consumption. So we conducted the cluster energy analysis to divide the level energy consumption of the respondent. So we conducted the hierarchical cluster analysis, and then these are the results. We divided into 4 clusters. One is the very lowest household energy consumption group. Cluster 2 is lower medium household energy consumption group. Cluster 3 is upper medium household energy consumption. And then 4th is the highest household energy consumption group. And this is the attributes for each cluster. We can see the according also to income. The lowest energy consumption has the lowest income. Then the highest energy consumption also have the highest income. And then after that, we conducted the scatter plot to see how every clusters of energy, the tendency of the answer regarding to the preferences of living environments and lifestyle, and also physiological. We can see from here in the cluster 1, in the red colors, how we can see the from the scatter plot in axis for PC1 and PC2, and then the other also same to show the how it's spread according to the different level energy consumption. And then in the cluster 1, we found the lower scores in the PC1 and also PC2. In the cluster 2, we found the higher score in PC3 and PC4. Cluster 3, higher score in PC1, lower score in principal component 4. And cluster 4, highest score in principal component 2 and principal component 4, and lower score in principal component 3. And this is the They simplify the results. So the preferences regarding behavioral and living environments among different energy consumption level, we can find that in cluster 1, with the lowest energy consumption, they tend to non-coexistence with nature and religion, and then they also tolerant with hot environments. And then in cluster 2, in the lower medium energy consumption group, they prefer to live in the traditional design and prefer stay in the closed place. And then for the cluster 3, they are upper medium energy consumption. They tend to socialize and then coexistence with nature and also religion's value. And then for the cluster 4, they are in the highest energy consumption group. They tend to intolerant with hot environments and prefer modernity, and also tend to stay in less sociable or introvert. And then this is the same result, and we move to conclusions. So from the conclusion, we can find that the annual total energy consumption for the respondents who live in Rusunawa, Rusunami, and condominium was 5 to 9 gigajoule per year, and approximately this happens in the 36.6 respondent. And then the average electricity, gas, and total energy was about 7.2 for the electricity, gas 4 gigajoule per year, and 11.3 gigajoule per year for total energy. And then for the PCR result, we can find the 4 components about preferences of living environments with significant influence on household energy consumption. They are first is coexistence with environment religions, intolerance with hot environments, traditionality, and introverted lifestyle. And then we also find that as the energy consumption increase, people tend to prefer less sociable, choose modern environment setting, and to be intolerant with hot temperature. Yes, I think that's all from me. Thank you very much.
Thank you very much, Oki-san. It is a good achievement. So we should think about not only the energy consumption, but also the preference of the lifestyle for optimizations. Okay, the next speaker is Andan Trihamdani. Okay, time is yours.
Okay, good afternoon, ladies and gentlemen. Today I would like to talk again about the window, but this time about low energy cooling strategies for public housings in the hot humid climate through window design. Okay, so basically the key words here is the natural ventilation, because but not only just making natural ventilation, not just open the window, but when we open the window, we get the proper wind speed, we get the proper air change rate, because by having a proper wind speed, we can have enhanced evaporative cooling. Our sweat can evaporate and that can enhance our thermal comfort. And also here, if we take a look at the thermal comfort zone for under natural ventilation, the upper limit of the comfort zone can be raised up to 2.2 degrees Celsius under 1.2 meter per second of wind speed. So natural ventilation is a simple and cost-efficient solution to promote thermal comfort, energy saving, and also good indoor air quality. But if we take a look at our existing Rusunawa design, for instance, we can see, regardless of the climate, regardless of the locations, the window designs are the same. If you take a look at here, this is in Palembang and this is in Yogyakarta. They are the same. This is in Palembang in Manado, also the same. And just copy paste without considering the climate and also the geographical locations. But Rusunawa mostly using air conditioning, because they are mostly using natural ventilation, because air conditioning is prohibited. If they use AC, they have to go out from Rusunawa because their income level already good enough to have AC. And typical design, and as mentioned before, without consideration of ventilation performance. So no lack of quantitative evaluation when designing or proposing the window. So our study aims to investigate the effects of opening configurations on the ventilation performance and thermal environment through field measurement and also through the computer simulation. So this is our methods for the numerical simulations. We divide it into two phases. On your left hand side is the phase 1. So we only study about the opening configurations. So we set up a base model like this, a very simple 3-story building with 3 units with 3 by 6 meters and a corridor. And we assess the opening size and proportion. For instance, this box is this facade of each unit, and the red color meaning the opening. So the red color meaning the opening area that, let's say it's a hole that the wind can enter. So opening size and proportion, for example, big, medium, small, either up, and opening size position either on the top, bottom, center, top and bottom, left or right, and also the window types. For this is the typical window used in Indonesia: casement, top hung window or jendela jungkit, yeah, and pivot windows either horizontal or vertical, and sliding windows. Then after having this phase 1, we do the field measurement to test whether this simulation results is suitable or say can be represented in the actual condition. Then after that we do the phase 2. So we consider several building configurations. So previously only 3 stories building, but in the phase 2 we consider several building heights. On the bottom image you can see the from 5 stories building, 15 stories building until 37 stories building. And this is for the field measurement. On the left hand side photos, it's our experimental house located in Tangerang, Indonesia. So we have 2 identical rooms. We call it room A and room B, and we set up several sensors here horizontally and also vertically to measure the wind speed and also the thermal environment. And this is the results of the numerical simulations. The table shows the combination between inlet and outlet. On the upper left is the description which one is inlet, which one is outlet. So inlet is where the wind coming into, while the outlet is where the outcoming air will go out. So we can see here, this table shows the temperature difference between outdoor and indoor, and also the air change rate. So we can take a look at here. The bigger the opening size between inlet and outlet, we can reach higher ventilation performance. So here is up to 800 air change rate per hour. You can imagine how fast the air can change within 1 hour. And if you want to know how's the ventilation performance of the existing Rusun, you can see here, this is now outlet, meaning single side ventilation, and this is maybe the typical opening size, yeah, in Rusun. So we can take a look at here. The air change rate is very small, 0.7, while the national standard says should be more than 4. And in this case, this is only opening without windows. But if you take a look at the window, how the window affects the ventilation performance, this table shows the ventilation performance for air change rate and also for the operative temperature indoor among several types of window under 2 different wind conditions. The blue color showing the front wind, meaning that the wind coming perpendicular to the facade, while the cross wind, the wind coming about 45 degrees to the facade. Here we can see that, let's take a look again, the typical window in Indonesia, the top hung window. You can see the ventilation performance is very, very poor. But this is the most common window type used in Indonesia. While if you take a look which one is good under front wind or cross wind, we can see maybe the good option would be central pivot or horizontal. And what else? Yeah, this is the best for the cross and front wind. While this is also good, but maybe only good for the crosswind. So different wind direction, different ventilation performance. And then we try to verify the simulation results through the field measurement. So we set up several opening types, from large opening, top and bottom openings with windows, and also very small opening on the upper side with this kind of window, a double vertical pivot window like this. And these figures on the left hand side showing the indoor airspeed under several vertical height levels. So we can see the typical is the gray color, and the large opening like this, the indoor airspeed is around 0.1 meter per second, while the small opening like this can provide proper wind speed more than 0.2 meter per second. So according to the Singapore guidelines, the wind speed more than 0.2 meter per second is considered as good. So it's already good enough. So it means that in order to provide good ventilation performance, it doesn't necessarily need large opening, but a small opening but properly positioned, properly designed, can also provide good ventilation performance, and also for indoor air quality, and also for the thermal comfort. And on the graph on the right hand side showing that large opening, the orange color, tends to overheat during the daytime because the air change rate is very high, so more outdoor air, warm outdoor air coming into the indoor space. So that's why it tends to be overheating in the daytime. And then last, after we get this one as the best window that can provide a good indoor air quality and also enough wind speed for the thermal comfort, we test this window under several building configurations, from 5 stories building, 15 stories building, and 37 stories building. And this is the flow that we want. We want the air to the occupants levels, not to the ceiling, not to the floor, not to the side walls, but to the occupants level. And this one is represented in the blue color in this one. So this is the number of stories, and this is the unit horizontally in the windward and also the leeward side. So we can see that this one is considered best, but when we test this window under several building configuration, the ventilation performance is not the same. It's not equally distributed. So this is another challenge, to provide equally distributed ventilation performance amongst the units. So this will raise 2 questions. Number 1 question is whether we need to design different window for different levels or different zones, vertically or horizontally. Or the second question, is there any special type of window that can perform consistently regardless of the location, regardless of the position? That's the eternal question that we want to solve in this project. So the ventilation performance depends on the unit location and positions, and it is a challenge, again, to provide equally distributed good ventilation performance. So I will just go through the point number 4. Maybe that the specific window design tailored for particular location of the unit can be one of the solutions to ensure good and equally distributed ventilation performance in public housings. So we can think together about this point, and if you have ideas, we can share together in this forum. Thank you very much.
Thank you very much for the presentations. So we'd like to move the question and answer times. So please raise a hand if you have a question to the specific speakers, and please say your name and affiliations and questions. Is there anyone who have a questions? Okay, please.
Yeah, I want to ask a question to Mr. Andang. Can we design the custom design for the windows to opening like this, and then the same window open like vertically pivot? Or also if we think about the NACO system, we can have a different width of the blade of the glass, so we can control how much we want to open the NACO. Thank you.
Okay, thank you very much for the questions. The first question about the design of the window, whether it can open like this and like this. So basically that's possible, but it needs required. In Germany there are some windows that can open like this and can open like this. It's called a tilt window. But the problem is the parts. Currently it's maybe not considered as affordable, but it is possible. And in Singapore also they have the mechanism like open and slide. It's also possible. But again, the problem is the price. And but the NACO system, it's very possible. For example, it can NACO, for the one who not familiar, is called the louver window. So many glass louver, and yeah, it's very possible to divide into several segments. And regarding the NACO window, maybe yesterday I already shared with Pak Yusing. NACO is one of the solutions for the question number 2 that I mentioned before. Is there any special type of window that can perform consistently? And NACO can be one of the options. But the problem is the current NACO is only open up to 90 degrees. But when in the unit where the incoming wind from outdoor coming downwards, it will block, just like a jendela jungkit or top hung window. So if possible, the NACO should turn more than 90 degrees. So when the downward wind comes, it still can allow the wind enter the unit. Thank you.
So in Japan, so I have already mentioned about the screen mesh. Isn't it a big issue in Indonesia to put on the mesh screen for the windows?
From our experience with our customer, that's their desire. They want to, but they don't know how to get it. Yeah, they want.
But you can provide, right?
Yes.
Okay. Okay, is there any other questions? Okay, please.
Hello. So I have one question, like while evaluating the types of windows and associated ventilation or thermal comfort, are you considering the local future development that can occur surrounding the buildings? And is there any design of a window that can work for a current situation, as well as the if situation around the building changes, then it will work for that scenario also? Is there any that kind of design?
That's also interesting questions because basically in our simulation we do experiment even for our experimental house located in the open field. We don't know what will happen if there is our neighbor built another buildings, right? So and basically we now considering that solutions, but of course it should be verified through simulations. Now we have several collaboration projects with architects in a real situation, actual site, actual location, very dense, urban density, and that will be case by case. It's very difficult to generalize. So when we work together with architects, the location A need treatment A, location B need treatment B. So it's difficult to answer that at the moment with one single question. So it's always case by case.
Thank you very much. Is that okay? The answer is okay? Okay. Okay. I was in Tokyo. I would like to ask you the city, Opi-san. So will you show the comment from the internet? You cannot. Okay. Was the questionnaire initially designed with the intention of being analyzed using PCA from beginnings? That is a question for you. Yeah, the questionnaire survey was originally designed just for the PCA from the beginnings.
For the beginning, no, actually, the PCA conducted after we collected some information, after we conducted the evaluation group method. So in the second part, because we found that a lot of factors, more than 10 factors, then we want to simplify to make a axis to make a scatter plot to find, to put how different energy consumption levels. So after that, we conducted PCA. This in the second part. In the first part, we didn't.
Yeah.
Yes.
So the second question is, given that decision making is inherently tied to human behavior, could casual influences approaches be more suitable for rustling? I see. So please check LDA instead of PCA. So he is proposing to check the LDA, the kind of method. So okay. 難しい。
Thank you very much for the questions. So from Agung Tokyo, thank you very much. So yes, if the decision to use PCA came later, LDA, yeah. So for this, we right now we only, how can I say, try to use PCA. We haven't considered to use LDA instead. But thank you very much. We will consider to maybe for the further research. And then for the second questions. Okay, so maybe I would like to answer this question later. Is that okay?
Quite difficult question. Yes.
Maybe I need.
Okay. Is there any question from the audiences? Okay, please.
Hello, my name is Eugene from AGC Singapore. So I have a question regarding the effects of urban heat. In terms of natural ventilation, the assumption is that it will bring in thermal comfort. But in respect to urban heat island effect, actually, the ambient temperature outside could be warmer than inside. So you could be, natural ventilation could also mean that hot air is coming in instead of cool air. I would like to ask if any studies have been undertaken to study this effect. Thank you.
This is Andan-san's questions, right?
Yes.
Okay.
Yes.
Thank you for the questions. So far, we haven't considered about the urban heat island effects into our study, but in another study says that we better close our window in the daytime and to prevent more air, outdoor warm air come in. But we still need to open to maintain indoor air quality. So somehow we need to block the warm air from outside in, but we need to let fresh air in for maintaining the indoor air quality. While at night, it is recommended to open the window at night. But under heat island situation, nighttime would be warmer, right? So, but I don't know how significant it is to reduce the night ventilation potential. We haven't considered about that recent at the moment.
Okay, thank you.
Okay, is there any question? Okay, please, Maruko-san.
Thank you very much, Mr. Moderator. So I want to ask Dr. Andang. This is about the window design for Rusunawa and Rusunami, and I think for all apartment. So you said that the air through the windows, it's important, of course. But we construct a lot of rusun, yeah? And then maybe for the 4 stories to more than 10, so we also need about the safety, especially for the children. So if we can open wide the windows. This is very dangerous. And then you remind me about the design. All of Rusunawa is the same design for the windows, right? So this is, we have another problems, yeah, because in 1 year, so we have to construct about more than 100 tower. So we have a problem with design. So it's very ideal if we designing the window openings, depends on the condition of the environment in every location. So it means so many window designs. So that's why maybe we need the typical design, yeah? not so many variants. Or maybe we can have a design about the ventilation, not the windows, but the ventilations. Maybe more typical, it's okay, something like that. So that's the question is, there's any window design, the optimum window design. So we don't need to make a lot of variants because we have to construct in all of Indonesian area. Yeah, thank you.
Thank you, Pak Marioko, for the questions. Reflecting back to my presentation, I raised 2 questions, whether spatial design for every zones, meaning that so many variations, or question number 2, is there any superpower window in any condition can perform consistently? So now we are doing research on answering the second question, Pak. So hopefully in Tegal number 2, we can propose that prototype, and we can experience together whether that window can perform or not in the actual conditions.
Okay, thank you. So we are waiting for that. Thank you.
So I think I have already spent our time, so I would like to close my sessions. So thank you very much for joining and asking.
Thank you very much, Professor Takaguchi, for sharing this session. Ladies and gentlemen, I will deliver an announcement. Snack and beverage has been already served in the right side room. Participant can take the snack and beverage, but please to have a seat back because we will begin the 4th session. Thank you. Dear honorable participants, please make your way to the conference rooms as we are about to start the fourth session. The seminar is about to continue. Kindly be seated and fill in the front row. Distinguished participants, we are now in the last session of the seminar. Session 4 is a special session since we are going to discuss and elaborate the future apartment building design for energy saving and low carbon and how to standardize it. This session will be chaired by Professor Tetsu Kubota of Hiroshima University. He obtained his PhD degree from Shibaura Institute of Technology. Prof. Kubota is an expert in passive cooling techniques, natural ventilation, adaptive behavior, indoor thermal comfort, and urban heat island. His specialization is hot and humid climate, particularly in Southeast Asia. We will discuss this subject until next 1 hour. Prof. Tetsu Kubota, please move forward and chair the session. Time is yours.
Thank you so much. Terima kasih. Yeah, first of all, thank you very much for your patience and then really staying in the conference until now. Thank you so much. So yes, as she said that this is a special session, so it's a general discussion. So yes, so and also this is the exact final session. So therefore, please join us only slightly forward. Okay. So this I think the program is not indicated in your handout. So this is quite unique session actually. Now I'd like to create the program. So okay. So these are the can you open my slide? Okay. So now I'd like to invite the special speakers and also commentators. Okay. So for this session, so I'd like to invite two speakers. One is Yopi-san. Yes, he's a very young and very cutting-edge architect of Aknoma studio. So yes, he's talking about our next experimental house in detail after Yushin-san. Okay, number one, please come to the front. Thank you. And a second speaker is our close friend, Enrica-san. Enrica-san is originally working for PUPR, and now he's doing PhD in our research group. So Enrica-san, please, please welcome Enrica-san. Thank you so much. Okay. And then the third is, of course, it's not necessary to explain him. Yes, he is the best friend of our, of us, the Mas Ariel-san. Okay, Pa Ariel-san. Okay, thank you so much. Right, and then the last but not least, I'd like to also invite, the final commentator. So Diego-san, so he's my master student. He's now doing research on LCA, particularly focusing on the material flow. So I just want to invite him to make some comments, especially for the new experimental house project. Okay, thank you for coming. All right, so then the purpose of this session is quite straightforward, as you can see here. So we just want to discuss the future plans. Okay, so of course now, as I probably mentioned yesterday, now still in the just midpoint of our project, right? So we have still 2.5 years to go, as you may know, right? Of course, we have still so many things to do, but the today in this session, I'd like to focus on the two important agenda. So these are the important assignments for us to do ahead. Okay. One is, yes, construction of the, as I mentioned, new experimental house. This is going to be the hybrid structure. So this is agenda number one. Number two is the, in a way, most important, yes, as I mentioned very repeatedly, the ultimate goal of this project is to establish or revise the, yes, the standard, okay, for the low carbon affordable apartments. Now is probably time to start discussing these things, right? So how to standardize our research results. And okay, so that is the second agenda. All right, so thank you very much. And then the, next please, I'm sorry. Okay, so we have 4 minutes to go. And then I'd like to divide into 4 or 5 topics, as you can see here. So yes, I'm now making the introduction. And after my introduction, yes, I'd like to invite first Yopi-san to introduce, as I mentioned, yes, experimental house. And after that, yes, let's discuss the standardization. And after that, I'd like to open to all the participants, and then please give your comments about our discussion. Right. And then this is the flowchart, needless to say, of our project. So as I mentioned just now, so the 5-year project. Now we are in the midpoint. Okay. So the first phase is some fundamental studies over the last 2 or 3 years. Yes, we have been developing specific techniques, as we saw in the previous sessions, like radiant floor cooling system, for instance, or insulation, or window opening system, or and etc. Right? We have been developing this kind of very specific, the passive cooling techniques. Right? And then the climate team, for instance, also yes, conduct very fundamental studies and develop the nice climate zone. And now they are developing the TMY and so on and so forth. Right? And then energy team also collect the very fundamental data, which is also very important, like operational energy, embodied energy, and etc. Right. And then what we do next is, yes, as Prof. Asaba also mentioned, we now need to integrate these, the very nice specific, results, achievements into the design. Okay. And then, as you can see here, the second phase, right? After doing this kind of fundamental studies and specific development, we try to integrate these results into the design, and we now will develop the so-called prototype design of low carbon affordable apartments for specific each of the climatic zones. Okay, so that is the next mission, right? And then, yes, we will develop several types of the prototypes. Let's discuss later in detail. And we will pick up one of them, and then we will construct this in Tegalu. Okay, together with, yes, Aknoma, as well as Mr. Eko and all of you together, right? Okay, then after that, yes, we will, yes, summarize all the results as a guideline, and then propose it to the, yes, PUPR, right, as a guideline or building standard. Okay, this point is the second agenda. Let's discuss how best to standardize our idea, incorporate our idea into the, the guideline or building code, right? So that is the second agenda. Thank you. Next one. Right, needless to say, yes, this is the, we never change actually. So this is, this is a very old-time slide in a way, but still we maintain the, the big structure, framework of a project. Our project still comprises 5 groups, like climate, human, building, energy, and now we are discussing the number 5, implementation, right? How to implement, right? Yes, in practice. Okay. Next, please. Okay, so this is the new slide actually. I have just prepared this slide this morning, so I hope this works. Just a moment. This is my idea. I mean, how to integrate our specific results into the prototype design. Okay, this is just my idea, very tentative idea, right? So therefore, please make your comment after this the session, during this session. Number 1 is yes. Can you click once? Can you click once? Okay, right. design modification, right? So just let me explain first, right? From the left to the right, right? First, typical layout. This is what Enrica-san did, right? Enrica-san collected the hundreds of drawings from the Rusunami and Rusunawa, and then he analyzed the typology of the apartments, existing apartments, and classified these 300 to 300 and so on and so forth, and he, determined the so-called typical layouts of the existing Rusunawa, Rusunami apartment. That is his achievement, number one, typical layouts. Okay, and then, yes, we now try to modify this, typical layouts, right? So one example is, yes, void, for instance. Now we found that, yes, the existing apartment is not so good in terms of the, especially Rusunami, in terms of the cross ventilation. So therefore, one possible design modification is perhaps we can incorporate the void space into the, design, right? So that is one, the possible modification, right? That is the, the upper part, right? And I have also idea about the high ceiling. High ceiling design can be, also can, improve the thermal comfort for the tropics, right? So this is just a tentative, but the, yes, still we haven't studied, but the just my tentative idea. Okay, that's number two. And also that, as you may know, that now we are interested in the wooden structure. Yes, someone will explain about this, in detail. Yes, that is number three, and etc. The number four is, yes, why PUPR? Because the PUPR is also they are the proposing and developing this kind of so-called prototype design, actually, basically, right? Why don't we integrate into one? Because they are doing almost the same things, actually. In Jakarta, they are always studying and then they're proposing this kind of prototype design for Rusunawa in particular, right? So I'm thinking how we can, if we can integrate into one, right? So we can work together. So that is, therefore I put PUPR, right? Anyway, so that is, yes, after the typical layout, we can modify the design, right? And then we can propose that, some base models, not only typical, layouts, but also modified, the design. So then altogether, let's call it base models, let's say, right? And then the second is, yes, the specific techniques, right? So yes, we conducted together with the IT and etc. Yeah, we conducted first, literature review and so on and so forth, and we, already identified that possible passive cooling techniques at the beginning. And then, in fact, of course, as you all know, that we, as I mentioned, we are developing the specific techniques like radiant cooling system and insulation and window, system. And now the Hirayama Sensei now just started the evaporative cooling and etc. the specific techniques, right? And then, after that, we try to, incorporate this kind of techniques into the, base design, right? So that is the passive cooling techniques on the right-hand side, right? And then the quick ones. The last one is the evaluation, right? Assessment, right? This is the, in a way, the, okay, let's take a look. Right. The Dewa-san's climatic zone is so important in a way. It's a foundation for our evaluation, right? So now he nicely classified the Indonesian climate into 4 or 8 zones, right? That's very nice work, I think, right? So take this as a foundation. So of course, the climate team now they're very working hard on the development of the TMY, not only for the current condition, but also for the future condition. That is the upper part, right? And then the Sakoi Sensei's team, yes, now the first, they are very much focused on the closing ensemble, right? That can be also used for the standardization in a way. And now they are doing the very nice intensive field works, and then they will be able to develop their own adaptive comfort standard. That is the second one, right? And then the contact cooling is also very important, needless to say, topic. And then that can be used for the evaluation, perhaps. That is the third one. And all-in-one, yes, let's say the evaluation, group, let's say. And then by making use of this kind of evaluation method and tools, we will do the optimization, right? So we need to judge whether our prototype is really appropriate for each of the climates, right? So that is the optimization. let's say we have so many now tools, right? Screwdriver, spanner, and so on and so forth, right? So we need to find the optimum combination of the passive cooling techniques for each of the climatic zones, right? That is the number 3, yes, the optimum combinations for each of the climatic zones. That is the next important task, right? And then after that, finally we can identify the most appropriate prototype for each of the climates. That is the last one, the prototypes. Okay, so this is just my idea. So this is my idea of the how to integrate our, all the results into the design prototypes. Okay, next one, please. And then this one, I have already explained this to you. So this is just a, again, image of the final image of the standardization, right? So yes, as I mentioned, that Dewa-san's climate zone, Dewa-san and of course Anemia Sensei's climate zone is on the right-hand side, right? And that is going to be the the x-axis of this the matrix, right? 1A, 1B, and until 4B. Now the 8 climatic zones, right? And then now the TIT team and also the Hiroshima team in particular all together. So now we try to develop the prototypes as I mentioned just now, right? So that is going to be the A, B, C, D, E. This is just a tentative model, so please ignore, right? Anyway, so that is going to be A, B, C, D, E, right? And then we will assess the performance of a prototype for each of the climatic zone, and then we judge. Okay, let's say that in the case of climate zone 1A, okay, let's say this is just an example, maybe the prototype B and prototype E are very appropriate in terms of thermal comfort and also in terms of energy and CO2 emission, right? And maybe we can summarize all the assessment results into this kind of the matrix form at the end of the project, right? And then my tentative idea is maybe, yes, after preparing this kind of matrix, so we can incorporate this kind of matrix in the existing guideline. For instance, I know that, yes, they have already some, the design guideline for Rusunawa, Rusun, right? So maybe we can put this idea as an appendix of the existing design guideline for Rusun. So that was my original tentative idea. But now I don't know. So today, let's discuss how best to do this kind of standardization. All right, thank you so much. Next one? Oh, I think that's all. Next one? Okay, thank you. And then let's move on to the next. I'm sorry I'm talking too much. Anyway, next is so let's move on to the first topic. First is the next experimental house. Okay, before discussing the standardization, let's take a look at in detail about the new experimental house. Okay, Officer. Okay.
Thank you, Professor Tetsukubota Sensei. Yeah, good afternoon, everyone. I hope we are all in good and fresh condition after coffee break. Okay, at this time I will present the progress of our design, experimental housing part 2, that we call it hybrid timber housing. Okay, next. Firstly, maybe we can see the set condition and the set position. Our experimental housing part 2 is located in former of fish pond of the near of Tegal Ring Road, or we call it Jalan Lingkar Utara of Tegal City. And in the number 1 is Rumah Susun MBR part 1, and we can see in number 2 is experimental housing part 1, and in number 3 that it color blue is pump house. So our set is in number 4. Next. Yeah, near on the side we have small river that flow toward into the
see on the city Tegal. We can see the set location is not too big on there. Maybe we can see an photo existing for the some point. Next, this is the location of the experimental housing part 2. You can see in the position of the experimental housing part 1 and also Rusun MBR in the behind it. Okay, next. Okay, I start from the ground floor. We have actually 3 story with 1 attic in the floor plan. In the ground floor plan, we have open layout floor plan that we have some multifunctional area for maybe to make some sustainability for economic to the resident and also for motorcycle parking. Next. In the first floor plan and second floor plan, is a modular plan. We have maybe double loaded type of housing, which is in the middle we have a wide corridor, and each story we have 4 units. So in this building we have 8 units for the resident. For in each unit we have 2 bedroom for master bedroom, and also we have kid bedroom and living room that compact with the small kitchen in there, and we have balcony that have orientation to north and south elevation. In the west and east area we have like a small maintenance balcony that can be function as a secondary skin to avoid sun heat from the east and also west area. Next, this is same for second floor plan, modular. Like, okay, next. This is attic area. We have attic area for common space or communal space for the resident, which is we have for common space and the wide corridor to make some activity for the resident. Next, and this is a water tank area in the top of the building. Okay, next. Okay, this is a prototype. I think prototype when we make it for making long and row housing. So in the middle we still have void to make airflow from the bottom to the entire of the room from the housing. Next. Okay, this is the axonometry of the building. So we have, actually we have 3 story with 1 attic in the top. Well, the roof material we still discuss. Also, we can use PVC, bitumen, or metal sheet. But in above it, we must be using insulation, thermal insulation. And for the material of partition in the external area, in number 2, we try to propose locally traditional technique, with bamboo woven plaster panel as external cladding, and also in number 3 we have a secondary skin that can be covered to the west and east area. We using wooden jersey panel with wire mesh to media growth of the vines. Yeah. And number 5 we can see 2 small tower tunnel to wind tunnel in the center area. Next. This is a section of the main section of the building. We can see each stories. In the bottom, in the ground floor, we have open layout area. In first and second floor, we have a unit for the residential and yeah, pakai contekan, Pak. Yeah, and we in the attic we have in the fourth floor we have attic to common space. Next, we try to propose to make some material into the above of the ceiling. We try to propose with rice charcoal that can be control the humidity of the interior, and also we can put the mineral wall insulation like stone wool to make some thermal insulation material. So we can see in the middle we have a wind tunnel that connected with some service and kitchen area that can be when we cook something, the heat from the surface or kitchen area can be flow into the top area. Next. Yes, this is our assumption about the airflow condition from the building. Next. Okay, for the external cladding, we try to propose with a semi-traditional scale and semi-traditional material with bamboo woven plaster, and we can put it in the external, and also we have some layer in external area with bamboo woven plaster, insulation thermal, and inside of the room we can take with some panel like GRC or any other. And also in each of the story we have a translucent roof to avoid this water shock from the raining, and also wire mesh panel for the fines. Okay, next. This is a west and east area that we try to put secondary skin on there. Can be applied with wooden fiber GRC panel, and also with wire mesh for the fine screw media. Yeah. Okay, next. Okay, this is a image of the building structure that we can see. The building structure is combination between reinforced concrete and also wooden structure 2x4. So I think this is 15 by 50%. So this is, we call it hybrid timber housing. Next. This is a structure without 2x4 structure wooden. Okay, next. This is another view of the structure system. Next. And we can see with the wooden structure 2x4. Yeah, this is another view from east and west area. Okay, we try to make some render image from the existing site and the location of the experimental housing part 2, just like this. And this is another view of exterior rendering image. Okay, this is in west and east side that have secondary skin. Next. Okay, this is interior image you can see in the ground floor we have open layout, and for food stall or for parking motorcycle, and also in the corridor of residential unit, you can see this is in the below we have a small void to flow fresh air into each room. Next. Okay, this is another view of ground floor, and this is another view from the corridor of the residential unit. Okay, next. Yeah, next. This is a view rendering from each residential unit. You can see the living room, and also we have small kitchen and small living room, small bathroom, and we have access to the balcony for wind catcher to every living room. Next. Yeah, we try to making some alternative material that we can see the different situation between each material. Okay, next. This is a master bedroom. Okay, next. And this is we try to make some combination of the different material to the master bedroom. Okay, next. This is a children bedroom, kids bedroom, fit for one single bed, but we try to make another alternative with bunk bed. So we fit for 2 children in the inside. Next. Yeah, like this. Okay, this is a rooftop area, attic area, that can be functioned as a common space or communal space. Next. This is the situation. And this is another view from the east and west side. Yeah. Okay, that's all from me. Thank you for your attention.
Terima kasih. Thank you so much, Mas Yopi. Thank you very much. Yes, this is what we are now developing actually. So we are working very closely, yes, between the two countries, and then this is the latest progress. So I really thank Yushin-san. Thank you very much. Okay, so now, as someone also mentioned, that the wooden structure is something boom, right? Because we believe that the wooden structure can reduce the energy, especially so-called embodied energy, the energy used during the construction, very much. So therefore, now the many countries, yes, even in Japan, Tokyo, for instance, we are constructing this kind of wooden, relatively high-rise, multi-story buildings in many parts of the world, right? But I believe that the important challenge ahead for us is the cost, needless to say, because we are now dealing with the Rusunawa, and then we are targeting the relatively low, income group, needless to say. So therefore, we need to, save the cost as much as possible, very dramatically. So then we were interested in so-called CLT and so on, so advanced, the building material, but such things may cost a lot. So therefore, we decided, thanks to some advice from a Japanese wooden company, so we almost decided to apply the so-called 2x4 system in order to reduce the construction cost. So that is what he is now kindly proposed, actually. Right. So, okay, so now this is special session. I just want to invite especially my student, Diego, to make some comments. Okay, so since he's now doing the research on LCA, particularly focusing on the material energy, so therefore, okay, so please allow me to give some question to Diego. Okay, so Diego-san, so just can you tell us approximately, based on your research results, how much embodied energy can be reduced by this kind of wooden, hybrid structure?
Thank you so much, Kubota Sensei. Good afternoon to all the dear audience and also the audience that join us online. So regarding your first question, Sensei, according with our progress so far that we have conducted together with my colleague Rico Koda, we could have savings in terms of embodied energy and embodied CO2 emissions of 22%. Also, if beyond using a structural material from wood, if that wooden material is domestic instead of, for example, glulam made from javon wood, which is already used in Indonesia, this will represent a reduction in the further half of the embodied energy and CO2 emissions that, for example, bringing wooden material from China. Chinese hop-horn bean is also already available in Indonesia. And beyond the use of harvested wooden products for structural use that, as you already mentioned, has some issue with the price, right? It's an emerging technology, and the economy of scale is not is still very small, but hopefully we will make it there to these materials to be already available. But beyond that, if the building materials for Rusunawa in an hypothetical scenario, they were all domestic, contrasted with imported products, if they were all domestic, we will have reductions of embodied energy and CO2 emissions around 48%.
Thank you so much. Thank you so much.
Yes,
I
yes.
think yes, it's a quite reasonable answer. So it's better to, needless to say, to use the domestic material as much as possible. Yes, that's very true. Yes, and then the second quick question is that yes. So you said javon, but anyway, so what kinds of species, what species of wood? I'm sorry, the supposed to be the most suitable for the the wooden construction in Indonesia, based on your perspective?
No, thank you so much, Sensei, for your kind question. So Indonesia is blessed with abundant timber resources. So it is a country that exports, has a big market of wood exporting. Species such as Meranti, antique, are very famous from Indonesia in the international market. They are renowned by their quality. However, they are expensive. So that's where javon species like javon, sengon come into place. So these species are fast-growing species. So the rotation year, for example, of Meranti wood, in order to be commercially available, is around 30-40 years, which is hardwood of high quality but expensive and from big rotation period. Javon and sengon is available for harvesting after 12 or 15 years. So these are very short rotation periods, and this wood, javon, sengon, these woods have around 0.3, 0.4 grams over cubic meters of density, and this is the type of wood that can be improved by glue laminating into producing cross-laminated timber or glulam. So, for example, with Meranti and other hardwood species, their density is already high. So it's not that reasonable to treat them with another process. They are already good. But these species, sengon, javon, they have a long, short rotation period, and that make them more economical than traditional harvested species in Indonesia.
Okay, so yeah, thank you so much, Diego.
Yes, Sensei.
Then, so I'd like to invite some questions, but now the time, because of time limitation, so let me move on to the next topic, and then I would like to invite the questions later from the audience. Okay, so the next agenda is, needless to say, the standardization, and then I'd like to invite the close friend Enrica-san to give some presentation. Thank you.
Okay, thank you very much, Sensei. Can you please share my slides? Yes, okay, as Kubota Sensei already mentioned on the introduction, so on this opportunity I would like to share some ideas about doing standardization on the Rusunawa for the low carbon development. I would also like to share about some discussion that we made with Sensei and also some colleagues from the Ministry of Public Works and Housing, including with Bu Ira also as the director of Bina Teknik, or maybe I can say as the director of standardization agency perhaps for the housing sectors in PUPR. We also have some discussion with the Directorate General of Housing as the implementers of the Rusunawa in PUPR. Maybe there will be some colleagues also coming from Directorate General of Housing in this seminar perhaps. So maybe if I'm saying about something wrong, maybe you can please kindly correct my statement. Can I? Yes. Okay. Maybe this one is not. Yeah. Oh. Thank you for the. So for the first slides, I would like to share about the how to say, like the hierarchy of the regulation in Indonesia. From the highest level, there will be some national law. So why I put the policy on top of here, because usually some government policy in the central government used to be follow up with the national law. For instance, in 2007 we have the national policy of 1,000 towers, and 2015 we have the policy of 1 million housing program, which accelerates the number of housing in order to reduce the backlogs of housing in the urban areas. Those policies were followed by several laws and regulation and also standard and guidelines in order to make the implementation goes running smoothly. So on this particular session, I would like to limit the number of law and regulation and guidelines that is pretty much related with our topics, which is the Rusunawa or Rusunami or apartments. So can I summarize maybe one of the summary from the regulatory frameworks? We have in Indonesia, we have the Omnibus Law in 2020, which basically merged all the national law, merged several national law, or maybe all national law, into one regulation in the national level. Under this regulation, we have the derivative regulation, which is the government regulation. This one is number 16. This is entitled about the building law implementation. So we have the Indonesian building law were established in 2002. So under this Omnibus Law in 2020, we use this government regulation number 16. Which is also related to our topics into some sustainable housing of vertical housing, the Public Works Ministerial Regulation in year 2021, which entitled the performance indicator assessment for green buildings. So this one may be also very interesting, and there are also some Indonesian national standard which is related to our topics that I collected and put it here. These are the definition of the green buildings according to this government regulation. So the dimension, the aspects of the green buildings were quite huge, like they involve energy, water, and other resources for the green building. This is a basic building standard for minimum requirement for building standard according to our building law. Still, we will still use this. There are four main aspects: the safety aspect, healthy aspect, comfort aspect, and convenience aspect. So under these concepts, there will be so many other things that need to be considered as the very important parameters to have a building that is meet the standard requirement. This one I would like to share about one of the content of the green building performance indicator assessment in 2021, which is basically have at least 7 performance indicator evaluation, including site management, energy efficiency, water efficiency, indoor air quality, the use of environmentally friendly materials, waste management system, and wastewater management. So these are the indicators that were assessed to give some certification on green buildings in Indonesia. One of the discussion with Ibu Ira during that time, maybe also Mas Ariel also, there were some ideas and say whether we can have some derivative regulation under this ministerial regulation, which is specifically discuss about some additional guidelines for Rusunawa, which has the thematic approach of maybe low carbon development or low energy housing, for instance. So that will be some of opportunity to mix. Basically the discussion with several colleagues from PUPR, they were agree that we should use the result, the findings of any particular study, especially under this project, to be used to be implemented in the real building sectors. One of them is by making the findings of the research to be put in some regulation. So according to some discussion, at least there are three aspects in order to implement the standardization. The first one is how to build the awareness. This one is probably quite difficult, but we need to make approach to every level of policymakers in order to build the awareness. Second one, after we have some awareness, maybe we will need some regulation. Under this regulation and guidelines, we may implement any particular values under the research findings, for instance. And then the third one, perhaps we need some showcase. So after we have the awareness, we have the regulation, we need some example, some pilot project, which is very important. So people will see the actual implemented findings of the research to be really implemented and be very useful, and also be contributed also to the national agenda, for instance, in order to achieve the low carbon development, for instance. So building a showcase and pilot project is a very important matter also. This one is just some example of one of the content of the Indonesian national standard. This is regarding the ventilation system design and air conditioning in buildings. There are some words, some statement there that saying, like, for instance, the standard of thermal comfort for the cool, comfortable, the optimal comfort, and the warm, comfortable. Yes, something like this. The level of humidity, the use of open layout that is being recommended for for a good ventilation system, and so on and so forth. And we also found one of the the implementation guidelines from the Directorate General of Housing. So now they already have this kind of guidelines, very practical, very implementable. So for further use by the implementers of the Rusunawa in Indonesia, under the Directorate General of Housing, they have these guidelines in the end of 2022. And we also look at these guidelines because they have already some specific knowledge about how to do the planning and design by using some approach in green building approach. So these are some of the contents. They have the technical aspects, basically the site analysis, the design building, and including the interior designs. This is one of them. I quote from the guidelines from the DG of Housing. These guidelines already mentioned about the type of balcony, for instance, the type of mass configuration on buildings, the type of microclimate and orientation. But on this particular guidelines, they only mention one reference to be used as the weather data, for instance. This one they they use the reference of Climate One building, if I'm not mistaken, to download the weather data. But actually, by having this study, we already have like study from Kagoshima University. We have the Indonesian climatic zoning, which is more precise, and also the proposal of the TMY that can be really specifically able to use on the future Rusunawa designs. So on these guidelines, they talk about microclimate, building orientation, building material, also including some reference about the thermal properties, type of balcony, shading device analysis. So it's quite technical, and if we can have some suggestion, recommendation according to our findings in the research, maybe we can have some additional appendix. And we already discussed this with DG of the director of Rusunawa, and he kindly accept that this kind of regulation can be modified if we have the academic manuscript. Even he also suggests that it's also possible to put these guidelines of our recommendation into a higher level under the ministerial level, if necessary. These are the example of how they put some thermal material properties. This is the typical material that were being used in the Rusunawa building. So they have some reference to be put here in terms of density, the thermal conductivity, specific heats, and etc. So what I'm trying to say is that this guidelines is already very technical and kind of academic. So I think we are in the same line, and if we can propose some modification or some improvement, it will be also very acceptable. For now, they have this prototype of Rusunawa to be built in Indonesia. There are several, let's say 4 major types of Rusunawa. The first one is commonly used for students and for army, armed force, police, and etc. And then for the low income group, usually to be concentrated in the type 24 and 36, and type 45 usually mostly maybe used for state civil servants. Is it correct, Mr. Ardu? According to my knowledge. And they have the design also, what kind of building that can be developed on each types. This is they call it Asrama Wiyata 24, Meraki 24. And this is the type 36 and 45. Type 45 probably can be raised into high-rise floors, more than 8 floors.
Enrica-san, 1 or 2 minutes.
Okay, Sensei. I think I almost finished. Yeah, and this one is the type of windows that they were using typically in Rusunawa, as previously discussed with Andang-san and Marigo Sensei. Maybe it's very interesting to see in the future that we can have some improvement in these aspects. Maybe not too many variation, but maybe we can improve the use of windows for natural ventilation. I think that's it, my Sensei, for my presentation.
Right,
thank you very much.
Terima kasih. Yes. Yeah. Okay, let's give applause. Thank you very much. Thank you very much for explaining the very important points, actually. So, originally, I think all of you remember. So, I think original purpose, the goal of our project was to incorporate our research results into the SNI. SNI is a national standard. But now we found that yes, there are high hierarchy in India, say for the building regulation. The top one is yes, the SNI, the national standard. But as he said that there are hierarchies, and then the ministry level, and slightly lower level is the, let's say, DZ level, and etc. Right. So now that yes, in other words, that there are so many options in a way to incorporate our idea into the regulation, because the level is different actually. So then now we found that the SNI is a bit difficult because it takes time. So if we want to incorporate our idea into SNI and establish the new standard, this alone will take 2 or 3 years. So therefore, now we think that it is not necessary to go for SNI. Rather, we try to incorporate our idea in the slightly lower level of the standard. And so that is the current idea actually. But now we don't know which is the most suitable for our standardization. All right. So now I'd like to invite, needless to say, our best friend, Mas Ariel, and then to give some comments. So I'd like to, frankly, I'd like to discuss how best to, do the standardization in our project. I would like to, frankly, hear your, kind opinion as a project leader. Thank you very much.
Yeah, thank you very much. Probably I will not take so long time since our time is limited. So I think it is better if we give chance for, like, say, Dr. Marioko or maybe Mr. Eko. But don't need to give additional comments. Nevertheless, so yeah, actually we hierarchical regulation, yeah, this is true. So the lower rank regulation should not or must not different from the higher level of regulation, right, Mas Andika? Yeah. So the lower rank of the regulation must in accordance with the higher. So our idea was during the discussion, including with Bu Ira, so we mentioned about the easiest way, but quite strong of the regulation is through the circulatory letter of the minister under the umbrella of the ministerial regulation number 21 year 2021. So as you may know that under ministerial regulation number 6 number 21, there are already two circulatory letter from the minister. One's concerning the technical guideline, very technical guideline of the how of the assessment of the green building performance, and the second is green building performance assessment for building, for residential building. So there are already two circulatory letter. So if we want to dig into the detail for some important keys, important points, for example, in that ministerial regulation, they are definitely mentioned about the passive design, right? Passive design, about the site development and so on and so forth. So in order to further interpret that those clauses and give more explanation in detail, so we can use that kind of regulation. SNE or SNI is it is voluntary, and it becomes mandatory whenever it clearly mandated by the regulation. For example, yeah, ministerial regulation, if in one of the clauses said that you must refer to this standard, so that standard is becoming mandatory. That is the big picture of the regulation in Indonesia. So yeah, and now we are now trying to extend the old standard concerning the I forget the name, but number I still remember clearly, 6572 into 3 different standards. Now is still running. One will become the standard of ventilation by referring to the ASHRAE 62.1, and the second is standard of thermal comfort by referring to ASHRAE 55, and the last is standard for calculating cooling load, and probably it's also referring to some standard. So yeah, it takes time, probably 1 or 2 years, still not yet finished, but we are going heading to that direction. I think that's all. Thank you.
Thank you so much for the very constructive, comments and very encouraging. Thank you so much. So now is I think how many minutes do we have? 3 minutes? 5 minutes? 5 minutes. Okay. So by making use of the rest of the 5 minutes, so I'd like to invite some questions or comments from the audience. Okay. Prof. Marioko, yeah. Marioko Sensei. Microphone. And after that, yes, Doni Sensei. Microphone.
Okay, thank you very much, Kubota Sensei. So I like to speak more, but very limited time. So I just talk about the this Rusun structural system. So first is I agree this we can construct the hybrid structural system on concrete and timber. It's very good. And then, but can we show the structural system slides? So for the until story 2, yeah, level 2, it's we construct by the RC system, right? And then also the stair space, also the frame of RC. But another frame, I don't know why you make the structure, the RC system also. I don't know what the space for. And then about the timber materials, Sensei. So I agree with Diego Sanz. Yeah, you explained about the species, especially for the fast-growing trees in Indonesia, like sengon, jabon, and everything. Say about the frame structures system. So it's better if we use this material. Yeah, and if you want to use the 2x4 system, 3-dimensional frames, yes, before this. Okay. Okay, before? Yes. So what's the frame is this? So I don't know why this you have to use RC also. This frame, it's okay because we have a stair disease. And maybe later we can discuss about this, because it's okay if this is the RC frames and then all of second stories and then going up is timber. So anyway, if your system is about 2x4, we have a factory in Indonesia who make the 2x4 timber. You know the LVL system, right? The LVL type, laminated vinyl lumber. So they use sengon, yeah, full sengon they have, and then also sengon and rubber wood. This is the size of 4 by 5 centimeters by 9 centimeters. So that's yeah, close to 2x4 inches. So it's very good materials, but they do not sell the materials in here. They export. So if we agree to use this one, so we can talk with them. Yeah? Can they provide us about this? Okay, and then also another materials is about glulam. Yeah, so glulam we use column and beam, and then the price, it's average for glulam. It's about 4.5 to 6 million per square meter. Per square meter. Yeah, the materials. Yeah. So they also constructed the system. But for LVL, it's about 400 to 500 to 600, yeah, dollars per cubic meters. It depends on the what kind of chemical we want to edit. And then another one is about the roof structure system. So you will use the attic rooms, and then you put the room frame by the 2x4, yeah. So also it's better or more better you use glue lamp. Yeah, it's very beautiful. Yeah, we can discuss more details, and Kubota Sensei can decide which one. And also I heard maybe the Sumitomo Forest can support us, but yeah, I still thinking about the local materials, so they can making about the components in Indonesia or others, yeah. So that's very nice. So we need more discussion for this. And then I think for regulation also we can discuss later, because little bit long time to explain. Okay, thank you, Sensei.
Thank you very much for your very important question. So maybe you can quickly respond to this. Maybe quickly. Why?
Okay, thank you, Pak Marioko, for the question. Yeah, maybe currently we still on the schematic phase, yeah, because we try to in this image maybe we have some point that maybe inefficient structural. So maybe after this we can try to calculate it structural for the reinforcement, and also connection between RC structural and also between and also with wooden structural. Yeah, it's because we still on schematic design phase. Yeah. We still not enter to detailing analysis, but your input will be make our design better. Yeah. Mungkin Pak Ising. Yeah. Yeah.
Yeah, for protect the wooden structure, so we use also RC structure for bathroom and laundry. Yeah.
Yeah, before slide. In here also the bathroom, yeah?
Oh, no, that's the community corridor, the main corridor.
In this one?
Yeah, the main corridor.
Okay.
Yeah.
Yeah, we can discuss
yeah,
technically later.
Yeah, thank you.
We purposely apply the concrete line for the community space to maintain the lower temperature during the daytime. Okay, thank you very much. I understand. Let's discuss the detail later. So this is supposed to be the last question. Maybe Doni Sensei, so you kindly raise your hand. Yeah, after that, okay, Jaya echoes, Mr. Eko, and then let's, maybe we need to close the session. So after, okay. Okay.
Okay, can we start? Okay, thank you very much for the opportunity, for the times, and I just want to discuss about this designs actually. So this is what you call wind turbine. So I just afraid that this is effective workings. I don't know. Maybe you have to simulate about these ones. Because as our experience, I don't know. This is a wind catchers or stack effect. The wind catcher and stack effect is very different. Yeah, different how to
it's
work
stack
actually.
Stack
effect. If you say this is a stack effect, so you have to make that the peaks or the roof of this stack effect is more hotter than in these ones.
Yeah,
So
we use
what kind of the material that you use in
ventilator,
this one?
just like at the factory roof, the ventilator that will be rotated by the wind.
I don't think so that it going work well, because you have to use maybe some materials when the difference of the thermals or the difference of the temperature from the lower ones must be more than 5 to 10 temperatures. Because I already simulate about its stack effects in Indonesia, and that is still not going well actually. So you have to be careful about this one. This is I don't know, this is the stack effect or wind catcher, because sometimes stack effects going to be wind catcher sometimes. So you need to be careful about that when this is going to be wind catcher. So you have to be careful about the temperature from outside.
Okay.
It's very, very hot.
Thank you.
Thank you very much.
I understand. So his kind suggestion is to apply the chimney effect on top of this, so that we can ensure the temperature difference between the top part and the lower part. I understand. Thank you very much for your constructive comment. So very last question. I think Mr. Kodak, I think. Yes, sure. I hope.
Thank you. I just give information about site of the new building. Mas, tampilkan yang site plan, Mas. Terus. Ya, stop. Okay. You can see that beside this site, you can see small river. Yeah, and based on information from a local public work, they will build a new road there for inspection and maintenance for the river. So please make a properly distance between building and the small river. And the other information is I have already said to Pak Yusing. Yeah, okay, and the other one is about what Pak Marioko said, that actually for building rule or perhaps until local law for building, I think it's not so easy. So I think we will need long time discuss about that. Okay, thank you.
All right, Jan, thank you so much. So I think we need to end the session. So yes, thank you very much once again. And then let's continuously do this kind of constructive discussion towards the standardization. Okay. So once again, thank you very much for your cooperation. Thank you.
Thank you very much, Prof. Kubota, for sharing this session. Ladies and gentlemen, please applause once again for Professor Kubota and all the speakers in this session. Ladies and gentlemen, we are now in the end of the seminar. To mark the end of the seminar, Director for Settlements and Housing Development Engineering, that will be represented by the Head of Subdirectorate of Infrastructure Technology and Equipment, Pak Sugeng Parianto, will deliver the closing speech. Pak Sugeng, time is yours.
Baik, Mohon izin ya menyampaikan sambutan Bu Direktur. Hari ini Bu Direktur mendadak harus mengikuti rapat dengar pendapat dengan DPR. Jadi mungkin mohon izin saya sampaikan. Baik, terima kasih. The Honorable Director General of Human Settlement, representative of GST, representative of Jaya, keynote speaker, Prof. Cian Enrica, Professor Prasasto Satwiko, and architect using, professor from both Indonesian and Japan University, guests and participants. Assalamualaikum warahmatullahi wabarakatuh. Let praise the good Almighty, whose His blessing can lead us the Venice Satrap Conference. Also, this is a pre-event to the World Habitat Day and World City Day entitled Low Carbon Affordable Houses for Sustainable Society. Ladies and gentlemen, throughout the course of the seminar, we have been witness to convergence of mind, a meeting of experts and stakeholders and fusion of ideas. Within this today, we discuss many things related to low carbon affordable houses in wide spectrum. I also would like to express my appreciation to our counterpart and collaborator, Jaya, GST and Hiroshima University, Universitas Indonesia, Institut Teknologi Bandung, Universitas Pendidikan Indonesia, Universitas Gajah Mada, Institut Teknologi 10 November Surabaya, Universitas Brawijaya, Tokyo Institute of Technology, Waseda University, Shinshu University, and Kagoshima University for your continued support. I extend my gratitude to Rockwool, Waikiki AP, AGC Company for giving the most support to the seminar as well as this project. I also would like to deliver my thanks to all organizing committee for organizing this today's seminar. Your dedication has brought this seminar to life. And we say, Alhamdulillahirabbil alamin. We close this seminar. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you. Thank you very much, Pak Agung, for closing the seminar officially. And now there is an announcement from Dr. Ariel about field trip to Semarang Old Town. Thank you.
Good evening, everyone. Good afternoon, probably. Yeah. Thank you very much for joining today's seminar. I hope you get something here, and we are very appreciate for your kindly support, your attendance, your actively involvement in our discussion, our project, and so on and so forth. So, I'd like to, as I mentioned before, that we are arranging field trip, social visit to the Kota Tua. Kota Tua is in English Old Town, probably, yeah, of Semarang. This is from the probably 18th centuries or 17th centuries, 300 years ago. So I believe you will enjoy. We provide the shuttle bus. Unfortunately, this bus, it seems not sufficient to just a single departure, so we will divide into two. We are categorize this one. I'm sorry to probably separate you with your friend and with your colleagues. We are very sorry, but this is the arrangement from our team. So please take a look, see your name and batch 1 or batch 2. Okay. Can you show the yes, a batch, not batch. Okay. One of us for the committee will join in the first in the bus. of course. And then we will drop off you in the parking lot of bus, Burani ya. Parking lot in the bus, and then we will just enjoy the old city. In the program book, you can find some our suggestion for just sightseeing. And if you want to go buy some souvenir, you can go to the snack shop, a traditional snack shop, or batik. If you want to buy some unique batik from Semarang, we also put some guidance to go there. But the most important is our trip, unfortunately, we have to stop by 8 p.m. I hope it is enough for you to enjoy the old city area. And unfortunately, we do not provide guide, right? Okay. So I'm sorry in Bahasa Indonesia, but I think most of you Japanese already know this Bahasa Indonesia, right? Yeah, we just drop and then we will probably walking together. Either you want to walking in group or in the large group, it's okay. And the bus will take you back to your own hotel. But we have to gather in the parking lot at 8 p.m. With the route of the hotel, Novotel, Holiday Inn, 5 Hotel, and the last is this hotel. Okay? If you have any inquiry, so you have any inquiry or some assistance or something, please contact Isnisan in this number. Okay, if you want to go home earlier or maybe you want to stay longer there, please just enjoy yourself. Okay, bis sudah siap ya? Oh my God. Okay, I'm sorry. This is some because the bus still, so some of our guests also will be, how to say, transport by expander, Mitsubishi expander, Toyota Innova. Okay? Okay, ada I don't know, Aoshima sang, Pondo sang, Windy sang, Emir sang. Okay. Any questions? Any questions? If not, because the shuttle bus is already there, available. Once again, I, on behalf of the organizing committee and also the Ministry of Public Works and Housing, Pak Sugeng ya, deeply express our gratitude, our thanks to all of you to attend this wonderful meeting, and we hope we meet again someday. Tomorrow, in Tegal. Okay, and if we have some mistake, even please forgive us. Okay, now Pak Sugeng already closed the seminar, so I close again. One more information. Sumimasen. For participant of JCC tomorrow to Tegal, this is the route. We will pick you with shuttle bus. Start from Novotel at 7:15, 7:30 in Holiday Inn, 7:40 in 5 Hotel, and 8 a.m. in Patra. Please, and the list of the, okay, we already have the list, so no worry, just please.
Has been delivered. We would like to extend once again our appreciation to the Director General of Human Settlements, Director of Engineering Development for Human Settlements and Housing, representative of GAST, representative of Jaya. We also thanks to all moderators and speakers for today's session. And for all the sponsors, our deepest gratitude to Rakul, YKKAP, and AGC for their support in this seminar. The highly appreciation also given all to the committee members who are make the seminar possible. Thank you for your hard working. Thank you for your kind attention, and we hope we can meet again in the future seminar or in the future collaboration. Thank you, have a nice day.